Summit 2023. My name is Karen Shea, and I am an intellectual property lawyer currently working at Amazon. It is an honor to be here today as your host of Taiwan Tech Summit. The Taiwan Tech Summit is a cross-border, cross-generational, and cross-industry technology extravaganza featuring the participation of over 100 organizations and corporations. The theme for this year's summit is Next Vision. And in line with that, we are excited to explore the future of technology through 5 major sections and activities: Innovation Forums, Taiwan Demo Day, Career Expo, Career Workshop, and networking events. This summit will be a wonderful opportunity for you to learn about the latest technology trends, network with industry leaders, and collaborate on innovative projects. The Taiwan Tech Summit is a star-studded affair. To start, Taiwan's Vice President, Liaw, has sent a congratulatory message expressing his support for the Taiwan Tech Summit. In addition, we are joined today by, and will hear from our distinguished Taiwanese leaders, Director General Ming-Chi Lai from the Taipei Economic and Cultural Office, TAECO, in San Francisco, Director Ya-Shu Zhuang from the Cultural Center of TAECO, San Francisco, Minister Ming-Shin Kong from the National Development Council, and David Wang, the CEO of Taiwania Capital and Chair of our Advisory Board. We will also hear from our impressive keynote speakers, Wally Liaw, the Senior Vice President and co-founder of SuperMicro, Vivian Lien, the Vice President and General Manager of Intel's Business Group, and Sony Xiao, the founder and CEO of Acepodia. Additionally, the summit will feature a variety of innovation forums on AI and data, biotech, hardware, investment, AI and cybersecurity, and generative AI. Finally, we are hosting Taiwan Demo Day, professional networking events, and a Career Expo workshop. With such an impressive lineup of speakers and events, it is no wonder that the summit has attracted so many talented and outstanding individuals like you from both the US and Taiwan. We are all very excited for today's events and speakers. Now, we would like to invite Katie Shea, Xie Kai-ting, Chair and founder of, and the driving force behind the Taiwan Tech Summit. She initiated and founded the summit with the aim of uniting all Taiwanese associations in the United States, leveraging and sharing resources within the Taiwanese community, assisting Taiwanese individuals to establish themselves in the US, and most importantly, sharing her deep love for Taiwan. Let's give her a warm welcome.
Hi, good morning. How are you? Okay. Hi, my name is Katie Xie, and I'm the founder and the chair of the Taiwan Tech Summit 2023. I'm also an entrepreneur and an angel investor and a founder of Taiwan Next Foundation. The goal of Taiwan Tech Summit is to build an ecosystem to connect Taiwanese professionals across industries through multi-generations and around the world. We want to unite all of the Taiwanese in the US and Taiwan and build a very strong network and a database to support each other. Oh, yeah. And I appreciate my partners, Taiwan Data Science Meetup, and then Big Global, the Bay Area Taiwan Biotech Association, BayBot, and then the North American Taiwanese Engineering Association, NATIA, the Next Foundation, and the Southern California Yushan Science and Technology Association is CMJ. And also, I'm glad for that there are over 100 volunteers to join our operation team. It's amazing, and our awesome team realized the spirit of digital democracy. Each organization planned and was in charge of one forum or a keynote. They did amazing jobs for the summit. Also, I would like to express my gratitude here to the important guests and the sponsors and who have contributed significantly to the 2023 Taiwan Tech Summit, including Taiwan's Vice President Lai Ching-de, Director General Ming-Chi Lai from the Taipei Economic and Cultural Office in San Francisco, and CEO Mr. David Wang from Taiwan Capital. Mr. Wang is also our advisory board chair. He guided and supported Taiwan Tech Summit so much. I truly appreciate Mr. Wang from my heart. This year, we have a Taiwan Demo Day, guided by the National Development Council and supported by Startup Island Taiwan, and organized by Make Global, which is a dedicated platform for startups. Also, we have a career workshop and networking events to assist more Taiwanese connect with across industries. Special thanks to SuperMicro, Intel, Spokeo, Cadence, and also supported the Taiwan Tech Summit very much this year. I also want to say thank you to all of the alliance partners and the media partners. There are over 100 organizations and the media attending the summit from the Bay Area, Los Angeles, Seattle, Washington, D.C., New York, Boston, and Chicago, Texas. I'm so touched that we can get very strong support from every partner. Thanks again, and thanks everyone for coming. And we appreciate your great support for this Taiwanese event. Enjoy the event. Thank you.
Thank you so much, Katie. We appreciate you. So now, we have a congratulatory message from Taiwan's Vice President Lai Ching-de. Vice President Lai has personally expressed his support for the Taiwan Tech Summit, which we greatly appreciate. He believes that by combining Taiwan's innovation, robust technological ecosystem, and the ability to connect with the world, we can create a brighter future together. So here's a message. So thank you to Vice President Lai for his message. We would now like to invite Director General Ming-Chi Lai Ming-Chi, from the Taipei Economic and Cultural Office, TAECO, in San Francisco to come on stage and share a few words with us. Please welcome Director General Lai.
Chair Xie, distinguished guests, ladies and gentlemen, good morning. I'm Scott Lai, Director General of the Taipei Economic and Cultural Office in San Francisco, which represents government of ROC Taiwan. This morning, I was supposed to fly to Las Vegas. Due to the importance of this event and a free lunch, I canceled the trip. However, in order to make sure that I will be invited next year, I will talk as short as possible. First, I'd like to, on behalf of Taiwan government, to congratulate the Taiwan Next Foundation on holding this event to coordinate the science technology industry in Taiwan and to promote investment and exchanges between Taiwan and California, or to be more specific, between Taiwan and the Silicon Valley. For your information, there are more than 1,500 Taiwan companies set up their branch office in California. And in Silicon Valley alone, more than 100 big Taiwan companies have their branch office here. And why Silicon Valley? That's because Silicon Valley is the heart of innovation, startups, AI, semiconductor, and also aerospace science technology industry. In one word, Silicon Valley is the engine of economic momentum in California. And most importantly, Silicon Valley has lots of talented people like every one of you today. And second, as we know, the economic relations between Taiwan and California are very close. Two-way trade volume is about $33 billion US. But I'm very sorry to say that Taiwan will enjoy a trade surplus about 10 billion. That is why my wife always goes shopping, try to balance the deficit. And I'd like to take this opportunity to thank every one of you for your support. Because of your support, not only we have fostered the relationship between technology professionals and corporations on each side of the Pacific Ocean, but also we have helped promote relations between Taiwan and California, or to be more specific, between Taiwan and Silicon Valley. And I thank you for doing my job without pay. And once again, thank you for your invitation. I wish the event great success and everyone a wonderful time. Thank you. Thank you very much.
Thank you, Director General Lai. That was really, really amazing. We now have a video message from another special guest. We are honored to have Minister Gong Mingxing from the National Development Council to share a few words with us. Please join me in welcoming Minister Kong.
Dear ladies and gentlemen, welcome you to Taiwan Tech Summit. Last year, we had over 1,000 people come and so much good feedback, showing Taiwan and the US are connecting after a long period of lockdown. I'm happy to hear the summit happening once again. In recent years, I believe you can see Taiwan and the US have more communication and collaboration. A big event like Taiwan Tech Summit is very important. I'm happy to know this year the summit is going bigger, including more industries, topics, and the 10 staff from Taiwan are going to pitch on the stage. I'm sure you will all get new insight, exchange ideas, and make plans that give you the power to make change and impact together. This is an important time for Taiwan to empower connections with the US. We will continue the efforts with the National Star Brand, Star Island Taiwan, and the Asian Silicon Valley Development Plan. To each of you at this event, you are also very important for this mission. Thank you for being here. Thank you for supporting this event. And I hope you have a successful summit.
Thank you, Minister Kong, for his message. Now, I would like to invite Mr. David Wang Jiashen, the CEO of Taiwania Capital and chair of our advisory board, to share a few words. Mr. Wang is a respected leader in the technology industry, and his contributions to Taiwan and the Taiwan Tech Summit have been invaluable. He has provided us with great support and guidance, and we are grateful for his commitment to the success of this event. We are honored to have him join us this year. Please welcome Mr. Wang.
First of all, I would like to thank you, the foundation, and also for the gracious introduction. Since I have been here for a long time, but many of you may not know me, I moved to Silicon Valley and came to study since 1981. 8 years ago, I received a phone call from Taiwan, which is the Minister Gong from the think tank. And really, we start from the whiteboard to the business PowerPoint, and we draw the Asia Silicon Valley Initiative, which is we want to transform Taiwan's economy from an efficient-based economy to an innovation-based economy. As of today, you can see there are so many startups, so many investment arms already established in Taiwan. And according to IMF, Taiwan is becoming an innovation country. It ranked at number 4. And in terms of productivity, in terms of the new emerging technology, we are truly the leader. And because of the Asia Silicon Valley Initiative, we also have an investment arm created, funded by National Development Council. And we start building from scratch. Once more, we start from the scratch. And now we have a 6 fund exist and already doing the investment, not just in Silicon Valley or East Coast. We are expanding our influence to the East, Central and Eastern European. Soon, we are going to have a Southeast Asia fund as well. Through the investment, we want to connect the world. We want to have an innovation technology which Taiwan doesn't have. How can we leverage it? How can we collaborate and become a part of the Taiwan and landing in Taiwan? For the past years, we all experienced the COVID impact and also the supply chain change. Not just like that. I think we also have emerging technology. Every 10 years, we see a big wave. When I was here in the 80s, I see the microprocessor coming up, the personal computer, the notebook. In the 90s, we see the internet emerged. And after year 2000, we see the mobility. Every 10 years, you see a big wave just like that. And I think Silicon Valley is becoming the center of innovation in the world. And we certainly want to leverage what all the talents here, just like you today. I think we have entrepreneurs, we have scientists, we have engineers who are all well trained and who has experience can contribute to the growth of Taiwan. You know, one thing I want to do is just do the right thing for Taiwan. And that's the passion that we have. And I do believe Taiwan, this tech summit is very important platform for us to all work together. And I think we can work together and walk a long way for the next generation to come. Last night, I came back from Tokyo. There's also the similar summit that we brought 41 startup teams from Taiwan to Japan. And I think that Japan also want to, have an innovation momentum like Taiwan, and they declared that's the year 1 for Japan to becoming a more innovation-based economy, and we have been doing that for 7 years. So today, I'm very glad to be back here, and I think this is a very important forum for all of us to contribute. I do want to build a bridge between Silicon Valley, Taiwan, and beyond, and I think you will play an important role, like I have done for the past 7-8 years. I also invite a lot of entrepreneurs and a lot of the experienced scientists or engineers to start up in Taiwan. And together, I think we can make a difference. And I hope that you have a fruitful and very productive days and make networks. Thank you very much.
And we ask thank you so much, Mr. Wang, and we ask you to please stay on stage for a moment. We are now going to have a group photo. So please welcome our founder, CEO, Katie Shea. Please come up. We would also like to invite Director General Lai and Director Zhuang of TECO San Francisco to come up stage. We would also like to invite the Taiwan Data Science Meetup, Meet Global, the Bay Area, Taiwan Biotech Association, BATBA, the North American Taiwanese Engineering Association, NATIA, the Next Foundation, and the Southern California Yushan Science and Technology Association to please all come up stage. And we want to give our special thanks to SuperMicro, Intel, Spokeo, and Kden. Please join us on stage. Once again, thank you to our Taiwan Tech Summit Chair, Katie Hsieh, TACO Director General Lai, Taiwania Capital CEO Wang, as well as our co-organizers and sponsors. We will now proceed to the media interview session. Interviewees, please join the media at the theater entrance for interviews. We kindly request the staff to guide them there. So, it is now time to kick off our main event, the official start of the Taiwan Tech Summit forums and keynote events. The first forum is organized by the Taiwan Data Science Meetup and has a theme of unleashing the power of AI and human augmentation for a smarter future. The speakers for this session include Chu-Cheng Hsieh, Chen-Ping Yu, and Wei-Cheng Wang, with Nina as the moderator. And Nina is the co-founder of Taiwan Data Science Meetup. And I will now let Nina take over. So once again, thank you to all our distinguished and wonderful guests for joining us today. Please stay tuned for... Sorry about that. And so stay tuned for the exciting forums and programs scheduled throughout the day. Thank you.
Hello, can everybody hear me? Cool. Can you hear me? Yes, thank you. Thank you for being here on a Saturday. It's not like you're missing out because it's overcast outside. And today's gonna be very informative, very valuable. And then there's a lot of forums that we're going to go through today. And then don't forget to go to networking, career expos, and then a lot of vendors out there. So take your time, enjoy today. And so today, welcome to our first panel discussion, our forum, AI and Data Science Forum. Our topic today is AI and Human Augmentation. I'm your host, Nina Chen. I am co-founder of Data Science Associations and then Taiwanese Data Science Meetup with 32,000 members on Facebook group, along with my co-founder, Qi Guan. And then it's organization that's dedicated in connecting and cultivating DS talents amongst the Taiwanese community. So if you're not part of it, definitely make sure to join. And today it's my pleasure to be on the stage with these three seasoned AI DS practitioners. And then with me, we have Chu-Cheng Hsieh. He's Chief Technology Officer at Shein US. And we have Chen-Ping Yu, Engineering Manager at Google. And then we also have Wei-Cheng Wang, Chief Marketing Officer and GM at Cadence Mobile. So today we're going to talk about AI. And artificial intelligence has been a really hot topic today or this year. And I'm pretty sure people in the audience, you probably have used and played ChatGPT, and maybe asking questions such as, what is the meaning of life? Or giving it prompts to things like, write me an opening for a panel discussions I'm hosting. Today we're honored to have these practitioners on stage where we'll talk about how AI has brought really brought convenience to our life and also created opportunities in various different business sectors. And we'll also talk about what are some of the concerns or risks that keep them up at night, as well as give advice to people who are wishing to pursue a career in AI. So without further ado, I know I've been talking a lot. I'm going to pass the microphone over. Can you all tell us a little bit about yourself? What do you do and how is it related to AI?
Hi, everyone. My name is Chen-Ping. Really happy to be here. My background is primarily in computer vision, machine learning research. I became an entrepreneur about six years ago. I was the founder of Fire, an AI-powered AR navigation software company over 6 years, and now I'm at Google. Really excited to share some experience with everyone.
Well, good morning, San Francisco. I came all the way from Southern California. My name is Wei-Cheng Wang. Thank you very much, Nina, for your kind introduction. I do possess a somewhat different background because I'm an academically trained economist. And as Nina said, that I am the co-founder and currently carrying the title of Chief Marketing Officer at KDM Mobile Software. Very glad to be here. Now, with respect to artificial intelligence and data science, I think we all know that the change is coming. But I wanted to say that I bring maybe a somewhat different perspective to the table, because I wanted to focus a little bit more on the commercial applications rather than talking about like hardcore engineering stuff, because obviously that's not my background. But I think that we're gonna have. I will have an opportunity to learn a lot, from this particular panel as well as from the networking opportunities with all of you, and I look forward to that.
Yeah, thank you all for joining us today. So our first question for today is, so AI applications and programs has been around has been seeing huge growth in recent years. But actually the research and development has been going on for many, many decades. So I'm also curious, what do you see have been the most breakthrough or advancement in the past decades? And what do you think, how have they shaped our life or the industry?
Nina, I'm sorry I have to ask. Can you repeat the question again?
So what are some of the breakthrough advancements you've seen
Right.
that, and how have they shaped our lives or business?
Right. So on the more historic and technical side, I think what really made AI what it is today started with 2 or 3 major things. One is the beginning of deep learning back in 2012. That started with a paper, I think it was called ImageNet Classification with Deep Convolutional Neural Networks. And that word deep is what really coined to deep learning. And several authors on that paper, really, really important. The first person is Alex Krzyzewski. His name became the name of AlexNet, the network that paper created, which is the foundation network for most deep learning networks ever since. And the first GPU implementation of deep neural network, which now everything uses the GPU. The second author on that paper is also very interesting. His name is Ilya Sutskever, I believe. He is the co-founder and chief scientist at OpenAI. So recently there's a news about how I think Elon Musk poached him from Google, and that Larry Page was really unhappy about that. And I think that's the guy. And the third person, Jeffrey Hinton, was a godfather in the AI area. So that paper was defining. And then the transformer paper that happened, I think 2017, that came out of Google. And why is that really important? Because that is the backbone of what GPT is. ChatGPT, as we all know, GPT actually stands for Generative Pre-trained Transformer. And that's because of the transformer architecture, which allowed long-term dependency to be to be kind of solved in a language model. And then we have now ChatGPT. So all these are kind of breakthroughs that happened during the history of the development. I think those are really important.
Actually, quick question. Can you repeat what does GPT stand for?
Yes.
I don't know.
GPT, all important, all the keywords now are all the buzzwords. The first G is generative AI, generative. P as a pre-trained, and then T is transformer.
Okay, thank you. Quick round of applause. Who knows GPT stand for? Raise your hand. Okay, decent amount, some amount, okay. Yeah, so now you all learned something, first learning of the day. Keep making notes. Thank you.
Yeah, well, so like I said, I mean, I have a somewhat layman's perspective, right? Because I want to talk about perspectives from a random average Joe that you would bump in the street, like me, myself, right? So I think AI is very new, although it's not something that's brand new. I think we all have, people sitting on this stage or in the audience have all had their fair share of experiences interacting with robots on the phone, right? We all want to get to that customer representative, but there will be a voice that try to guide you through and try to categorize what your questions might be, right? And then it wasn't until maybe, like you said, 2012, deep learning was introduced, and then there were more applications that were being developed, right? The other day I was playing on my iPhone, trying to look for the pictures of my son, and I click on the kind of like the portrait of my son, and my younger son popped up. And then my image also popped up. And I was like, oh, okay, yeah, we're from the same factory, I guess. So I think the deep, I guess the deep learning really helped, proliferate the applications that we're currently using. I think the deep breakthrough for people like you and I is really the ChatGPT, because you now have an understanding, knowing that there are limitless possibilities created by the machines that allows you and enables you to really interact to accomplish things that you previously wouldn't imagine that you could accomplish.
Yeah, and I can tell that you're really excited we're all pretty excited for this technology. And then there's actually some concerning thoughts, or on the flip side, we're going to talk about in just a bit. But before we get into there, I'm also curious, so we talked about some of the impact to our daily lives, but what about some of the like examples that you've seen that has been commercially successful, maybe in your respective areas, like retail, e-commerce, VR, self-driving, or B2B and project management part?
So I'll try to take that on first. As the theme suggests, that we're talking about artificial intelligence and human augmentation, right? So from my perspective, I supervise a team, oversee a team, and I always tell the team, you make sure that you leverage the existing tools out there to save your time, right? Because we want to save our precious time to do the things that could create the most value, right? And I think, from my perspective, is the document services, the support services, or the services that AI could help us, really eliminate the mundane type of work and really to give the time back to us, right? There are companies and applications out there that try to take that on and has been very successful, right? There's a company called Flexport, right? So for example, it's a stevedoring company, basically managing logistics. We actually have a startup company in Taiwan that does similar things, like Go Freight. I'm not sure whether you've heard Go Freight or not. I think Go Freight might be also a Taiwanese portfolio company. What they do is they make sure that there's no, maintain the highest level of efficiency, making sure that logistics of the vessels are being managed properly. And previously, it's very difficult to do because people have to deal with the differences in time zones when you're shipping goods from different continents, and then after the cargo arrives, you have to make arrangements for ground transportation, and all this takes a lot of time. And sometimes there is a huge amount of efficiency loss. Right? Support services, like the customer support example that I gave you, all those things are what AI could augment. What us humans do. And I think really that's the valuable part. Obviously, there are more advanced challenges that AI could help us solve. But I think, from the commercial perspective, that's what, most people are looking for.
Thank you.
AI, I think there's a lot of application, especially revolutionized or enabled things like self-driving a couple of years ago. I want to say it's a couple of years ago because it used to be very, very popular. And then until all the companies kind of went out of business a couple of years ago. I think what's left right now is Cruise and Waymo.
Waymo, yes, they're everywhere in San Francisco.
Yeah. And I'm glad that there's still some of them around. But if it wasn't because of AI, there wouldn't have even been a boom of self-driving. You have to be able to recognize the road, the lanes, where the car should drive to, how to avoid obstacles, and all in real time, and at a very high accuracy. So that's computer vision AI at its finest. But sadly, yeah, it's now it's kind of old tech because now the new thing is generative AI, and that's okay. There's also a lot of AI is also really useful for VR, AR. Oculus, even though you use the stick controller, but they also do allow you to use your hand gesture to kind of move and interact with VR elements. And that's using computer vision, again, in real time. And it has to be in a very, very low latency, so you don't really, you don't even realize that it's detecting your hand, and you feel that it's almost instantaneous. And that's the same for the Vision Pro headset that Apple kind of unveiled a couple months ago, that they were showing the different gesture-controlled applications, right? So that's also very important. And scanning a room to be able to actually place AR elements in front of you or on the tabletop. These are all computer vision AI. So these are also really the AI that's working underneath the hood, that enabling these important areas.
Yeah, and then it sounds like what we've talked about are a lot of the AI that's based on kind of the supervised learnings, and we're just kind of on the cusp of seeing how general AI is being adopted in the industry or being an opportunity to be addressed by AI in our daily lives. And when we talked about AI, I think people a lot of time think of Andrew Chang, and in his recent research, or that he stated that a lot of these value capture opportunities are lies in the daily life or the use cases where AI can address as a general technology, and then that in return can also fuel the development of the infrastructure or the hardware layers. So I'm also curious in terms of the market / application layers, which is the things that we use or in business use. Where do you see are the next biggest opportunity for general AI to be addressed, which can also continue to be adopted and advance the AI kind of advancement?
I think that the opportunity definitely exists in the data ownership, data transactions, because it doesn't matter what application that you want to develop, but what technology you want to develop, you need the foundation of data, right? And obviously, I can understand where Andrew Chang comes from. He obviously wants to sell more chips, so he's gonna be super hyped on AI. But I argue there might be two focuses going forward. Number one is the data ownership and the transactions related to data, because that's going to drive the algorithm, that's going to drive the input and the quality of output, right? And the second one might be commercialization, right? So the AR, VR opportunities seem very cool. So happy to report that, I've driven cars that with the VR, with the, what is that called? The dashboard display on display or something like that, that gives me the speed limit as well as the direction of GPS.
Yeah, the heads-up display.
Yeah, heads-up display, correct. So the heads-up display is an add-on, right? It doesn't affect the main functionality of the car, but it asks users to actually pay a little extra to get that functionality, although cool, but it doesn't affect the main functionality. So I'm waiting to see whether or not AI could help create and promote products and services that we must have instead of being just an ancillary service. So it goes back to the commercialization. Like, how do we develop applications that are so, I want to say, prevalent or universal that we cannot avoid? And then when developing those commercialized opportunities, can we also identify the opportunities in the foundation, right? And there are obviously players in the industry, and I argue, like, for example, the finance industry, the healthcare industry, or the software industry, not only they have recurring transactional data, they have user behavior data. So they're basically sitting on the gold mine, right? There might be other industries that share very similar characteristics, but I think the fact that they have access to data would potentially enable them to participate in data transactions, or maybe allow them to develop AI related applications that could be later commercialized. So those are, I think, personally, where the opportunities are.
Well, side note, personally, I think we still need a person customer service, ultimately for that angry person who just can't get through their phone.
Are you that angry person?
Yes. I was trying to connect to some customer service yesterday and be like waiting on the phone for 5 minutes, 10 minutes. And people working with like mobile services probably wait even longer. But anyway, side notes. Ping, anything?
I also think there's a lot of opportunity on the applications of generative AI side, but then we're eating into the generative AI section too much, which is a later section. So I'm kind of come back to AR, VR.
Who cares about them?
I didn't say that. So yeah, I still think AR, VR is, even though metaverse is kind of a very polarized, people has polarized opinions about metaverse. but it is an opportunity if Meta can really build it well and can build a better hardware and to enable better user experience. And that will allow a lot of AI technologies and applications to enable better interaction, better user experience for the metaverse, or Vision Pro for AR. And because there's, again, like I said, there's a lot of AI involved in order for you to feel like there's actual something augmented reality in front of you that feels like part of the real world. And in order for that to happen, there's many parts of AI that has to run in real time at the same time and in a very small form factor using a very small chipset. As we all know, ChatGPT, it takes, these type of models take many GPUs to run, and that's very expensive. But when you have an AR, VR device like a headset, you don't have that many GPUs. In fact, you have like a Qualcomm chip in it, and that has to sustain all the computation. So I think there's a lot of AI opportunities for VR.
Do you think the hurdle is with the computing power and to avoid the latency and to better the user experience?
Both, I think. Qualcomm and the chip makers, they're trying to make more powerful AI-specific accelerator chipsets. But at the same time, a lot of researchers are trying to distill and lessen the size of the neural networks so that they don't require that many GPUs to run. So both are advancing at the same time.
Well, thank you. And as we talk about a lot of the AI advancement, exciting applications and opportunities, people are oftentimes also start thinking about, it also raises some concerns around how is AI impacting our life and negatively. So things such as privacy infringement, such as intellectual property ownership, and even job security. And that risk could also be impacting a very different demographic or professions compared to the previous industrial revolutions or previous internet, Web 2.0. So I'm also curious, as you're thinking or advancing and doing your work on your job, seeing these AI technology being advancing, what keeps you up at night when thinking about how is AI impacting our lives?
Before I talk about what keeps me up at night, I wanted
Besides
to share,
your kids.
Yeah, right. Exactly. I wanted to kind of share the optimistic economist perspective, right? So the introduction of new technology is not new. In the beginning of the 20th century, when we first introduced the agriculture machine, at the time, the amount of employment that we have in the agriculture sector was probably over 50%. And then right now, if you look at the agriculture sector, we have less than 2% of the labor force working in the agriculture sector, but there's no shortage of food. And we don't have that much unemployment. I mean, last time I checked, the unemployment rate was like 3.7%, right? So, and fast forward to 1970, first, when we introduced ATM machines, all the bank tellers were freaking out, right? My aunt retired in the early 90s because she didn't want to deal with this new thing called email. Right? And I imagine 20 years from now, looking back, we would laugh at the AI thing that we're talking about right now, thinking, yeah, this is a common stuff, right? So that's the optimistic economist perspective, letting you know that people are, I think, creative enough, human beings are creative enough that we will always find a way. What keeps me up at night is that I don't think that people understand what it takes for AI to be improved upon or more efficient and effective. In order for AI to understand you more, you have to compromise on the privacy, right? So think about ChatGPT. The reason why ChatGPT could provide you with that much content is simply because there is a machine working behind the scene trying to crawl data, right? And if you own a website, you don't want ChatGPT to crawl through or comb through whatever your website has. You could actually block it, just focus on GPT bot, and you don't let GPT bot, and there are ports that you could actually lock up. But here's the thing, like for people like you and I, sometimes we don't even know that we have given up our privacy. Sometimes that option wasn't made very obvious to us, and for the sake of inconvenience. So how much are we willing to give up in terms of privacy to accomplish the next level convenience is my question, right? And I think that is a topic ultra sensitive in the United States, right? In Asia, not so much. Like people are currently developing AI applications without thinking about, how important it is the notion of privacy, right? So, and I think that's also a cultural difference.
Yeah, I'm sensing a little bit of argument or debate between the collectivism versus individualism, like how much you're willing to give to get benefited in your daily life.
Absolutely.
I'm really worried about AI taking over the world. I'm just gonna say it. And that's also a polarized topic between some big names.
Right.
I think Elon Musk and somebody else, they take opposite opinions. And as a former researcher in AI, I was working on computer vision, and I remember a couple of years ago when this discussion was really, really hot. And that was before ChatGPT, and I was thinking, well, we're still trying to figure out where the lanes are, where the roads are, and trying to get 70% accuracy in detecting objects. We're so far from AI being dangerous to us or even being conscious. That's just, we don't need to worry about that. And then ChatGPT happened. That totally blew my mind. I never really thought about we can actually mimic consciousness, mimic logic and reasoning through learning through a language model that learns from a bunch of texts. It's so good at regurgitating what it's learned, but it mimics consciousness, and that really changed. It changed everything. And last year, I remember there was a paper from Facebook. I think it was called API something. So that basically what that neural network does was it's able to find, if you ask the network to do something for you, say to book an hotel for you, it will go find the proper API to make that API call to initiate this action for you. So what that means is it was not only able to answer your questions, it was able to find ways to execute on your based on your request. And that's very dangerous, because if AI is able to execute and find ways to execute on the request, if there is an API that leads to another API that leads to another API, eventually goes to a nuclear launch sequence, you can do it. And I would definitely imagine bad people trying to use that technology for such purpose. So, and unfortunately, a lot of times, what researchers care about is less about what people will use it for. It's more about, oh, I'm enabling a new breakthrough, I'm enabling a new technology, or I'm publishing this paper at Science, Nature, CVPR, I'm getting this many citations. It's really important for them to help us with the breakthrough, but at the same time, these breakthroughs are also very dangerous, and I don't see ways to prevent that, because it's just impossible for us to stop the progress. But at the same time, this progress is very concerning to me.
But do you think is there any guardrails that can be put in place by various different players in the ecosystem, government or private sectors or nonprofit? Thoughts?
I think that's in the works, but it really takes a lot of collaborations to really figure something out to be able to guardrail against these potential risks. Or not potential, I think very real risks.
Yeah.
I also worry about introducing too much regulatory influence into the things that we're developing at the same time, because there are people, including me myself, don't trust the government, right? So how far do you? Every time when we have some issues and concerns, we want to enlist government's help. Every time when the government wants our tax money, we said, leave us alone, right? So unfortunately, you can't pick and choose. If you want the government to come in, most likely they will come in and take over. So there is no borderline or gray zone. in their perspective. I mean, obviously from the recent conversations and discussions that are currently in the public domain, they want to take over. They want to have regulatory oversight in everything we do. And what keeps you at night really sends chills in my spine as well. I totally get it. But I argue, I think there is some sort of self-consciousness involved in this. Like researchers, they need to be trained in a more well-rounded manner. So they need to understand that there is supposed to be a humanistic perspective in this, trying to gatekeep the safety of human beings. But like you said, I mean, the researchers are being driven by impact factor and the amount of publication that they have. I mean, all of us sitting up here, we have academic backgrounds and we know how the game is played. We get that. But I don't think that in the entire education system, anywhere in the world, we have that built in. So people are not being trained in a well-rounded manner. They are pursuing whatever they want to pursue because they're driven by motivation and incentives.
Yeah.
I think it's a really great point about should we ask the kids to not use these tools until a certain age or not, or allow them to use it. I remember back when I was still running the startup, when we were interviewing our engineering candidates, our approach wasn't to test them coding. Well, we were testing them coding questions, but we were allowing them to use whatever they can use online as long as they can solve this coding problem. Because when you're at work, you have access to all the tools you have available. So we cared more about the problem-solving ability, and are you able to find the right tool to help you solve problems, which I think is kind of relevant to what you're talking about. But now that there are ChatGPTs that can write code for you, I'm not sure if that's a good idea anymore.
And it sounds like it's the destination or goals are all, the problems are the same. It's just how we get there are different. And then how we decide, or different generation or different background of people or professions, then we'll decide different solutions to get to that final problems. But it's the same thing. Yeah. And actually, Zhenping, echoing what you said, I think I'm kind of on the cusp or between the really excited, the technology enthusiast, but then also the kind of the pessimist. Especially, I think none of us actually talked about it, the potential impact to climate, to the planet, like the materials that we are using in building chips, and then the heat that we're generating from these data centers. So yeah, there's a lot of risk and concerns, but it sounds like it's all to take, best for us all come together and then have that dialogue to determine, okay, what's the best path forward? Okay. It's kind of heavy topic, so we're going to shift a little bit, probably more relevant to some of the attendees here. So AI and DS, and you've been in the industry for many, many years and have done a lot and seen a lot of talents. What would you say and advice that you would give for people who want to pursue or wishing to pursue a career in AI, especially for those that who are either just starting or just enter this field?
All right, I'll take it on. I mean, like I said, I mean, I possess a somewhat different background than you guys, because I am an economist. I did get my PhD in economics, and when I was in grad school, I had to code too. I had to use MATLAB. I no longer code.
MATLAB. Okay.
I no longer code, but I have long recognized the importance of data. Right. So economists, as you know, we heavily use econometrics model to deal with applied research. Back then, that was when the big data idea emerged. I didn't want to say years because that'll reveal my age. But when I was dealing with the data, I mean, everybody was so hyped about big data. And I look at my field, the econometrics research, for example, has existed for decades, right? So when we didn't have the quality of data, we had to resort to the explanation of biases. We have to get a very good handle on the biases before we can make meaningful predictions and forecasts. And then fast forward to 2014 or 15, I recognized and acknowledged the importance of data. So within my team, the marketing team at KDM Mobile Software, I started building a data team. So the data team focuses on the data analytics issue, right? So when I was hiring, I focused on trying to find talents with an aptitude in data, numbers. I was looking for people with numerical sense, right? If you recognize and acknowledge the importance of data, and then we could talk about something else, right? If you don't understand what data means, then this is probably not for you. And I would argue that in the business world, it doesn't matter what position you are, what function you are, you're probably going to find it very difficult to steer away from data, right? So yes, I understand that I'm supposed to be giving you career advice on pursuing a field in data science. And I think all of you, knowing this is where your passion is, you have the aptitude, you have the numerical sense in data. But I would argue, in order for us to build a more effective linkage between the data science, the field of data science, and business applications, you need to be the translator. You need to be the one that could effectively communicate whatever concepts or insight that you could get and obtain from the data that you're dealing with, to let the leadership team know, to let the managers know, this is important. Let data drive your decision. So we talked about data-driven approach. Actually, I actually like the phrase better, data-validated approach. I like that phrase better than data-driven, because we're providing evidence and foundation for decision-making process, and that's how we drive progress.
Or data informed. I used to tell my team data informed versus data driven, because you want to gather enough information so then you can make informed decisions.
Right. So my career advice would be to really cultivate yourself with the sense of knowing communication is important. How do you communicate with people who are in the capacity of making decisions that your insight is actually valuable? Too many of us have stuck our head in the data, mining tasks, trying to identify trends and patterns without understanding. You know what? In order for us to get to the promised land, you gotta really communicate your insight more effectively.
The storytelling.
Correct.
Yeah. We'll do sequence. Yes.
We'll do this way.
Or rock, paper, scissors.
Okay, so I echo very much about data, understanding data, storytelling, super important. So since you covered the storytellers aspect, I'll cover more of if you want to get into AI, on the more engineering aspect, is that in order to really understand the data and tell an important story, how do you extract information, important information, and filter out the non-important information from the data you're working with? And that really depends on the wealth of AI techniques that you understand. So I view this almost like how you're kind of fighting a boss, a monster, like in 武侠小说. You have a lot of different techniques. Certain techniques work with this boss and certain does not. But if you only have one technique that you know, you're likely not going to be tackling a lot of battles. And so that's why you need to amass yourself with many, many techniques in order for you to know which techniques work with what kind of data, what kind of problem. And that way, whenever you have different kind of data you're working with, you'll be able to utilize this wealth of techniques that you know. And so that's why it's important to really get into learning and practicing and doing different projects using different AI techniques.
What are some of the top 3 technical techniques you think people should focus on now? You don't have to answer.
Yeah, I'm a former engineer, so I'm not a very good person to talk about that anymore, but that's a general idea.
Yes. Thank you.
I have one thing that I wanted to add. I think the current education system doesn't support what we're envisioning. Because you see,
would you like to go back to school?
Right? Yeah, right. Because everybody needs to pick a major, right? And within that major, you don't get to really open your mind, right? You have to eat up all these courses on the menu, which doesn't really cultivate your skills of trying to learn something that you don't know, like, right? I mean, right? Because, obviously jobs that existed 20 years ago don't exist today. And most likely jobs that will exist 20 years from now, right? You see what I mean? So we don't have an education system that allows all these young professionals to go out there and train themselves to learn things that they don't already know, because we're throwing things upon them. And I think that is the skill that I most value as a person sitting on the other end of the hiring table. And I think we all are. But I think it's a challenge, especially for young professionals, to demonstrate that skill of being adaptive, being willing to learn new things. Mm-hmm. How do you do that?
Challenging. Well, with that, thank you so much for the speakers today, and thank you all for being here. That's it for our forum. And if you want to hang out or meet our speakers and myself, we also have at 2:30 have a networking event hosted by DS Data Science Association. So thank you all. Let's give a round of applause to our speakers. Thank you.
Thank you.
Thank you.
不然他讲不出话来。从中间 ，OK， 这样可以了啊。这是否电视？啊，手电。Test 1 2 test 1 2。
everyone. We are starting our next event. Our first keynote speaker, Wally Liaw, will be speaking soon. So please take your seat as soon as possible. Thank you. Hi, everyone. We are starting soon. Please take your seats as soon as possible. Thank you. Please take your seats as soon as possible. We'll be starting in 1 minute. Thank you. Okay, now I'm going to invite Mr. David Wang and Mr. Wally Liaw to come up on stage. And we are now ready for our next event. It's a keynote event. Thank you.
Ladies and gentlemen, it's my honor to introduce our keynote speaker, Wally Liaw. Wally and I have known for many, many years, and along with Charles Liang, co-founder of SuperMicro. SuperMicro has emerging into a very one of the leaders in the data center in many aspects. Like we see the AI, machine learning, even the 5G communication has been a tremendous growth for over the last almost 30 years. Yes, and I think we'd like to hear the story, especially recently, they are becoming one of the fast-growing and also emerging leader in the AI area. So that's my honor to introduce Wally. Let's have a warm welcome to our keynote speaker, Wally. Thank you.
Thank you. Thank you for CEO Wen's kind introduction. 北美台湾科技年会谢主席、英文处赖主委、台杉风总经理、各领域的科技与会人士，大家好。Leon Katie, Director General Lai, CEO Wen, and all the participants, good morning. I'm so honored to be here for the keynote. So let me introduce. I'm Wally Liaw, co-founder of SuperMicro, Senior VP of Business Development. Yeah, today's topic is unveil the latest AI building block solutions and redefine performance at the edge computing. So I will do the company introduction, and my colleague Wally will do the product introduction. Yeah, so for the SuperMicro, I will do a few minutes to introduce, and our products we call Go Serious Solution for AI. Everyone knows GPT introduced just now, machine learning, LLM, and metaverse, and also SuperMicro offer the edge computing for AI inference training. So about SuperMicro. SuperMicro was founded in 1993. Three founders, Charles Liang, CEO and President, and Seda Liu and me. We are in San Jose, headquarters here. And we IPO at NASDAQ 2007. Symbol is SMCI. The company revenue last year, we ended at June 30th for our fiscal year. We reached 5.2 billion with 50% year-to-year growth. This year, end of June, we have 7.1 billion with 30% annual growth. And the coming 2024, end of June 2024, we expect targeted to be 10 billion. So we need everyone, if you can help us to grow. And SuperMicro, we have worldwide presence. We have more than 6 million square feet facility to help all the industries. We are here for sure. San Jose, we have 13 buildings. In Taiwan, we have 5 buildings plus a company office. And in the Netherlands, we have 3 buildings there, okay? And also we are building our Malaysia 100-acre factory there. So we will be ready in Q2 next year. This is our facility, and we have worldwide more than 5,000 employees. And the most important thing, we have more than 50% are technical and R&D. So SuperMicro enabling the total IT solutions. So that means for the data center, for the your server farms, we ship the total solution, and that means a higher value to our customers. For example, we have great scale plug and play. That means industry called L10, L11, or L12. with our optimized building block architecture solutions. So once the customer receives the rack from SuperMicro, there are only two cables they need to connect. One is a power cable, one is internet communication cable. So it's trouble-free for you. So this is our most optimized IT solution we are doing now. So with this, we have all the new products from Intel CPU, AMD CPU, and everyone know AI from NVIDIA. So let me tell you the detail also. So for our corporate expansions, as you know, San Jose is our headquarters. We have our green computing park. I will explain what mean green later. Next slide. So with this green in San Jose, in Taiwan, and the coming Malaysia factories, and more. So we can ship to worldwide 4,000 racks per month to service the AI data center environment. So what called green computer for the planet? Because we only have one Earth, our Mother Earth. We need to keep our Mother Earth more green, more healthy, without such much air pollution. So SuperMicro improves the industrial PUE. The PUE is the power usage. Like we say, target 1.05. What do you mean 1.05? Means only 5% is for non-IT related. If you have the experience, if you went into the data center, the first thing you feel is very cold. That's air conditioning. So computer need the air conditioning to cool it down. That almost take 30%, 40%, or even 50% of your expense for the air conditioning. So that is a waste your energy to create the heat, carbon. Okay. SuperMicro, we have the solution, no air conditioning. We call free air cooling. And this proved in San Jose, Santa Clara area. As you know, Intel have big facility in Santa Clara. And their EDA data centers use more than 600,000 nodes of SuperMicro SuperBlade solutions. And for those solutions, they don't use air conditioning. In that case, the PU can be 1.06. That means 6% only for the non-IT. So Intel here, they are more than welcome. If you like to build this kind of data center, Intel for sure more than willing to share with you and come out the solution with you and save all the analysts. And another one, we have the Green is computer in the F500. That means the preferred network. They are number one and use a SuperMicro solution. So we also offer the liquid cooling, submerged cooling. That can be up to 1.05, only 5%. So don't think 1% is very easy. Let's take a lot of effort from our engineers, design, thermal, everything. So with this only one or two to show you the success story, we calculate if you use SuperMicro server, SuperMicro racks, that will save you up to 10 billion of your expense. And if you convert to the switch, because the switch will take over the carbon. Okay, so that's equal. You can plan virtually 8 billion trees. That's more than trees in Taiwan, or in double or triple trees in Taiwan also. And if you don't have the idea, that's equal to remove 30 fossil power plants. We don't need so many because the server, free air, liquid cooling, that have the expense to be reduced. So we call green computing from SuperMicro can be free and with big bonus because we return to our mother Earth. And right now everyone know AI. AI is so hot. And I like to share a little bit idea. The partnership of SuperMicro and NVIDIA. This June compute test in Taipei, Johnson Huang, NVIDIA CEO, make a big wave to Taiwan. Everyone knows that it's a big wave for the AI. And SuperMicro CEO Charles Liang has keynote with Jensen. They are sharing all the benefit, all the solutions for AI from NVIDIA and from SuperMicro. And I just show you one picture. That is back to 17 years ago, 2006. We already QBR with NVIDIA. And in the middle is Jensen Huang. On the right-hand side is Charles Liang. And we together discussing about the development of GPU. And later, Jensen, interviewed by the media, they will say how we have we work together with NVIDIA for more than 20 years. One example on the right-hand side is in 2006, 2007 timeframe, NVIDIA GPU is just an add-on car. So they need one box to host the add-on car. And SuperMicro, 1U compute. So between 1U and GPU, you need 2 cables to connect together. And this is the design idea by that time. So people may say 2 cables only is not a big sense. But one will be okay if you have 200 or thousands server and GPU together. You can imagine so many cables together. So Charles and our R&D group come out the idea. How about merge the GPU to 1U? But that is space, thermal, all kinds of solution you need to conquer. So finally we come out 2 GPU in 1U. So we have a big press release with NVIDIA at the compute test by the time. So we are the very, very first one come out this design. So I will show you the video, only 40 seconds, not too long, okay? How Jensen, NVIDIA CEO, say, by that time, no one believes in GPU computing technology. Only Charles, SuperMicro CEO, have NVIDIA to build the world's first AI GPU. So this is media from Taiwan. So we will be English and Chinese, okay? Yeah.
First server he built with NVIDIA was a supercomputer. And at the time, nobody believed in accelerated computing, but Charles did. And so I'm very grateful for his friendship and support over the years.
两人一路走来，合作超过20年，不止黄仁勋成为赵元男，梁建后的身价也水涨船高。受惠 AI 浪潮来袭，美超微今年至今股价累计大涨约167%。美超微看望 AI 需求庞大，将带动辉达 H100伺服器出货提升，有望带动美超微今年营收上看200亿美元。三立新闻林淑贤、李文科 SNG。
Okay. Thank you. So the next one is the new products from NVIDIA. So NVIDIA designed their own CPU they call Grace. And GPU, for sure, everyone knows it's the H100 they call Hopper. So we are the only very first server solution who designed together with NVIDIA. So this is also only a 50-second video at NVIDIA Computex Taipei, their CEO keynote speak. So there you show you a little bit.
Here in Taiwan, let me show you one of them. This is from SuperMicro. Get my exercise in today. Whoosh. I am the sound effect. Okay. All right. So this is a SuperMicro server. You got BlueFlu 3, you got the CX7, you got the Grace Hopper. Okay. But there are so many systems. There are so many systems. So this is Grace Hopper. This is SuperMicro. There's so many systems. Let me show you some of them. And all of our partners, I'm so grateful. You're working on Grace, Grace Hopper, Hopper, L40s, L4s, BlueField 3s. Just about every single processor that we're building are configured into these servers of all different types. And so this is SuperMicro. This is
Okay, so this is a very short history for SuperMicro and the coming on SuperMicro Go serial products will be presented by Wally Lien, and hopefully we can work or we can promote together to get this huge AI wave, huge market. Thank you.
Good morning, everyone. 谢谢 Wally. I think this is a very great beginning session to talk about all the AI and data science in the previous panel discussion. They help us to understand about the data behind through the AI, and then also the concept and opportunities. And these two videos Wally just shared with all of you, covering the history, the deep partnership with NVIDIA, and also the latest innovations, and how to help the industry drive faster for the innovations. As an audience here, I believe most of you have a different perspective, including using apps, be a startup perspective to drive the AI. But you could be also the investor want to know how to purchase the right hardwares. So there are many different angles to look at this part. And as one of the leading company offering the solution to the industry, we would like to lay out certain of the features behind why we have to do this way for you. Before we start, I think there are a few messages we can align together. First of all, you need to understand the AI, it's a very powerful machine itself, can drive lots of solutions. But have you ever thought about that? One machine itself fully loaded for all the GPUs, how much does it cost? And it's actually multiple $100,000 per systems. Some of you, if you are the fan of the cards, I don't have that cards, but if you check the 2023 Lamborghini new cards, it's like the $200,000 to $300,000 for a card. We are talking about a product like that. And then that was because of this, a powerful machine costs a lot. So people carefully select what's the right business model to generate revenues, and also how to make sure the user will get benefit of that. I think one of the sessions Nina mentioned about to all of you, operators, they're offering the service to you. Sometimes you probably don't know you're talking to real person or the machines. And during the chapter box, they also will remind you you are talking to the robot. And all of this computing behind require the GPU. So there will be 3 products covering how it looks like. And also I will highlight certain features, what's the difference, and how we help the industry. Before we enter this segment here, you can recognize there are many racks here. And this rack is what Wally mentioned to all of you. In the data centers, lots of the density is the key to make sure all the computing power can be aggregated together in the past. But computing power in the past, most of them are centric, focused on the CPU, networking. However, GPU played a more and more important right now. We offering the possibility lending all kind of the GPU format. And those knowledge like the grasshopper and also other H100, those GPUs require the very solid thermal solutions, including the liquid cooling to combine them all together. You can recognize this machine have different form factors. For some of you are not familiar with the data center, it's just starting from a unit we call U. 1U, 2U, and total 42U rack you can calculate. You're only allowed to put 42 units. But in this 42U unit space, you can maximize the GPU become important factors. So you can recognize the density-wise, we can up to the 8U per machines, or you can provide in the 5U. In this space here, I think you can start to think about what kind of a machines are driving behind for the ChatGPT, AI, machine learning, large language modelings. You need to have the machine like this and look like a very, very powerful supercomputer. Itself is really like a supercomputer because on the top, you have all kind of a high density. They call the XGX GPU. So that means this GPU will be on board, on the tray, like you can recognize here. And on the bottom part, you have a computing platforms altogether. Running on behind this here, you also need to have the high-end switch to drive the data. And because of this, you can imagine those machine running behind for the ChatGPT look like this into the rack. Not everybody offering the ChatGPT only, because lots of the enterprise customers, they're also doing other services for their innovations on the R&D side, and also renderings, and provide the contents to all the users. So we also recognize this opportunity from the industries. We're coming back with another lower form factors and also try to reduce a little bit cost for them and give them flexibility. Because in these high density solutions, you require either 4 or 8 fully loaded. What if you need 1 to 4, up to 8 different configuration? How to manage that? So we have that solution as well. This pictures for you to easily understanding about the configurations. We open the top cover this time. So you can recognize if you start to count. So all the card on top of that, that's a double width card. It's up to 10 units. And what's the message to you is each card, it's L40S. And those cards, they are able to drive the GPU power like the previous one, but they allow you to configure. So that means the cost will go lower and the workload become related. So you don't have to purchase everything at one time. Depends on your business model, depends on your workload requirements. And also you recognize SuperMicro offering the AI building blocks. We actually not force you to buy one chipset technology. We actually offering different options, including Intel and AMD, and the GPU as well, NVIDIA and plus the others. So this make your business model become very flexible and doesn't let you occupy into one technology only. There's a go lower and lower. After the AI and the metaverse concepts, there are also certain kind of new business model for the 3D rendering. Most of you are aware of that. Lots of the augmented realities require lots of computing powers. I think one of the panel discussion mentioned about those devices, the goggle, AR, VR, whatever you're using right now, there was intelligence at that goggle already. But how to make you real, have the experience into your environment, make it become an immersive application, you need to have both. Have the data training in the data center, has a data center close to the network you are using through the operators. So there's another level to go lower, to get it closer, make you feel really real, interact with those environments you are driving. And the GPU in the data center for machine training, but this computing GPU getting closer to your side, you can see machine getting smaller. And then this is also the reason why we continue to offer the possibilities for you. I think this is about the first sessions of all the GPU technology from the data center perspective and help you to understand, okay, finalize, you realized all the GPU behind to you, it's no longer just a machine itself. It's actually have to connect to the very high network and also the very high cost in the data center to drive all the topic they just present to you, ChatGPT, AI, machine learning, and also large language modelings. After this session here, SuperMicro also want to drive the sessions to the Edge AI. We no longer just satisfy the data center growth. We also recognize Edge AI become a booming trend. So the next few slides will be a chance for you to explore what we are doing and contribute to the industry. First of all, you recognize this side here, data center in the cloud, have a high densities. And then moving from the data center clouds to the edge, you require certain infrastructures before touch the edge device. So there will be the central office, other network connectivities. We all have that already at the field. And recognize this challenge at the field, edge computing require different type of form factors. We will also share that with you, how it looks like, how to help the edge AI possible. And then you also recognize this possibility is it's not limited to one application. We highlight certain vertical market here. They all need a different level of the AI support, including telecom, retail, smart healthcare, smart city, and others. And some of them have the business model require the machine learning analysis. They will go by previous Go series in their data center, try to generate more data crunching and automatic service to help you find out the answer quickly, including the pharmaceutical industry for those COVID vaccine things innovations. Those things need lots of AI GPU power in the data center. But what about those industries? They want to quickly deliver a service to the end users. And those are the edge AI related topics. Because of this, we have a few cases I want to share with you what we are doing and contribute to the industry. Well, first of all, you can recognize I'm not giving you a Rackmount system anymore. You can recognize there was a box, the AI box. And this AI box gives you many different possibilities. Some of you probably aware of what it looks like. It could be the small modules and able to drive certain small light workload. But when you want to do the inferencing, you have the choices from NVIDIA series like the L4. And those card itself was a low profile. And also you can recognize, we also put the full length card. It was like the A100 or L40S we presented before. Why I have to connect these two dots for you? In a data center, you don't need to worry because you have air conditioning. You also have enough space to maximize the capacity and density. At the edge is totally different story. You don't have a rack anymore. So those machines, it got to be mounted in a different way. The box you saw is actually mounted to the wall. So you can imagine your server no longer on the table in the rack, it's actually on the wall. Carry on the GPU power to drive the innovations. And also you can recognize going to the different industry, retail, factories, and those areas will require lots of the different mounting options at the field. Those are the segments we help the industry in the intelligent retail or industry 4.0. There's a one requirement they want to do it faster for the behavior analysis, including like the people traffic response to the retail layout things. In the industry 4.0, they require the worker safeties to avoid people get hurt by the robotics arms. So those intelligence no longer have the people watch them around. It's an unmanned area. So you need to have the power of the GPU. For the smart places, we have the product able to do the outdoor edge computing with AI. This machine is still mounted to the wall for smart cities. We have a project in Mexico City. It's able to detect the gunshot sound, face recognitions, and help the police station to protect the citizens. And those require the inferencing power at the edge to do the job instead of the cloud computing in the data center. You also recognize there was the energy sectors we are helping right now. There was some solution able to detect the wildfire before they get worse. So there was a 24/7 smart camera look at the world with the edge AI combining together. So camera do their job, but there is a machine help them to provide intelligence like a brain. Combining together, it's not a robot, but it's a concept of the virtual services at the field for the edge AI. Last one, telco. We have many investment in the telco business for people do the automation services to all the mobile network you are using right now. One of them is the Open RAN. And also the private 5G network allow you to deploy the solution in the specific places like the stadiums right now here. And also could be the special private event to drive these things. This kind of a concept all require the edge AI to make the service faster and reliable and with intelligence services behind. My last slide here. I think we want to echo again about Wally and Charles bring the mission and value to the industries. We believe at this data center architectures all the way through the 5G AI age, we are able to provide the sustainabilities to the world for our Earth. So because to making this mission possible, all the green computing we are innovating right now will bring the huge values back to the everybody invest here. And I hope this presentation will give you the best chance to know more about SuperMicro. We got a booth outside, and please feel free to reach us. We can give you more updates. That'll be the presentation today. Thank you.
Thank you to our keynote speakers, Wally and Maury. That was a very, very informative and fabulous message. And right now, this concludes our morning session for the Taiwan Tech Summit, and lunch is ready. So please go ahead outside and enjoy lunch. Lunch is right to the left. Thank you. Welcome back. Hope you had a wonderful lunch. This afternoon, we have multiple exciting events lined up for you, including speeches from our keynote speakers, Sony Xiao and Vivian Lien, and forums on hardware, investment, biotech, cybersecurity, and generative AI. We are starting with our hardware forum titled Taiwan Semiconductor Industries Navigating Through AI Wave. The speakers for the session are Maury Lin, Jack Kang, and William Koo, and our moderator is Mark Tsang of Natia. Please give a warm welcome to the speakers.
Thank you. All right, thank you. Welcome all the panelists. Please take a seat. Okay, this morning, I think we are waiting for people to wave in from their lunch. So this morning, Lina set the standard very high. So I need to make the standard even higher for the hardware panelist discussion. So this is Martin. I am from Samsung DRAM Product Marketing. I am representing Natia in 北美台湾工程师协会. I would like to thank you, Natia's team member, TTS, sponsor, and all the volunteers making this happen possible. So we know in the last 2 quarters is a very special time in the hardware time. NVIDIA make into a 1 trillion market cap. And we know that and the market start to realize the hardware is not like before. Previously, people all talking about software, but now it's about hardware. And this new hardware was invented by NVIDIA, enabled this whole new technology. And today we have all the technology leadership from a different sector. We have from ODM, OEM, SuperMicro. We have SoC, IP, Sci-Fi. We also have AI inferencing IP at the edge from Acepodia. So I'm very happy to, I'm very excited to have this opportunity moderate today's hardware forum. So let me have a quick introduction about our team. So we have Maury Lin from SuperMicro. He's a VP of IoT, embedded and edge computing. And no further introduction needed. We know SuperMicro is under the spotlight with NVIDIA. So if every time Jason mentioned SuperMicro, they make $1,000, they probably make a few $1 million already. We have Jack Kang from Sci-Fi. He's a senior VP of corporate marketing, BD, and customer experience. We have William Kuo. He's a VP of sales from Acepodia. And Acepodia is an AI inference IP company leading the development in the edge low power automobile IP solution. So let's give all our panelists a warm welcome, and we'll kick off today's forum discussion. Okay. So the first question, I will go. We know SuperMicro and make this amazing hardware with NVIDIA. And now, like this morning, in the keynote Wally mentioned, we are seeing the wave of GPU computing in the data center coming to the edge. I want to ask Maury, what do you think, what is impacting what happened of the edge computing of AI hardware?
Thank you, Mark. And I think this is a very good chance for SuperMicro to comment on this edge computing related to the AI topics. But before answering these questions, I think edge computing has been addressed the importance in the market for a while. And suddenly AI from the cloud become possibilities for the ChatGPT type of applications. And then they start to think about what about the edge? Have the same level of the innovation with the intelligence behind. And to reach this level, edge AI requires certain of the things. First of all, this machine or this service have to closer to the devices or to the people are using those services. And to make this edge computing plus the AI, we require lots of effort behind. We are just one of the infrastructures under here to supporting all the application on the top. I think later on you can hear from William, also from Jack about this case. And to us, we think Edge AI will bring wider possibilities and all the computing workloads back to the data center. So that's the reason why in this spectrum here, from the cloud down to the edge computings, all have a chance cross with the AI features inside. And this is a concept, but we also put it into the hardware. And you can recognize this morning we put the AI in the data center. It's a bit different computing hardware. To the edge, there is a location challenge for mounting machines. And there is a thermal challenge like others is in the factories or retail space. The thermal will be also the challenge as well. So we have to have a different setup to make the performance could be secured at the edge. So from our perspective, I think the Edge AI will have the same importance to the end user, but require different design know-how. So we definitely want to make sure that both spectrums, like the data center at the edge, can have the same flexibilities to drive AI power inside. Thank you.
Okay, thank you, Maury. Thank you for the insight. And then we are definitely seeing that edge computing, and then they have a booth outside. So if you're interested on their solution, you can also stop in by the booth or see from their website. Okay, with SuperMicro, they build the foundation of all the AI infrastructure. Then we were able to enable more application. And one of the key is all those IP company. They make the design possible and bridge toward the software. So we have a Jack. So I want to ask the Jack about the questions is, how do you see how the advancement in the AI algorithm, this time we see large language model, how does that affecting the hardware requirement from your perspective?
Yeah, thank you. And first, I want to thank everybody for coming and attending and hearing us talk. It's a Saturday, so spending your Saturday. I was actually surprised at the number of people here in total. My name is Jack. I work for Sci5. So we provide RISC-V IP. So we're kind of at the other end of the hardware spectrum in terms of, we're providing the components, the IP components, the design that goes into the silicon that ultimately makes it into a system that then gets deployed by folks like SuperMicro. So to answer your question about, I think the main thing that I think everybody has to realize about what we call AI, AI is this very kind of nebulous technology. It's evolving very, very quickly. And what worked yesterday is not what's going to work tomorrow because we don't know what's actually going to work tomorrow. If we were here a year ago, last year, everybody would probably be talking about neural nets and CNNs and how that enables all sorts of things. This year, nobody talks about that. Everybody's talking about transformers and how do you accelerate that? So will we be talking about transformers next year, or will we be talking about something else next year? I think we will see, right? Transformers is very exciting because it's they found in my opinion, they found a killer application, called generative AI, or I guess chat AI, ChatGPT, that's which uses transformers. So everybody's now chasing that. So from a hardware perspective, what that means to me is that the algorithms are going to continue to keep changing and evolving because we're not set yet. We don't know what the solution is. So how do you accelerate something that keeps changing? Because fundamentally, when you accelerate something, you take the algorithm, the software algorithm, and you're mapping it into hardware that can run it very fast and efficient. Because if you didn't know what it was, you would just run general purpose CPU, right? That's how we do in the last 40 years, right? So you accelerate because you know what the hardware requirements are, but the hardware requirements keep changing. So I think what that means from the hardware provider's perspective is understanding what parts can be accelerated, but more importantly, making sure that your solution is programmable. And I think the programmability gives the flexibility that then you can adapt to the changing algorithms without sacrificing too much of the hardwire acceleration. And maybe later we'll talk more about how RISC-V does that and how Sci5 does that. But I think I would as everybody listens to us speak, I think I would keep that in mind. Like, what does it mean to be programmable? What does it mean to be adaptable? And the kind of last point is, I think this is why, in my opinion, why NVIDIA has done so well, because they have the best programmable engine that exists right now. It's called CUDA. program with CUDA. It's a programmable engine, and that's why it's been adopted so quickly.
Thank you, Jack. And we have when now we see like what Jack pointed out, all the different algorithm was making that infrastructure more demanding than before. In not only in the data center, also coming to the edge. And from Williams, their company Acepodia, they are trying to enable this even in a lower power system. So I want to ask Williams, from their expertise, is how do you see the advance of the AI-specific semiconductor that we are seeing today, the inferencing the bigger, broader scope of the AI design?
Thank you, Mark. Well, first of all, I too want to thank all of you. I know TTS provide a lot of very authentic Taiwanese food up and down this building, but thank you for taking time to come here and listening to join us. So, AI specific, right? So, plenty have been said and written about the general purpose CPUs and GPUs from NVIDIA, right? And with their CUDA being the de facto software standard and Mellanox being the top-notch switching solution to move data, we can understand, why they are doing so well. But outside of that, the general purpose CPU and GPU, there are plenty of companies, big and small, such as my colleague Jack here. They are dedicated themselves to AI-specific semiconductor or silicon IP solutions. So we can look at two different parts of the AI marketplace, right? The training and the inferencing, right? So in the training space, of course, a lot of training is being done in the cloud. A lot of cloud computing players like the Google, the Amazon here in the US, to the Alibaba and others in China, of course, they are using NVIDIA, solutions, as we all know. But they also, each one of them are developing their own ASIC, not only to reduce unit costs, but also they truly have unique problems and applications they want to have specific hardware to address, right? So those are internal solutions to those big companies. Outside of that, you have companies like SambaNova, Cerebras, Grok. They are developing, chips or even subsystems to address training-related AI applications. And in addition to those, you have optoelectronic companies like Lightelligent, right? And even FPGA, right? Not too many people know that in the AI space depends on the training space, depends on the configuration. FPGA can be a pretty good solution there as well. So that's not just the big companies like Xilinx, but the newcomers like Achronix, right? So that's in the training space. In the inferencing, in the inference world, it gets even more diverse, right? So as you push further and further out to the edge, right? So it's all about the trade-offs of PPA in power performance area, right? And latency and bandwidth. So you think about the requirements and the neural network models that's needed for a Bluetooth headset. That set of requirements will be vastly different than what you would see in the autonomous vehicle. So there are plenty of companies that's again developing chips and IPs, trying to address different niche market and application. So yeah, collectively there are plethora of different companies, coming up with AI-specific solutions so that, together we can advance AI from cloud all the way to the devices that's in your pocket.
Thank you, William. That's very insightful. So now we can see all the different hardware to make the some solution like NVIDIA happen now today, we see in the data center is coming even more closely to our edge computing or daily computing in your phone, in our PC. Now, we want to ask a little bit more deeply question, which is for Maury. So this is actually amazingly, we know for each server they build is a huge, they have a lot of GPU, 4, even 8. Amazing power they can deliver, and then they can computing power, also the power they consumed. I wondering, how can you share with us what kind of innovation SuperMicro is working to even better for that thermal power management of a GPU?
This is a very, very challenging questions, but I think it's good to share since we all are in the same rooms to try to make the AI, not just at the edge, also possible innovations in the data centers. And probably I will use certain examples to explain why this topic is so challenging to all of us who are building the AI solution hardware right now. In the past, when you build a server, most of the server have the components such as the CPU, memory, hard drive, and with one card, like Wally mentioned about FPGA card. Those things all together in one system probably create a power consumption requirement like 1,000 to 2,000 watt without GPU. There was the age, many years is you using lots of devices. This morning, we present certain GPU. Those are the public information. Some of the GPU easily consume like the 300 watt per card. And then so easily you can calculate if there's a machine can support up to 10 GPU. So you need to have 3,000 watt just for GPU. And then if next steps, they are going to push the limit to a higher power consumption per card, then it's not about providing the bigger power supply only. Actually, you have to think about what about the heat? How can we bring out of it? And then we recognize this become much challenge by just using the air cooling, and which is also the public information we are doing right now. We have investments on the liquid cooling. So for sure, not put the liquid on the machines. It will be a big issue. And you need to have a technology to bring the heat or dispatches outside of the server from the data center to the other devices to cool it down and through the specific materials. And this will be the trend. Imagine if AI is very demanded for more computing power, and we need to have a very power efficient architectures, and plus with very efficient thermal solutions to do it. And this requires lots of know-how. It's no longer making a server AI computing faster and faster. We also make sure they can save the energies. Otherwise, you will bring another cost factors to all those people who want to deliver the AI to the world. And so that was a very main topics we care about. And second thing is that we also care about age. So after solving the problem, the future problem about the thermal challenge and things, there's also a thermal challenge at the edge as well. Think about if we don't have enough air conditioning and others to cool down the machine, and how we are going to solve that. We also invest a lot of resources to make the edge AI possible. So this is the two things that we want to make sure when the chance is coming with the AI computing through the different platforms, we always want to make sure this machine will be able, good for the good return of investment for the next few years. Once you deploy the device at the edge, you don't want to change it every year. So the liabilities and also the mean time between failure, those numbers are all we care. And that means that you need to have a very good component experiences and knowledge to protect those investments. And which is the reason why I mentioned about the average selling price per machine now. It's actually pretty high selling dollars. And it's also create a big pressure for those people who's going to acquire it, use it, and protect it. So we would like to put more efforts to make those machines reliable and also can continue last longer as they expected. So that's our plan for now.
Thank you, Maury. So, you know, like these days we see the climate change and the global warming, and we see like industry have a lot of effort to reduce the power and make it more sustainable for our next generation. A very important topic. And so the next question we're going to Jack. I'm not sure if people know sci-fi. is a RISC-V based company, and Jack is the number 6 employee of that company. Then I'm always wondering for the sci-fi, they are ready to take a market share from ARM and x86. I'm wondering, how do you see the inventor of a RISC-V, which actually founded sci-fi, and sci-fi has been a leader in the RISC-V space. Can you explain how do you see the importance of a RISC-V in the AI market?
Yeah, that's a very good question. So I guess I'm curious, how many people know what RISC-V is? Okay, so we're making progress, I guess. So if you're not in semiconductors or chip, maybe it's a little bit difficult. But let me explain a little bit really quick what RISC-V is, because then it'll lead into why I think it's very important for new technologies like AI. So RISC-V fundamentally is what's called an instruction set architecture, or ISA. And the world today, before RISC-V showed up, really had 2 ISAs. There was x86, which had 2 companies, Intel and AMD, were the only companies you can get x86 for, and you can only get it by buying their chips. And then there was ARM. Now ARM, it seemed like you can buy ARM chips from everybody, but there was only one company that would provide the underlying technology, the CPU, and that company was called ARM. They just went IPO this week. Congratulations to them, $60 billion. But the world only had these 2 choices until RISC-V came around. And RISC-V is different than ARM and x86 in that RISC-V is an open standard. So if we look inside our industry, our hardware industry, pretty much everything other than CPU ISAs is an open standard. Think Ethernet or Wi-Fi or even 5G. These are all standards that anybody can implement and compete with. Only in the case of the ISA somehow did we end up in a situation where there was 2 proprietary standards. Now, one of the reasons why this is so important is because the ISA defines how the hardware talks to the software. So how does all the software get written, the software ecosystem, the thing that is actually the biggest investment that everybody has to do, even though we're all hardware guys, it's like actually the software part is the part that's really hard to change. The software investment has to go against the ISA. So Windows was written against x86, so we had Wintel for the longest time. And now there's some Windows on ARM stuff, for example. Android is on ARM, that's why they're very strong in mobile. So similar type of things. So RISC-V and Sci-Fi, were founded by the inventors of RISC-V. So, when I say made progress, when we started, we had to explain why this was even important. And the more anybody knew about CPUs, the faster they ran away. Because, why? There is no new ISA. It's been 30 years. Every 30 years, one comes along. But so when you look at new markets, new technology areas where a lot of new software is being written, it's actually very ideal for RISC-V because you have to write a lot of new software anyway. So if you're starting off on a blank sheet of paper and you say, I'm going to write a whole bunch of software for x86, so I'm going to lock myself into these 2 vendors, or I'm going to write a whole bunch of software for ARM, which means you're basically dependent on what one company will provide, or will I go to do it with RISC-V? So if there's no existing software, the choice is actually very easy. If there's existing software, you have a more difficult decision. So we look at something like AI, and because it's evolving so rapidly and so quickly, people are able to say, what do I want to do here? And they're looking at new things. So RISC-V has a very important role to play because the software is new. So how do you adapt that technology into it? The other major benefit that RISC-V provides compared to the others, as I mentioned earlier, it's an open standard. So of course, Sci-Fi, we provide RISC-V solutions, but you can build your own RISC-V. Other people can build their own. We have competition. And this means that you can customize the RISC-V implementation. You can extend it, you can configure it, you can do all sorts of different things that you just simply cannot do, right? So like if you want to do something with ARM, you have to go ask ARM, and if they say no, then that's it, it's a no. If you want to do something with RISC-V, even if Sci-Fi says no, you can find somebody else who will say yes, or you'll do it yourself. So what this means ultimately is, just like with every other standard in our industry, you come in with competition, you have more choice, the best solutions will win, but it also means you'll have the largest number of RISC-V implementations, the biggest diversity of RISC-V implementations, because now people can compete and they can go into different niches as appropriate, but leveraging all the same software. So what RISC-V brings to AI is the ability to make your hardware engines very programmable. So you need the hardware, the CPU, you have all the common tool chain, the software, the compilers, the libraries, and then you can attach your accelerators to the RISC-V core. And then you can connect that to a large decision-making RISC-V core. If you look at NVIDIA's architecture, they have Grace and Hopper, right? Grace Hopper. Grace is just a big CPU feeding data, making decisions. Hopper is just a big GPU accelerating the AI portion. So what I just described is you can use RISC-V connected to accelerators or by itself to do all the acceleration, and then you can still have large RISC-V cores to do the compute and decision-making and planning. And now because it's all RISC-V, you can imagine the software capabilities that come from this, because now you can virtualize across these cores, you can share workloads, you can pass things along much better. So this is where people look at, oh, I'm going to write new software, what new things can I do? And then RISC-V is so attractive for that.
Thank you, Jack. So now we see, like in this generation, all the computing we have to design from bottom up again, like back to the early time of x86. A lot of players, everything have to be reconsidered for some of the AI hardware, software perspective. Now I have a question for Williams. So when we're talking about all the hardware size, I'm wondering, what do you think, in what kind of role of the software is playing in today's to maximizing the capacity of today's AI hardware? Can you share something on that question?
Sure, yeah. Part of that is the extension of what Jack mentioned, right? So in the AI space, interesting enough, especially in the inference world, right? Not so much in the high-end training, but in the inference, dealing with, like the edge servers from Morris Company, from, wearables that you may have in your pocket. In the inference world, on one end, you have AI scientists developing different kind of neural network models on different platforms, such as Onyx, TensorFlow, TFLite, etc. On the other end of that, you have, right, of course, the different kind of hardware, whether it's a CPU, an NPU, or it could be even DSP. That could be all in the SoC, or system on the chip. So the AI scientists, when they develop the neural network models, the new neural network models, they may not know eventually what kind of hardware is going to process their models. On the flip side of that, people like all of us sitting here on the stage, we don't know tomorrow what kind of a new models and new layers and operators we will be dealing with. So this is where it is critical for a robust, sophisticated system-level software to bridge the gap, right? So a sophisticated system-level software, on one hand, they need to understand most, if not all, of the models out there, right? They had to build their model zoo, right? On the other hand, when they, look at a unique customer situation where they have an SoC, the SoC may have CPU, NPU, even DSP, and different kind of memory configuration, they say, okay, so how do I best optimize, how do I make this AI processing most effective for a given model by taking advantage of the hardware that's available? That's an easy say than done. You look at you have to manage the different hardware. You have to make sure which piece of hardware is going to use how much of the memory, and as you distribute different tasks, like for example, if you're really into AI, there's such, you probably heard of NMS, which is non-maximum sorting. That's best handled by CPU, like from the ones from Sci-Fi. And there are other parallel processing that can be done in NPU. So it is really a pretty interesting and challenging task for the software. So in that regard, the software play a very important role in all this. Since we are in this is TTS, Taiwan Tech. So there's actually a software company in Taiwan that's doing a very good job with that, and that company is called Sky Miser. So that's.
Thank you, William. Thank you for sharing that. So in the Taiwan Tech Summit, it's very impressed that we have people from all the different areas. Then that's somehow make it some topic choice a little bit harder. And I think all the panelists, they explain it very clear. Try to make it, especially in hardware, much harder than software. So these days, that's why NVIDIA much higher market cap today. Okay, so I have a question back to Maury. So last time, in the last question, Maury shared with us how SuperMicro was managing the very high thermal power issue. We know that's not the only secret something they do in that area. We want to ask Maury, what other things SuperMicro do to optimizing their server hardware for this unique requirement for the GPU accelerated or accelerated computing for those AI workloads? Do you have something a little bit more to share with us?
Yeah, so I probably need to answer this question carefully because I think for all the hardware companies, when we start to announce the features, for sure soon the competition will come after right away. But we also believe in that this will encourage us to run faster. So definitely I answer these questions about after those performance thermal challenged, then what else we are going to help this AI possible in the different angles. And I really appreciate Jack and William mentioned about openness and also the AI things. Actually, indeed, we are not able to control the future of the AI. But we do have a chance to contribute how to make the AI become affordable to different level of the applications. And to reach this level, we have to think out of the box. If we continue solve the high-end GPU and high-end computing inside data center, there will be just one big perspective of the world who need the AI for those ChatGPT big topic, large language modeling things. But what about those peoples? They need the AI power to drive the different applications at the edge. And I want to elaborate this topic a little bit more. For instance, like we have a certain application, I recognize two presenters mentioning about the inferencing. So I have some real maybe experience to share with you what's happening right now at the field. Imagine you have to find lots of money to buy the big machines in the data center to host everything by yourself. There must be a group of people just need a certain computing AI power for a certain period, not forever. You have to only for a whole year. For instance, like scientists, they finish their study, they finish their modeling, but they need someone to prove what they are thinking are the truth. Like what you are doing right now, you want to make sure your autonomous algorithm will avoid to create casualties. Those things just in your mind, in your programs, in your proposal, but you need someone to prove it as one of the supporting factors, not necessarily the fact after the field test. So there are certain people who start to think about how to lease those GPU power to the customers. And those people are thinking about how to make sure those data center closer to the edge. So after this topic, I'll talk about the edge AI part. So that means it's no longer just talk about the data center high density level. It's also become a modularized. The data center have to closer to the specific country, specific locations. And second thing was about the data breach issues for the security topics. Lots of people have a concern about put everything in the cloud because they might have a knowledge to protect everything. What about your AI power and modelings? So there are many topics will be involved how to make the hardware become more secure before they onboarding everything on top of that. So those are the things SuperMicro keep investing a lot, not just from hardware thermal perspective. We actually want to make sure our devices will be secure enough before you load everything into it to run your modelings. And after this too, data center, edge data center, and there's a topic coming in like edge inferencing devices. We use the same concept. We just brought that kind of a concept to help the edge application. In that level, there are different level of the challenge coming back. They no longer just ask us to make it modularized. They just want to make sure it's cost-effective, affordable. And then some of the machine, they just need inferencing, so they don't need so many machine learning power. From that perspective, I think the different CPU technology will bring the different openness, and programmable is the key. Because if you cannot do this job right, how can you believe your data center computing algorithm will be okay at the edge machines? It will crash. So that's the reason why flexible, programmable is the key openness as well, not just in the past few architectures. It's actually also impact the AI modelings. And we are the expert on the hardware level, and we also listening carefully. So that's why we not just invest in the data center at the edge from hardware. We also recognize the next step is how to protect those apps and how to make sure those apps will have enough computing power through CPU, through GPU, through others. So there will be the continuous topic in the next few rounds. And we hope we can make sure we can always in the leading position to help the world. Thanks.
Thank you, Maury. So there's a very different consideration between AI workload or AI specific design in the data center and edge. Like what Maury pointed out, in the edge will be no like a security, powers, all those still is very different perspective. Now I have a question go to Jack. So along the line, we see Sci-Fi, the RISC-V based company. Can you share with us what kind of a role Sci-Fi did in shaping an AI-specific extension to the RISC-V architecture, which is originally only based on general computing, now go to the AI age, it's become very different.
Yeah, so earlier I mentioned one of the nice things about RISC-V is that it's designed for customization and extensibility and things like that. Because it's new, a lot of the things that are being added to RISC-V, the standard as it evolves, there's opportunity to add in specific things. For example, one of the main parts of the RISC-V ISA is called the RISC-V vectors, or RVV. So vectors is just a way to compute lots of data very, very efficiently. But vectors is built in to the RISC-V standard in the ISA because it's coming up right now in a time of obviously AI and need. So one of the things that happens is for RISC-V vectors, for example, and other things is like what kind of data types do you support? So there's like native support for like bfloat16 and other things that have just come in from AI that hasn't really made its way into general purpose computing, if you will. So once it goes in, then it's part of the RISC-V standard. And now you can talk about things earlier when I said that, the compilers and the libraries and the tool chains all know how to speak that, all know how to generate software for that thing. And because RISC-V is extensible, because RISC-V is a standard, right? So you can imagine that there can be a RISC-V implementation that's a very large CPU, very high performance, 32 core, 64 core, 128 core type cluster CPU that runs RISC-V, and it can scale all the way to the edge. We have customers who use our core, they run it on like AA battery powered devices. And these are the same ISA, so you can run the same software, so everything in between. And because it's all RISC-V, as software gets developed for one segment, it can be adopted and used by the other segment. Right? So this is the benefit and the power of the ecosystem, and this is the benefit of the power when lots of people come in together into an open standard. So where Sci-Fi, where we have a specific role is, first because we invented RISC-V and we're the leaders in RISC-V, a lot of the new development customers work with us, and then a lot of the standards that are being driven, we contribute significantly to those standards, where we contribute the standards back to what's called RISC-V International, which is a standards body that's managing the RISC-V standard. So just as an example, earlier this year, we donated the security standard back to RISC-V International. So everybody who's using RISC-V has the same kind of architecture for security, right? not directly related to AI, but very related to our deployments, as you just mentioned. So you need to have all these additional components that are brought in, and I think your side is kind of a unifying way to do that. And then you have the very specific implementations from small to large and medium and everything in between. And that's where you're going to have lots of opportunities, not just for Sci-Fi, for us to service our customers, but also for competition to develop their RISC-V solutions as well. So at the same time, we're growing the entire RISC-V ecosystem. We're also competing within it.
Thank you, Jack. That's very insightful. As we see, the AI was involving all those areas that's got a lot of work need to be done. And William, from their edge or low power device consideration, I want to ask William, can you help us to understand, or can you describe how the AI inferencing IP, they, especially in the edge and those areas, they need to design to work seamlessly with so many various applications? Can you help us to understand that a little bit better, for the, especially in that IP area?
Sure. So to understand how a particular AI architecture, such as the one from the company I'm with, Expedia, can handle from very low-end application. Like I have a customer who's doing Bluetooth headset. They are not talking about watts, they're not talking about milliwatts, they're talking about microwatts, right? So from there to something like autonomous driving, I'm talking about not level 2 plus, but level 2, 3, or 4 kind of autonomous driving, or even inferencing in the data center. So if you want to have one architecture covering all of that, right? And I know Jack mentioned that as well. It would be interesting to focus on what's the most challenging aspect of AI, right? It is about data, big data, a lot of data, right? So in the hardware, from the hardware perspective, AI processing takes a lot of memory, whether it's SRAM, DRAM, HBM. And the reason it requires a humongous amount of memory is because if you look at a different neural network model, it doesn't have to be LLM or GPT, right? If you look at a CNN, convolution layer, it takes just a lot of, the weights and the activation. Traditionally, the CPU, GPU, or NPU, they download one layer at a time down to the memory. And so you need a big chunk of SRAM inside the IP or inside the SoC to accommodate all that. That, of course, takes a lot of space in terms of die area, and which translates into high power, and not to mention low utilization, because once the data is in the memory, you need to do pre-processing. You need to reduce the graph of that particular layer down to each individual instruction and feed it one at a time to the whatever processor you are working with. So a lot of time, regardless of what hardware you are working with, that processor is actually idling. So how do you address that kind of challenge? Well, one way to do it is to packetize each layer, right? Instead of a big chunk of layer, you break it down to a smaller unit, like we call packets. And so by doing that, your memory requirement can be reduced significantly. And that translates to lower power, smaller die area, and just as importantly, I mentioned about utilization. When you have a smaller packets, you can feed those smaller unit of data to your NPU so that your NPU will be busy most of the time. So your utilization goes up tremendously. So that's so that is how, please consider this as a case study, not a sales pitch. So this is just one way to solve that problem. But by using that kind of unique architecture, the Expedia solution can address low power, like I mentioned, a Bluetooth headset or something similar to that on one end. By using the same architecture, we can address high performance applications like autonomous driving or even inference in the cloud, where you start talking about hundreds of TOPS, it's a teraops per second. So yeah, that's one case study where one architecture can address low power to high performance all at once.
Thank you, Williams. Because of the time, I have one last question I'm going to ask. But help us to understand. So we know previously we have a cryptocurrency, we have a metaverse. I want to ask our panel from there, they have a great experience on all those areas. What do you see this type of the AI wave? Do you think it's real or is a hype? A few sentences, can you help explain to understand? We'll start with Maury.
First of all, I think it's hard to comment on that question directly, but we just maybe share the experience and also why we are doing this to support some directions. First of all, I think we invest a lot already to help the AI to run, and then it's not for specific workload. And we talk about several hardwares. I know it's very tough in just one morning to ask you to remember so many things, but let's just forget about what I present this morning about hardware. Let's just look at some cases I can share. We do have a customer use those AI to do lots of things, not about those two applications Mark mentioned. And those are cross-industry. So first of all, like those people need ChatGPT, but not allowed to use the public ChatGPT. The consulting firms, those people have a lot of business case on hand. They hesitate to move all their data to the ChatGPT, but they want to make their consultant run like a super smart guy. So how to solve that problems? So they have to build their own ChatGPT in the places they trust. So that's industry you can think about. As long as they have to provide you the special service for consultancy, then they need the AI to help them to make their team and people work faster to give you more precise predictions or recommendations. So it's a mix. With the machine's help, still give you the real person services to help you reach the goal. There's just one angle. But we also have a situation in the autonomous industry, as you all know about that. Lots of the autonomous driving topics, they need to study the pattern of data they collect. And there's a big question is how much trust you believe in that. So someone have to keep proof, not just about the result, also need to make sure it's will be a real one can run at the field. And those one also need lots of the GPU AI powers. And no longer just limited to this two, we actually have more customers that are coming back asking for a solution to solve their problems. And so from those kind of different vertical market observation and SuperMicro's existing customers, we recognize they are not here to talk about dreams. They are not here to talk about concepts. They actually have to make their existing business run faster to, either keep their leading positions or totally try to kill the other leaders' positions. So AI has kind of become very luxury machines for them to change their market position. And because of this, I think we don't know how long it will last about this AI topic, but we definitely know as long as those services need to be upgraded through different format, it must be someone have to empower behind, just like the computing in the past. Now AI is going to do this for AI for everything. And our job is to make it become a very friendly accelerator to all the application. So from the angles, I think our investment or our observation will help you to build your own observation and perspective.
Thank you, Maury. How about Jack?
Yeah, I think I think my private company, so I can be a little bit more open. he cannot say that AI sucks. He'll be in trouble. So I think the most important thing everybody should take away is, to me, AI is a technology. It's not a product. It's not a vertical. If somebody tells you, I have an AI chip, your next question should be like, for what? Like, what does that chip do? Because otherwise you can call everything AI. Now, AI is forcing everybody to build more compute. So that's great. More compute, good for all those hardware guys. That's definitely true. But so it's not a hype cycle, but AI is a technology. It's how are you going to apply this broad set of technology to solve specific problems? And I think right now, even AI, really, there's only been like one killer use case, which is ChatGPT, sort of, and maybe autonomous driving, maybe. But what is it actually solving? So maybe I'm downplaying a little bit, but I think, the key is like, what is AI actually solving, and how does it apply? It's a technology that will apply to many different verticals. It by itself is not a vertical.
Thank you, Jack. Williams.
Yeah, so I'm, so I totally agree. AI is not it's a technology, it's a solution, it's not a product. From marketing point of view, AI is a very powerful marketing acronym. There was a study recently that, for those of you who are in investment, the companies that mention AI in their quarterly report as a group, their stock gone up quite a bit more than those who didn't mention AI, right? So I can, but get back to your question. I can think of a couple examples. Now, AI is, may be relevant in some area, but not so much in other. But how about, say, agriculture, farming, right? So I run into companies and customers that they actually apply AI in the farming space. They are, famous farming equipment companies that actually use AI. For example, they use a drone to look, the farm and direct the machines on the ground to, as far as determining how much you fertilize and where and that kind of stuff. The other example is I was in another panel discussion just a few weeks ago where the chairperson and the professor, Dr. Pan from UT Austin, he specialized in, so we are talking about how to use hardware to solve AI, use AI to solve different problems. He's talking about use AI to design chips, especially for those of you who are in the back-end design doing place and route. It is rocket science to figure out how to, squeeze as many transistors as possible, but still be able to route the wires without getting to antenna and crosstalk kind of problems. So yeah, I totally see AI will take us, it's just no limit.
Thank you.
I forgot there are investors here. AI is great. Just invest in AI. It's good. Vertical market, no problem.
Thank you. So thank you for all the panelists for sharing their great insight and time with us. Let's give them another applause. And they will conclude today's AI Hardware Forum. Thank you.
Thank you so much for the speakers for the hardware forum. And our next forum will begin shortly. And the speakers are David Wang, Eric Liaw, and Jason Wang. And the title of that is Shaping the Future, Investing in Disruptive Technologies. So I would like to welcome the speakers on stage. Thank you.
Hi, it's a great honor to be here to share with you about investment. We are looking forward to what's happening. You know, we have been hearing AI for a whole day, and then I think three of us are very. I think we know each other for a while. You know, especially I know Jason for almost 20 years, and then. And also Eric, you know, we have been just knowing maybe 3-4 years, but we are becoming a good friend. So this section, this panel will be going to be more, you know, while side chatting, and we'd like to share some of our idea with you. So let me introduce a little bit myself. I'm CEO of Taiwan Capital. Actually, I spend most of the time in Silicon Valley. And I just moved back to Taiwan about 7-8 years ago, but not really moved back. I'm just, you know, flying across the Pacific Ocean to bring some of my experience in high-tech experience and also investment. So Taiwan actually is a very young venture capital sponsored and supported by National Development Fund and also some of the financial institutions in Taiwan, as well as some of the enterprise. So we only have a 6 fund in 6 years. So although it's you know, small compared to IVP, but we still fast growing venture capital in Taiwan. And what we try to do is through investment, we want to bring up the partnership globally. And we focus on biotech. We also focus on deep tech. So AI is also one of the areas that we are interested to invest for any of the emerging technologies. So, and actually I just flew in last night from Tokyo, and I know Eric is flying to London tonight, and Jason is also flying back to Taiwan tonight. So, you know, given all this time, I really appreciate Eric and Jason's participation in this section. So we are going to talk about what's the future, you know, disrupt technologies through investment. So with that, I would like to have Eric, you know, talk a little bit about yourself, and then Jason.
Good afternoon, everybody. Thank you for having me. It's my pleasure to be speaking to all of you, and hopefully you're still feeling some energy after a long day of great content, and we'll do our best to keep you entertained and educated at the same time. So my name is Eric Liaw. I'm one of the general partners at IVP. IVP is a venture capital firm that has a 43-year history here in the Bay Area and increasingly in Europe as well. And just as technology evolves over cycles and decades, which I think we're going to talk about today, so has IVP. So just to give you some context, when IVP was started in 1980, one of the first investments we ever made was in a company called Seagate. And it was speculative technology back then and also a speculative market. People weren't sure that there would ever be a need for storage, and even if you needed storage, it didn't need to be that small. Obviously, we recognize how much storage we all have in our pockets, and the industry has evolved. And that's been true for our firm into the 90s with the internet boom and bust. We invested in the first round of a company like Netflix, and it's continued to persist where we're now more recently investors in companies like Twitter, Snap, Discord, CrowdStrike, HashiCorp, Datadog. So that is a common theme in technology, the sort of rebirth and innovation, and I'm sure we're going to talk about that today. I've been in the venture business myself for 20 years now and joined IVP about 12 years ago.
Oh, let me add one point. Eric actually is the top 100, you know, venture capitalist worldwide, 2 years in a row. IVP has been one of the leading tier 1 and outperform other ventures, but you know, Eric is really #1 out of #1, so outperform. So it's my honor to know him, and also to have my honor to invite you to join this section.
It sounds much better when David says it instead of me.
Okay, Jason.
So my name is Jason Wang. I'm a professor at Stanford University School of Medicine. Before I joined academia, I spent a couple years with McKinsey & Company in Asia. And I also work at the think tank in the United States, the RAND Corporation, before becoming an academic. And since becoming an academic, I co-founded a company cognitive health about 11 years ago, and it's based on AI and IoT, and the goal is to help the elderly to prevent falls and pressure ulcers when they are living at home or in the hospital. It's a pleasure to join this panel. Like David said, we know each other for a long time. Actually, known Eric for 40 years. We were just counting, and it's a very exciting time for technology.
So Jason is not just a professor, medical doctor. He also a founder of Cognito. I think it's a healthcare system. So he really entrepreneurs. So we are going to hear from both of them to share. So I think.
Sorry, can I say one thing since we're all saying nice things about each other? So Jason, as he points out, and I have known each other for 40 years. We're family friends. Our brothers went to junior high and high school together. And so this is a statement of fact, not of judgment. I'm younger than Jason. But what that means when you're growing up is then, when your mom's best friend's son is so accomplished and smart, your mom's like, well, why can't you just be like Jason? And clearly you heard what he's done, and I can't do that. So that's why I went to venture capital.
Okay.
He's done better things.
Okay. So let's get into the AI business. AI frenzy, actually sparked enormous amount of related demand across several sectors, such as high tech and also biotech at a global scale. And as we all hear from this morning until the hardware in the AI area, we see this phenomenal growth. So I'd like to ask Eric, your perspective. AI investment is booming. Is all the hype around the generated AI warrant or overblown? For the next 5 years, how do you see the role of AI plays in the venture capital and also startup ecosystem, and how it going to benefit the whole ecosystem? So you can talk from the investment, venture capitalist point of view, and Jason, you probably can comment from the entrepreneurs.
So there's a lot in that question, and I think the specific answer varies on where in that time frame that we're talking about. I tend to agree with some of the comments from the prior panel that there is a hype cycle, and I've certainly seen over the last 18 months companies that really aren't AI companies try and attach AI to their names so that they can get a better valuation or get some more investor interest. So that's absolutely true for private companies. I think public companies, I think the prior statement, but I see it on the private side. I do think there is a bit of a hype cycle because the potential transformative power of what AI can do for different products, companies, jobs is something we haven't seen really in quite some time. I think you can credibly say that there's potential that this is sort of a white-collar industrial revolution with what AI can bring in terms of the efficiency, greater speed, greater pace of execution. However, that is not all here today. And like in many examples across technology and disruption throughout history, the potential gets out in front of the reality, and then, as Gartner would put it, the trough of disillusionment sets in. And I think we're actually a bit on the cusp of seeing some of that disillusionment, because the prior 12 to 18 months, you saw a lot of fundraising activity, very high valuations. In fact, it was the only subsector of technology where valuations and investment dollars still looked a lot like the activity from 2021, which we of course know was, in hindsight, excessive and unrealistic. So where I think where we will see changes and actual impact is when you have AI that is tailored to a specific use case, and probably a little bit more narrowly than some of the underlying LLM models are talking about today. So I'll give you an example of a company that we looked at. It's probably going to cut the number of paralegals that are out there. And that might be a good thing, because if you think about that as a knowledge industry, that is the lowest level of that particular industry. And so this company, it's called EvenUp, they use some of the different models out there. And we're not invested, by the way, so I'm not just promoting one of our companies. We actually maybe should have invested, but we're not. But they can expedite the process of creating the initial claims letter that happens in some legal processes. Is it perfect? No, but does it get you from a blank piece of paper to probably 80% of the way there in a fraction of the time and a fraction of the cost? Yes, and that's where you can start to see impact. And then I think that this will continue to happen over the next couple of years as problem-specific solutions become better and better and better. And I guess the one thing I would also point out is, well, I'll ask the audience, like if you remember Look Smart, raise your hand. No one. If you remember InfoSeek, raise your hand. Nobody. How about Alta Vista? So a few people. So clearly, those were all early incumbents in the early part of the internet that have now all been completely demolished and disrupted by Google. But Google was, the point I'm trying to make is Google was not the first player in search in even that phase of the internet. I mean, it really didn't pick up speed until after everyone else had crashed in the internet bubble. And so I think you will probably see the same thing, which is a theme that we talk about, that the long-term winners, when there's a new platform shift, usually aren't the first ones that you hear about. So for everyone in this room, if you want to think over the next 5 years, I would keep your eyes and ears out for what actually starts to gain sustainable traction.
Yeah, thank you. Jason?
I'm just going to focus on the healthcare sector because that's the sector I'm most familiar with. So there's no question that there's going to be application of AI, particularly generative AI in the healthcare sector. So we've actually, in the last year or two, we've gone through a lot of changes in the healthcare system. During COVID, for example, almost there's universal adoption of telehealth. And so now it's becoming part of the clinical practice. During the last 3 or 4 years, too, the FDA has approved 520 algorithms that could be used clinically. And so definitely people are looking at algorithms, looking at the machine learning algorithms and its application in healthcare. And when you look at the potential for AI in healthcare, I would look at the different areas. For example, the patient-facing area. So if you think about what you need to do when you go see a doctor, you need to make an appointment. And so that, could be automated. There's no reason why you need to call somebody to make that appointment. And billing too. So that area to receive billing, to pay for things, that could also be automated. And also, there's a lot of lonely people out there that require mental health support. And you know what chatbot is really good at? Chatting with people. Okay, it's really good at chatting with people. And once you figure out the right tone, I don't think people have done that yet, the right tone to engage individuals so that makes people feel better. It could take 10 years to train a psychiatrist to actually get the right tone, ask the right questions. But if you get a chatbot to act in that capacity correctly, they will probably prefer talking to a chatbot because that is individualized to that person. So that's just the patient-facing side. If you look at the provider-facing side, so what do we do during most of our time is to summarize data. So when we see a patient, we have to review all the medical records, try to figure out what is the most pertinent part of the medical that we can't miss. A diagnosis, a specific problem, an allergy to a medication. That could actually all be summarized by AI, and it could all get better with training. Now, granted that you need to get the right database to train it. I think the proprietary nature of the database, I think, would be important. And then you look at the administrative portion, the billing cycle, asset management in a hospital. There's probably 5,000-6,000 vendors that a hospital needs to manage for procurement of different equipments and so forth. And those are all potential opportunities. The analytic portion, for example, what we used to train people to do, to summarize research data, that would take 8 months. We could do it in 2 seconds right now. So a lot of the RAs are going to be out of the job. Because basically the ability to synthesize information, particularly with generative AI, is very, very powerful. And in a life sciences application, when you try to develop a new drug, you look at the structure of the molecule in 3 dimensions, and you try to figure out if one mutation here or one change it there, the 3-dimensional structure, and when you try to create drugs, I think it will also become a powerful tool. Now, that being said, the future of AI in healthcare is determined by the lack of transferability among data sets. It's actually the incumbents have very tight control over data, and also over patients groups are very sensitive about their information being shared across health systems. And so for entrepreneurs to engage in this activity, it's going to be a lot harder given the sales cycle. So you need to establish trust with a healthcare institution for them to give you data. So if you're a new company, they're like, well, you're not going to exist in 3 years. Why should I sign with you? And so you see the incumbents like, Oracle, Bot Cerner, Epic and Microsoft are working together. And these are all big incumbents that people know that they're going to be there in the next 3 to 5 years. So I would say that there are opportunities, but you need to figure out what is your unique competitive advantage if you're a startup.
Sorry, it's funny because we didn't plan this, but actually when Jason was listing through the different portions of the healthcare industry that could actually be disrupted, I've seen multiple companies pitching some of those solutions in the last 6 months. So billing, for sure, there's probably 4 or 5 different companies out there on the billing side. It's complicated, but it actually shouldn't be a task that a human being needs to do, right? That's where I think AI can have an impact. Think about jobs that are repetitive, slightly complicated with specific rules. Those are things that AI can do better and more efficiently than humans. Even if it's not all the way right, getting through the vast majority of it and then having one last set of eyes, that's where AI can make an impact. We've definitely seen them on sort of the documentation and summarization. In fact, one company that we had met with and talked about, their premise was using some of the public tools from speech to text to actually allow doctors just to dictate the record and the diagnosis, probably in passing to the next patient, and have that go into the system and have that largely captured. And then at the end of the day, the doctor can make sure this is actually what I captured, and it goes to the sort of EMR. Like that actually saves time. And I'll use this example too, because then it allows the doctor whose time and skills should not necessarily be completely replicated by an AI platform to go see the next patient, which is the uniquely human part of the process. So I don't think humans are going away at all. And the chatbot one, I think, is actually pretty interesting because, I think you were talking about it from a perspective of telehealth and mental health services, which are, I think, more regulated and more controlled. But actually, when you think about some of the direct-to-consumer AI chatbot companies, they're kind of like the wild, wild west. And we've actually had an ethical discussion in our firm about whether we want to invest in some of these companies because they don't have guardrails. And many times the people that are lonely are also potentially teetering on being more susceptible to mental health problems. And if you sort of let an AI engine go on its own, it can take you to pretty dark places. And instead of actually making you feel better about yourself, it can make you feel worse. And so we've actually chosen not to invest in those companies because there aren't guardrails. And that's similar to many other technologies where, it comes out, you're not sure about the full impact, and then you have to, and I'm not a fan of regulation in general, but you have to have some kind of guardrails and regulation on how some of these products interact with people because they could have negative repercussions.
Yeah, coming to this summit actually remind me a slogan when I joined Cisco in 1992. That is, the internet will change the way we work and we pray and we live. I think AI also impact the society in that matter, the same manner too. So actually I find out when Cisco becoming such a big network giant, we see so many players, from the switch, from the even 3Com or Bay Network, they are the first mover, but they are not actually turned out to be the best, And I think behind it is because of Sequoia, venture capital. Venture capital behind it and give you the, steering the direction, the strategy, the execution, including the M&A. So I pay a lot of respect to the, venture capitalist founder, Don Valentine. He became the first chairman of Cisco and be able to steering the company to move into the right business practice and be able to harvest, the technology. So although AI is the hottest topic of the year, and there are still many other frontier technologies that are critical to our future. So I'd like to know that, Eric, can you share some of the key trends and innovation other than AI that may shape investment going forward, as well as opportunity that may be present in not just US, but in Europe? I know you just moved to London, so what's your perspective?
So let me I'll give two examples and try and be a little bit off the beaten path because that was what you were sort of prompting. The first one is we are seeing a lot more opportunity, interest, tailwinds, entrepreneurs moving into some sort of climate tech, environmental tech. And I'm not talking about things like carbon recapture plants. Those are great. Or people that are going to go sell you carbon credits and go plant trees somewhere else. Those aren't really venture business models. But particularly in Europe, where the regulatory burden for environmental benefit is stronger, the regulations are actually coming in place, and therefore entrepreneurs are rising to meet that challenge. And what we're seeing is a measurement of carbon footprint, for example, for companies. Where you can't actually say you're carbon neutral if you don't, you can't improve what you don't measure. You need third-party verification systems. A lot of that can be done through software and analytics. We are seeing companies, so we're looking at more asset-light business models. So companies like that I think are pretty interesting. And I think ultimately some of those trends that are regulatory driven in Europe will also make their way around the world. I think Europe is a leader on that dimension, whether you think it's excessive or not. I think that's the truth. California then tends to follow. Obviously, you see what California can do as far as the California Air Resources Board and dictating EV trends throughout the United States. But you're also seeing that pressure come from shareholders who are then pressuring the institutions like BlackRock, who are then pressuring companies. So I think there will have to be opportunities and entrepreneurs that are offering, again, probably software products to help address some of these challenges. And then I think the other one, which historically has not been an area that venture capital has been very tightly linked with the buyer, and in this case, I'm telling you, it's probably the government agencies around defense and defense tech. Usually, venture capitalists have not been eager to fund those business models because the buying cycle is challenging, the procurement cycle to getting through Congress is challenging. Congress changes every 2 years. Bills may or may not get signed. But I think as we are clearly in a new environment with respect to geopolitical tensions, I think people across the political spectrum and as entrepreneurs are recognizing that there's work to be done, particularly in places like information security, and that's in some ways an evergreen market for VC because there are always more bad guys out there. It just used to be bad guys who are trying to steal your money, but now you have state-sponsored bad guys who, that's their job. They go into their computer labs from 9 to 6 every day, and they're just trying to figure out how to hack your systems. That creates more interest in working with the private sector to sort of fund and buy the next generation of cybersecurity.
Yep. Jason, anything?
Yeah. So I want to go back to how people's lives, the way people live, have changed, and to discuss sort of potential opportunities. And so, during COVID, for example, most research labs are closed. Okay. So graduate students actually have to take turns. Like you actually get your slot. Sometimes it's 2 in the morning until 6 in the morning where you get to go to the lab because they can't have too many people in the lab. Okay. So now if you think about it, there's really no reason why people need to be in the lab because a lot of what you're doing in the lab, the pipetting could all be automated. But I think automation is one area where a lot of the things that they used to take humans to do. And you could run an experiment in your head and just ask the robots to do it. And so a lot of the wet labs, I think, in the future will become dry labs where you could just work from your computer. And that's a lifestyle change. The other thing is that during COVID, we also found that hospital is a dangerous place, right? Like people don't really want to hang out in the hospital for too long. And so particularly with the elderly. And so hospital at home is going to be more and more of a trend, I think, in the United States because also hospitals are very expensive places, right? So how to equip the home with the right type of sensors, the right type of monitoring that enables the clinical decision making. And, you can come in if you need to, but you don't really want to. And nobody really wants to go into the hospital unless they have to. They could eat their own food at home. They don't want hospital food. Okay. And so, our company, Cognito Health, is involved in remote patient monitoring of the elderly to prevent pressure ulcers and falls. And I think there's a lot out there that could actually, for the monitoring of an individual in the future. There are also exciting opportunities in healthcare for disease prediction, prevention, and early intervention. So the omics, right? So we have genomics, we have the transcriptomes, omics, the proteomics, right? The metabolomes, and all things are basically signals from your body that tells, could be sort of early detection of something that might not have shown up clinically yet, but you could detect it early by measuring. And so I think there are exciting opportunities after the human genome has completely been sequenced and now could actually be manipulated in a way that could lead to pretty exciting outcomes. And so I think there are these areas that are sort of emerging, and I think there will be great opportunities there. And I agree with Eric that there are some areas where you have to take two big problems and work on them together. Like if you could make all these equipments more environmental friendly, make sure they are more biodegradable, and as you move towards new technology, some of these big missions could be met together. I think that'll be great.
Yeah, Jason was interviewed by more than hundreds TV or radio interview during the COVID pandemic. I think he is really truly the opinion leader in the public health area, and also provide a lot of opinion to the government as well. So, and I agree with Eric. Cybersecurity is evergreen, and also continue to be a very I would say people are chasing after because there's an endless solution to these hackers. So I remember when I was with Cisco, we see cybersecurity is not that important because router and switching is still the bread and butter. So afterward, I invested one company called NetScreen from 3 people. So when I put in the money into that, I didn't know what I'm going to get out of that. But
a lot. That was a great investment.
But today, if you look at the cybersecurity, after NetScreen, not just one company, they exited about $4 billion valuation after 7 years of the first check. And after that, we see Fortinet, we see Palo Alto Network. Now their market valuation is enormous. I even keep not tracking of how much they worth. I know Ken Shea, one of the founder from NetScreen. He used to respect me or admire me as a rich man. Now I look back, he has more than $4 billion in his net worth. I say, what? So I think cybersecurity, the disruptive technology, really generated a lot of the wealth, and that's what the venture capital is really looking after that. So, let me switch the gear a little bit. Follow all this control, the exporting about us, sensitive technology, like including AI, including semiconductor equipment between the US and China. I think the supply chain is going to be disrupted, and the world is going to be different. I think there are going to be a two camp. And I would like to ask, what's your perspective on how the macroeconomy headwind and the geopolitical friction will impact investor and also the entrepreneur's behavior? Either way.
When we talk about geopolitics, I think to think about what are the causes of this geopolitical conflict, right? And so today, the United States is competing with China on big ideas. Okay, so what are these big ideas? One is, what's the way of life people want to live in? Is that a democracy or is that an autocracy? These are huge, very important big ideas in conflict. Technology supremacy that governs influence of these two big countries. And then the respect for the rule of law. So these are very big ideas. This is why US is currently in competition with China on these big ideas. And so when you think about how to strategically navigate this opportunity or challenge, I think you have to look at the root cause of these conflicts. And so even during the pandemic, where the world stops for 3 years, there are great opportunities during the pandemic, right? For example, Taiwan did very well. Why did Taiwan do well? Because Taiwan has a technology sector that was very vibrant during the pandemic. Everybody needs computers, everybody is online, semiconductors, there's a shortage. And Taiwan was able to keep on producing them because it has very few cases. And so that turned Taiwan into a competitive advantage for Taiwan. So in a geopolitical conflict, you have to look at what are the winners and what are the losers, and how do you position yourself so that you win more and you lose less, right? And then finally, the idea is don't put all your resources in terms of don't over rely on one market for your resources, and don't over rely one market for your product, for your market. And so this is sort of the core of competitive dynamics, right? That people are fighting for resources, people are fighting for markets. And when you are dealing with geopolitical conflicts, do not put all your eggs, don't put all your resources in one market, and don't put your product. And I think that would diversify your risks.
I have a few thoughts on this, perhaps unsurprisingly, and I'll try and hit them based on specific topic. But I'll start with capital. I think capital flows are very, very challenged, and I think that this is, China is basically uninvestable for Western investors, period. There's a lot of capital from mutual funds, et cetera, that, for example, is stuck. I mean, Ant Financial was supposed to be this amazing IPO, the biggest one ever, and then all of a sudden, one person made a decision to shut it down, and the company's value has been crushed. What their business model was forced to separate, and foreign capital is probably never going to get out. I mean, a lot of the investors have marked it down on paper, but they actually haven't gotten their money back, and unclear whether they can. It'll be unclear whether non-Chinese investors in ByteDance can ever actually get their money out, or if they do, at what price. And so the thing is, when you have things like that happen overnight, investors hate uncertainty. They expect a certain set of rules, and then they expect to be able to invest and then into companies that can compete within those rules. But when the rules of the game change overnight, and then you have nothing to show for it as an investor, you don't forget that, because the trauma of that investment outcome was outside of your control, and it happened so quickly. And you can see in this sort of bipolar world that China started to realize they have some problems. They have some demographic issues. They have some really bad debt issues that, in my opinion, will make the Japanese property and bubble and the debt bubble of the 80s look trivial, because it's a much bigger country. But they're trying to soften some of the controls that they put in. So these are all self-inflicted wounds. I mean, they're trying to soften these controls. But again, I think Western capital is going to say, fool me once, okay, fool me twice, shame on me, right? Like that's how that typically goes. So I think capital flows are going to be bifurcated for the foreseeable future, because people have memories, and then eventually, if they forget or things change, maybe they'll invest again. But I think generally capital flows are going to come to a pause. I completely agree with Jason's point about diversification, both in terms of supply chain, which you're starting to see, of course, right? I mean, Apple has been talking about this for quite some time, moving their manufacturing to other places, including in India, including in Vietnam. I think that trend is going to continue. It's just going to take a long time, because for decades, the world relied on China to build things for everybody. No longer will the world do that. And on the flip side, I think there's now a new awakening, or a reawakening, that probably never should have been forgotten, that it's an unequal playing field when you're a Western or non-Chinese company trying to invest in China, right? Just to remind people, when Volkswagen went there, they were bringing all the technology for the cars. They were bringing all of the models and everything, but they had to form a JV of which they could only own 49%. That's, they accepted that deal. But now I think as people I mean, David would know this from Cisco. There was clearly forced IP transfer, and I think now companies again realize this. And so there was. I don't see this changing anytime soon, unfortunately, and I think it'll be quite some time before people are willing to invest and dedicate resources to less friendly political regimes. In fact, we've seen this in our portfolio companies. They've moved people and operations out of unfavorable jurisdictions because they're unpredictable.
Yeah, I can, witness what happened to Huawei and Cisco in the year 2000. That all of our software, iOS IP was not respected. Yet we cannot do anything about that against Huawei in China or in US. So we end up, but the government cannot do anything about it either. So I think that's a long overdue in terms of IP respect. But I think right now the US government is trying to do something about it. So given all the pandemic and also the geopolitical factors that a lot of the valuation of high tech or even the capital inflow to the venture capital has been dying or dry out. So Eric, I would like to see your perspective. What's the current state of, and what's your prediction about the capital market will become, in a couple of years?
So, I don't think we can talk about the next couple of years. I'll just a quick second on what happened, which was obviously during the pandemic period, we had something happen which had never happened before in human history, which is every single reserve currency in the world was being printed in mass quantities, and every single major government was incurring massive amounts of spending to keep the economy moving. You can debate whether or not the magnitude was too great. In hindsight, it probably was, but it happened. And so now we're dealing with the aftermath. What also happened with all that currency and capital being created is that it had to go somewhere. Economies didn't just expand at the same rate that the capital base did. And so that came into all kinds of assets, real estate, public stocks, private stocks where I invest in the venture capital business as well. And now, obviously, rates are going up, money's coming out of the system by design. It's going to take a while, but that means that capital has also left the tech industry. And in '99, and even in the financial crisis, the technology industry was a smaller percentage of US GDP. I'm just talking about the US for a second. Was a smaller percentage of GDP. And so if you had interest rate sensitivity or weaker demand, it was from non-tech companies. It didn't really affect technology companies that much. But now, actually, for the biggest technology companies, oftentimes their biggest customers aren't other technology companies, but they're non-tech companies because everyone has adopted software and cloud computing and things like that. And so when those companies face real demand weakness, intentionally incurred by the Fed for good reason, that is now flowing through into tech companies where it's harder to grow your revenue. And so as a result, you couple that with the change in the capital market environment, investors are much less willing to invest in high growth, high value, high risk technology companies. Then they have to make sure that they make their liquidity balance last, their cash balances last. And that's where we saw a lot of the layoffs across the tech sector over the last 2 years. And it's actually still continuing. Maybe they're not making headlines as much anymore because it's old news, like who hasn't had a layoff at this point? But that's going to continue for some period of time. And this may sound a little bit counterintuitive, but I'm actually okay with that. I'm actually kind of happy about that. Because at least for the venture capital industry and for someone who has been in the industry for 2 decades, whose firm has been in the industry for more than 4 decades, I'm actually happy to see what we affectionately call the tourists leave and go home. So valuations have come down, round sizes that companies are raising at any stage have come down. Because the model used to be, if you were a company, you raise what you need to get from point A to point B, and then you prove that it's working, and then you can raise the next round to get to point C on this journey. You're not trying to raise all the money you're ever going to need to take your business to its end goal at once. Yet that was often happening in 2021. So I think the environment is more normalized, if you will. Actually, I think it could probably normalize a little more and become a little tighter. But I don't expect a fast rebound, and I don't think that would be healthy anyway.
Yes, I agree with you. Maybe that's one of the, I see this happening. The cyclical, up and down, and one of the, maybe a good opportunity to invest at a fair market valuation. Yeah. As a founder, Jason, how are you going to survive or thrive in this such kind of challenging environment?
Well, I'll talk about survival first, because I think thriving comes later. As you know, during COVID, hospitals, you're not allowed to go into hospitals. Okay, only the people who need to be in the hospitals are allowed in the hospital. So when we're trying to sell products to hospitals, that was basically no. They don't talk to vendors, nothing like that. Okay. And then after the Silicon Valley Bank kind of tanked, and it became very, very difficult to raise funds. So what did we do during this time? So we kept on reflecting, are we solving an important problem? Right? So when you're a startup, you want to make sure that the problem you're trying to solve is important to society, and it will be there, and it will probably grow. Right. So when we look at it, yes, we are solving an important problem. It's the elderly population. There's going to be more care, probably both at home and in the hospital. Then we need to be hyper-focused. So what is something that we need to do? Not want to do, not, sort of, adding bells and whistles, but what are the one thing that we need to accomplish during this time? Okay. And what's the budget impact for every single hire, right? So, when you can't turn on the faucet like you used to, you have to conserve water. You have to make sure that every drop of water goes somewhere, and that each effort needs to be accounted for, so that you could flow longer when your tank is less full. And using that, we identified some key areas to our business model, and we moved everything online to the cloud, and to make it easier to deploy. We make all systems integrated, so it's one system versus multiple systems, and so it's easier to deploy both at home and in the hospital. It's the same system, it's in the same cloud, and so and because we can't visit the hospitals, we could work to optimize our technology. So we increase our capability in those areas. And so it's very difficult to survive. It's the hardest thing that I'm doing. Being a professor or being a doctor is less stressful, believe it or not, than being a startup founder. And but it's an experience that I think that makes me more focused in many ways.
I'm with you because I know how you've been through. So I have been.
You've been extraordinarily helpful.
Yes,
Great,
we are partners. So
wonderful.
I know the situation changed. We want to be more dynamic and adapt to it. And we need to move faster, right? Agility. So that's how you transform the startup that way. It's not always like you have planned, but you have to detour. Sometimes make you a stronger, come up with a stronger competitor. So as we all know that Taiwan plays a critical role in global supply chain in terms of high-tech and also biotech realms. From your perspective, what kind of industry competitiveness that Taiwan possesses and could be further harnessed in terms of staying in a good position of global supply chain amid economic uncertainty? You can go first.
Okay, I'll go first. And so I think Taiwan as a global supply chain partner has several advantages. Okay. The first advantage is that the Taiwanese people work extremely hard. So you could just look at the way TSMC, how it runs its operations in Taiwan, and when it's trying to transition to Arizona because of culture and different other issues. In Taiwan, I think there is the level of training, education, and ethics, work ethics, make it a great supply chain partner. And the second advantage is this trust that has been built between US entrepreneurs and Taiwan supply chain partners over the last 30, 40 years, starting with the semiconductor industry, then the PC industry, then the Apple supply chain. And these partnerships require a lot of trust. And once that trust is built, it's no longer transactional. No longer I buy this from you this time, I buy it from somebody else next time. It's a relational partnership. And when it becomes a relational partnership, it's more resilient. So to build a resilient supply chain requires fundamental trust and repeated business and the ability to actually deliver. And so I think that's the advantage that Taiwan has. Now, Taiwan could improve on one or two things. One is grow more business talent so that understanding more of the business models that's applied globally and upgrade its language capabilities and cultural capabilities so that when Taiwanese entrepreneurs come to the US or elsewhere, that they know the culture better, they know what people are thinking. That will build even a better partnership to supply chain.
Yeah, actually, last week I was this week I was in Tokyo, attending the startup. Similar things, they try to become also entrepreneurship, and they declare that's the first year of the entrepreneurship for the startup in Japan. I was so surprised that they, one of their congressmen, leader in the Congress, they're saying that. As I recall, 8 years ago when I was called to help out Taiwan to connect to Silicon Valley, actually that's the theme that we decided. We're going to, foster the entrepreneurship and be able to bring up the Taiwan from the efficient, economy to a more innovation economy. So I think Taiwan supply chain, for these days, I travel into Europe and also to other part of the country. They always, admire what we have accomplished in the ICT business and in the advanced manufacturing area. I think that's the strength that we really want to, build on top of that and to really lead the supply chain in the world. Last but not okay.
Actually, I think Jason also made a really good point about the world is more interconnected, and so you're working across borders, but importantly across cultures. And I think there is an opportunity for improvement there to read who your counterparty is. If you're coming from Taiwan or from Taiwanese culture, you're typically quite humble, and that plays very well in some markets, and it's very different in others. The United States, Americans are renowned for being a little bit more outgoing and optimistic, and maybe a little bit more braggadocious. So I think there are other societies, like in the Nordics, for example, that are actually quite similar in terms of humility and their willingness to work hard and high integrity and high honesty cultures. The point is, if you want to be successful globally, you have to be able to interact and capture the attention and build a relationship with people of all types, because the substance is there. The substance is absolutely there when you're talking about what Taiwan is capable of and what Taiwanese companies are capable of. But the marketing could probably use some improvement.
Okay, so last but not the least, maybe an easy, maybe a challenge question for Eric. I get to ask by some of my friends in the audience. So they're very interested in getting into the venture, sector. So what's your advice to those who would like to join? And anything that they need to be prepared, or is this a sexy sector that you encourage them to get in?
I don't think it's as cool as it was 2 years ago. I think if the number one thing I think you need to be in this business is probably curiosity, because as in any investment, there's a saying I really like is that the past does not repeat itself, but it often rhymes. So there were lessons learned, and I brought that up around search engines and Google to illustrate the point about AI. But you have to be curious enough when you see something new and you ask yourself, is this worth investing in? Is the market big enough? Will the customers actually switch from one to the other? Will this business model actually make sense? What is it about this person that you might trust with your capital makes them tick? what's their actual motivation? Because certainly the last couple of years, there were a lot of people who wanted to be founders because they thought it was cool. Like that was, they want to be in TechCrunch and on Twitter or whatever. Not really that substantive, particularly when it gets hard like it is now. So probably, the number one piece of advice is to be curious and don't stop your investigation or analysis at the first step or the second step or even the third step. And take the opportunity to meet people, because every meeting that you have, you're either going to feel better about someone and the opportunity or worse, but it's guaranteed not to be the same.
Well, thank you for the conclusion. I would like to thank you, Eric, and also Jason, to join us such a insightful discussion and fun. I hope that you also enjoy, and I hope everyone also enjoy our chatting. Thank you very much. Yeah.
Have a good trip.
That's right.
Good afternoon, everyone. I'm Sherry Leon. I'm the president of the Bay Area Taiwanese Biotech Association. Let's switch our focus to the latest trend in biomedical field. It's my honor to introduce our biotech keynote speaker for today, a superstar in the field of biotech and oncology, Dr. Sonny Xiao. Dr. Xiao has over 14 years of research and development experience, spanning biotech and academia in the area of oncology, cell therapies, and immuno-oncology. He has served in leadership roles including chief scientist and CEO, and is a co-founder of Acepodia, a clinical stage biotech company dedicated to developing innovative and high-effective cell therapy for cancer that are accessible to a wide range of patients. Dr. Xiao has navigated his journey from identifying preclinical candidates to secure FDA approvals. Notably, he successfully brought his own Berkeley Research cell therapy drug candidate through the process, obtaining IND approval and initiating clinical trials in the US. Today, we are excited to welcome Dr. Sonny Xiao to the stage. His wealth of knowledge, visionary leadership, and pioneering spirit promise to inspire us in the world of biotech and oncology as he takes us on a journey into further on career treatments through arming T cells with antibodies through click chemistry. Please join me and give a warm round of applause to Dr. Sonny Xiao.
Thank you. Hello, everybody. It's my honor to be here. And I think this year I already have more than 10 presentations or speech in the afternoon. They like to have me in the afternoon because whatever delay they have, I will make it up. Okay, so I think we're 5 times delay, so I will make it up. So today I want to first, again, I'm very honored to be here. I'm a Taiwanese kid as well, grew up in Taiwan, and then also go to college in NTU, Taida. I'm wondering who is from NTU? Raise hands. Yeah, I have a good amount of alumni. Yeah, so yeah, Taida is good. And then today, I think I'm more taking off my my mom's room. So I'm a major in chemistry as a chemist from NTU, major in chemistry. But my mom is also graduate from NTU literature. So today, I think I'm probably more of be my mom as a teacher and professor, let you know what we do, be a good literature or professor to describe what you do. I think what I would like to promise you is that after my speech, at least you know little
what biotech do or what biotech company is doing, and then why and how we're trying to make the world a different place. So our company is called Acepodia, and then I think those words, if you're not reading our field, if you're not chemistry or biology background, you probably can read all of them. Arming T cells with antibodies through click chemistry, but together they make no sense, right? So you can understand individual of them, but together that means nothing. So today, again, hope I be my mom, and then not a chemist head, but more of a literature, and then showing what we really do in a simple concept. So company-wise, I'll also be honored that my PhD advisor, Caroline Bertozzi, also the core technology derived from her lab. I was a PhD student in her lab at UC Berkeley. And then we invented the technology now Acepodia use to make anti-cancer drug. Honorably, she and then also the technology has been rewarded Nobel Prize last year in chemistry. So it is definitely honor, but it is also quite good because before the Nobel Prize, every time we talk to the pharmaceutical people, they're asking, what is this? What is click chemistry? What is that? How do you make it? What is your research? What? After the Nobel Prize, no question. Okay, everything we do, no question. Yeah, but I guess it is the highest honor, right? And then also highest validation of science. So after the Nobel Prize announced, now we get no question from all the Pfizer people, Merck people, and then all these J&J people. Now they don't have question about the science, which is good. And then based on that, what is the Nobel Prize really is for last year chemistry? It is a chemistry called click chemistry. So click chemistry, it is really a chemistry that can link two different molecules, molecule A and molecule B, link them together in a very reliable, reproducible, and efficient way. Sounds very easy, right? And then why this can be a Nobel Prize? Because through the years, chemistry actually mostly go into the different directions, making things more complicated. So I can synthesize this molecule. It has 16 carbons, 23 hydrogen. Oh, so I can synthesize another one. Oh, I have 18 carbons, 30 hydrogen, so I win. So it make more and more complicated product become kind of an arm race in the chemistry field. However, the click chemistry is on the other side of spectrum. Instead of making things more complicated, can we use chemistry a simple way, very reliable, although it's just maybe one chemical reaction, but very reliable, very reproducible, can happen in any type of environment, in any type of solvent, and then make things happen. So click chemistry is the chemistry that can do in this. Take analogy, it's like a Velcro. Okay, so Velcro, you have one on this side of clothes, one on this side. If we put the Velcro together, they will bind to each other, right? But the Velcro will not bind to the other parts of your clothes or shoes. So click chemistry has this very special type of uniqueness, and then it becomes Nobel Prize. And then the name is click, but there's another term. Sorry, I do need to bring another term, which is called bioorthogonal. Orthogonal meaning that it will not cross-react. So bioorthogonal is the same idea, meaning that this chemistry happen again like Velcro. Two handles will holding hands. However, they will not affect other parts of your clothes. So they will not affect all the other biochemistry happen inside our body. I think that's the beauty why I joined the chemistry / biology world because I did get admission from Taida Dianji, but I didn't go. I then won the chemistry Olympia game that happened. So I get to choose any school, any major I want for college. And then I decided to choose chemistry. I actually got admission from electronic engineering. I also can choose medical, be a doctor. But yeah, I think chemistry is I like. And then the beauty is this, right? So the biology, chemistry, they're a complicated system, but they are also very beautiful. And then among this complicated, beautiful system, my advisor, Caroline Bertozzi, invented this chemistry. It's very complicated, very beautiful. However, we have simple chemistry that can link two molecules together, very efficient, very reliable, very reproducible, and then doesn't affect other things that are going on beautifully in the biological system, in our body. So this basically the platform we have. And then, so what we do with it, right? So what we do with it. So so Acepodia and then my research do is that taking this click chemistry, this Velcro system, we link T cells, which is an immune cells that defend cancer cells, defend virus, defend all these pathogens in our body, and then link them with anti-tumor warhead. So that in essence, that's pretty much what we do. So link the immune cells, which is the army of our own body, to a warhead that can recognize and then target tumor cells using click chemistry. So this is also basically what we trying to solve. So this, for us, the end goal is to help cancer patients. And then cancer cells, they generate it every day. Okay, so like right now, every time, every day, there are 100 to 1,000 cancer cells generated every day. But we, at least all of us, we didn't have cancer. That's because our immune system, our immune cells wipe them out every day until they are not strong enough. They either first, oh, sorry, this is not the laser pointer, until at least they are no longer recognize the tumor cells because we grow old, we have a mutation accumulated, there are other factors, so the immune cells cannot recognize cancer cell anymore. And also second, when we grow old, accumulated mutation, there's also potentially T cells, which is the largest army of our immune cells, they get exhausted. So those two factors results in they can no longer control or wipe out cancer cells. Again, cancer cells happen every day. 100 to 1,000 cells will turn malignant every day. They all got checked or wiped out by our immune system. However, when that system become imbalanced, then it become cancer, it become tumor. So what we do is we're trying to address those two challenges, or you can say those two mechanisms happen in our body. So the approach we take are two of them. One is that, as I mentioned, one is the T cell exhaustion, T cell getting old. For that, we have one platform. So for this mechanism, our approach is that we get T cells donated from young and healthy donor, and then use those T cells to supplement for patients' old T cells. In the term, it's called allogenic T cell therapy. Allogenic means we're taking the cells from another individual, treat patients. So this is one platform we have. And then the second is one based on the click chemistry, is that we can link the anti-tumor molecule, which, for example, an antibody, to the T cells using this click chemistry. And then this antibody serves as a warhead. So it's kind of an anti-tumor warhead. Even if T cell themselves can no longer recognize tumor with this warhead, they can re-engage and then target tumor cells. So this is basically the things we want to do. I think it's biological system is difficult. However, the idea or concept is quite straightforward. In essence, we trying to help patients, provide them a young and robust T cells. In addition to that, those T cell has a warhead, has type of a GPS. They can find, recognize, and then target tumor cells. So this is looking closely, but again, long story short, I think in essence, we were able to use this chemistry called click chemistry and then get the antibody link to the T cells, and then specifically on the T cell receptors, on the protein, specific protein on the T cells. Again, this is the beauty of this chemistry. With the click chemistry, again, I can the beauty is that like Velcro, right? So when I want to put it together, then I put it together. If it's not a Velcro system, if not the click chemistry, when I generate the whole thing, your clothes is already attached. So you cannot open it or close it. So the beauty of the click chemistry is that I can make this part, I can manufacture this part first, and then this part, and then eventually at the timing, at the stage I like, then I can click them together. And then this type of this powerful chemical reaction allows us to make what we want, which is put an anti-tumor warhead onto the T cells. And then another part is which T cell we use. Again, I briefly mentioned the T cells we use to treat patients is an allogenic T cells, meaning that it's from a healthy and young donor. So why from a healthy young donor is also quite obvious, because their T cells are young, right? And so be more robust and energetic, not exhausted. So from this young and healthy donor, also another spatial criteria we have for these T cells is they are the one called gamma delta T cells, but that's just a name. It's named after the specific protein expressed on the T cells. But this type of T cells is very unique because when we are newborns, when we are babies, all of our T cells are gamma delta T cells. But when we grow old, like all of us here now, as an adult, 90% of T cells transform to alpha beta T cells. So why we use the gamma delta T cells? Because it's the 100% of our T cell from embryo to newborn, they do not reject mother's cells. So they are a perfect cell type for the allogenic use, because you can get from a donor A or donor B, and then use those cells to treat other patients because they don't reject. That's their design by nature. So these are the two platforms we have. And then this is just briefly how the manufacture flow look like. I do chemistry, right, as you know, so I know this process probably a lot easier than TSMC. But anyhow, so so first we get the blood donated by the donor, and then from the donor blood we can expand this gamma delta T population 10,000-fold. So that's why we can get one donor, we can treat 1,000 patients. So I think that's also a beauty of it, right? So so actually from this one donor, he were able to definitely, with our manufacturer, he will able to help 1,000 cancer patients. So after we can expand these gamma delta T cells 10,000-fold, then we do this click chemistry to get the warhead, those anti-tumor warhead, onto the T cells. we freeze the cells, like the BNT, Moderna, you freeze those vaccine, and then you can ship to the hospital. When the cancer patient need a treatment, when their immune system grow weak, and then the tumor become out of control, then they can use the drug to treat those tumors. And then this just a simple comparative landscape. So you may ask, so this is a simple concept, right? You put a warhead, you put a GPS on the T cells. Other people may have thought of it. The short answer is yes. However, here is the difference of what we do and then other companies right now. So so probably from the right to left. So currently, a company A, another biotech company in the US, so what they do is actually quite interesting, and then also very scientific. So what they have done is that if they only use the warhead, okay, no cells, well, we just use the warhead. Maybe warhead can just work by itself. So if they just use the warhead, the response we got, so this is, sorry, another term, the ORR is in our medical field, stands for overall response rate, meaning that the tumor have response to your drug. Also means the percentage of patients have tumor shrink. So only use the warhead, 30% the patient have their tumor shrink. However, when they doing the things we want to do, the same idea, we put the warhead together with the immune cells. When they did it with MD Anderson, the US #1 cancer center, this response rate go up to 97%. Meaning that once you put the warhead, not by itself, but you put it together with the immune cells, the response rate, 97%, meaning 97% of the patient treated with this product have tumor shrink. So this is a significant increase using the warhead or using them together. However, so for Acepodia, we can do, probably the most important is here. So so this one, for what I can do, they want to do the same thing. They want to have the warhead on the cells. However, we have the click chemistry they don't have. So for them, the warhead bind to the T cells just through the we call protein-protein interaction. So the caveat is that this protein-protein interaction is weak. So after they make their product, they cannot freeze and thaw the product. As we mentioned, this is an important cold chain, like BNT, like Moderna, all these vaccines need to be frozen and then shipped out. So for them, the clinical trial they have actually on fresh cells. What's the fresh cells mean? Fresh cells means they are not cryopreserved. So after they generate the cells from donor, they put the warheads on. They need to use it right away. They cannot freeze the cells because when they freeze and thaw, the antibody will fall off. Antibody is the name of the warhead. So so this become problem because to me, this is not commercializable, right? Because it cannot be commercialized because it's almost impossible when the cancer patient go to the clinics, then you find the donor to donate the cells and then doing all this, and then use the fresh cells cannot be cryopreserved. So our strength in this case lies in because we have this click chemistry which form the covalent bond between the warhead, which is antibody or T cell engager, to the T cells so that our final product can be freezed and later thawed. The warhead will still remain on the immune cells, on the T cells. So this is pretty much what we do, and then I think that's also kind of an interesting type of science or technology we do at the interface of chemistry and biology. And then we've been the only one because we possess this click chemistry tool, and then also the technology platform. So we were able to generate covalent bond between those warheads and the immune cells. With that, this is our pipeline. So the good thing about our technology is that it can really mix and match. So we can put different warhead on different type of immune cells. Immune cells, the biggest one is T cells, but there are others as well, such as NK cell and macrophage. So our technology platform allows us to mismatch all these different type of immune cell and then also different warhead. Why that's important? Because against different type of tumor cells, then we can have different warhead to target them and then to recognize those different type of tumor. So currently we already have 2 products in the clinical trials, and then the third one going into the clinical trial next year. For example, the first one is targeting HER2, so meaning targeting the HER2 molecules expressed on the tumor cells. And then those are for breast cancer, gastric, ovarian, endometrial, those type of cancer. The second one is targeting CD20 molecule on the tumor cells. This is for leukemia and lymphoma. EGFR upcoming is targeting EGFR molecules on the tumor cell. All similar concept, just mix match, switching the warheads. And then EGFR is for head and neck, lung cancer, and colorectal. Yeah, so this is the idea. I think this basically, with the 2 platform we have, we can go from warhead to another warhead and then generate different drug candidates against a variety of different cancer. So with that, this is our team. Again, this never done by a single person, and then I'm very honored and then very lucky to have a very strong team support me on this journey. Thank you. So I think that will be hopefully today I take a good head of my mom, and then we're able to describe to you what we do in more of a simple type of a concept. And then look at, I think I got that 5 minutes back. So I'll hand it to our panelists, which they are all awesome, and then can share you the more deep and then recent development of biotech. Thank you.
Good afternoon, everyone. Let's welcome the biotech session speakers on the stage. Can you change it to the speaker slide? Yeah, there's an order. Okay, in this order. Hi, everyone. Welcome to the biotech session. I'm the moderator, Linya Wang. I'm currently working in Twist Bioscience, which is a synthetic biology company. We're utilizing different libraries for antibody discovery. So before we start this session, we wanted to know how many of you are working in biotech. Please raise your hand. Okay, thank you. So now our speakers have a brief idea. So before we start to ask questions, I'll let the speakers to introduce themselves first. So let's start from Leon.
Hi, everyone. My name is Leon Huang. Before I introduce myself, I would like to thank for Leah actually invite me to this forum and also the committee of the summit. Give me this opportunity to come here. I live in San Diego, actually. I flew here and then had the opportunity to share my experience. So I'm currently a director of immuno-oncology discovery at Pfizer. And I'm leading a group of 18 scientists, including 9 PhD, responsible to develop novel immuno-oncology therapeutics, starting from scratch, from target discovery, all the way to modality generation, identification screening, and then IND filing and first in human clinical trials. So my group pretty much covered the early discovery all the way to phase 1 trials. And that's one of my current responsibility and job function at Pfizer. I have another responsibility and job, which is associated with Northwestern University. Currently, I'm the adjunct associate professor at Northwestern University, where I collaborate with the faculties in the pharmacology development and help and then mentor their immuno-oncology research, including manuscript preparation and also RO1 grant submission. So, I kind of had both flavor of industry and also academia discovery research currently ongoing simultaneously. And I found that is a very fulfilling experience I currently have, and I wish I can provide more insight and experience with everyone. That's my brief introduction. Thank you.
Thank you. And I-Chueh.
Hi, thank you for the chance for me to participate in this symposium. So, I'm I-Chueh Huang. So I'm currently working for Johnson & Johnson in the gene therapy department and a principal scientist. So currently I'm focusing on develop different kind of new platform for gene delivery. And also one important part for my work is to find the immune mitigation strategy. So for gene therapy, we don't want immune response, totally different from oncology. So we need to consider from the opposite side, yeah. So before joining J&J, I did my medical degree in Taiwan, National Taiwan University, and I also practiced there for 3 years in internal medicine. And then I did my PhD and the postdoc in Harvard University, and so my focus was virology. So I stayed in academia for about 8 years. So, and then I jumped to the industry. So I think it's highly possible because of my medical background. So I really want to do something more relevant to patients. That's why I joined the industry.
And Andrew?
Yeah, thank you for inviting me here. It's an honor. So my background is actually pretty broad. My undergrad major was in physics. So people who study physics, they usually don't like biology. I didn't like biology. But in my third year of college, a professor introduced me to use physics to study protein structure. And then you can use physics to study protein-protein interaction. This is not simulation. You can actually use microscope to look at protein and protein interaction, the dynamic. And I thought that's really cool. You can apply physics to study biology and to study disease. So I decided to pursue my biophysics PhD. So I went to Michigan, University of Michigan for biophysics, where I did a lot of things. I was building microscopes, so I need to know some mechanical engineering, so I need to mix a machine so that I can put some sample onto the machine. I need to write software to control the device. I need to write software to analyze a lot of images I took. And then I had to learn how to handle mouse, because I was doing some Alzheimer's disease study, and we need to culture some neuronal cells. So I did a little bit of everything. After that, I went to Genentech for my postdoc. Initial goal was to become like the expert in imaging, no matter it's MRI, PET, or basic microscopy. But long story short, I discovered my true interest, which is protein engineering. I didn't know what was protein engineering at the time, but I fell in love with it. And also the combination of that with machine learning, especially natural language processing, or people call it nowadays language model. So that two combination make me fall in love with this field. And long story short, 2019, I think my idea is pretty mature. And it's not just an algorithm, it's a process of generating data, power the language model, learn, predict, and then validate, and then generate another set of the data. That feedback loop is really powerful. And I think if I stay at big company, this technology cannot really benefit other companies. So I quit my job to form this company. But I didn't have any experience building companies, so I instead joined a few startups. So I joined a Series A company that was doing protein engineering. And then I joined a Series B company that was doing cell-free DNA diagnostic, and then a Series C company that was doing CRISPR gene editing. And then this year, I think my company is pretty mature, and the market also very mature. So I decided to focus on my own company full-time now. Thank you.
Thank you for the background introduction. So first, I would like to start with personal journey part. So for Leon, I would like to know that after your graduation, you mostly joined a big pharma. Can you talk to us about like resources, why you prefer big pharma? How about the collaboration, the eyesight? Is that the part why you always choose big pharma?
Yeah, so I need to go back to my graduate school study first. And I think that intrigued me to pursue my career in industry, particularly big pharma later on. So when I was a grad student at UCLA with immunology major, I happened to have the opportunity to invent immunotherapeutics called cytokine antibody fusion, and then licensed to a small company for clinical development. And then, I witnessed the whole process from the start of the idea, inventions, and then license to the companies and push to the phase 1 trial. The struggles, the excitement, everything in the whole journey. And then, although the drug pushed to the phase 1, but however, eventually the company cannot continue the drug development beyond phase 1 because they lack of funding, because they are a small company, they don't have sufficient funding. And then at that time, the cytokine antibody fusion is a very novel idea. At least there's no FDA-approved cytokine antibody fusion yet for immunotherapeutics. So they have struggled to secure enough resource to push the drug forward. So I realized the challenge working in a small company, because that could be the challenge I was facing if I chose a small company. So after my postdoc training, I pretty much determined I want to go to industry, because with my experience in drug development and immuno-oncology. And then, I applied multiple positions across small company, mid-sized company to large-sized company. And then, fortunately, I got interview offer for all the companies. And then, even though, I'm pretty sure that I don't want to go to small, mid-sized company, I still go for interview for the purpose to understand what they are doing, and also understand their culture, and also understand the way, the difference between big pharma and small company to execute, to initiate the program, how they move the drug program forward. So from there, pretty much see that actually in the big pharma, you can see the whole portfolios, different diversity of the drug development program that impact the different perspective of unmet medical need in patients. And small company, most of the time, they can only focus on 1 or 2 areas, or one or two targets at most. So, I feel like for my career development, if I put myself into big pharma environments, I'm able to learn more, actually see the whole picture. That's definitely more beneficial to put into the more narrow scope environments that my experience will be limited in that kind of setting. So that's why I pretty much determined to stay in big pharma. And then, as you work in big pharma, you get more visibility, more experience, there's more opportunity, including internally, externally coming up. And then, that's how you grow your career. And then, I've been taking that advantage and identify even more better opportunity in other pharma. So, my career started at Amgen as a senior scientist. And then later on, I have the opportunity to move to AbbVie as a group leader to lead a group of multiple PhD. And now I grow into a director role position at Pfizer, leading the much bigger group, and also supervise multiple drug development programs facing from very early stage all the way to phase 1. So I feel this journey is very fulfilling, and also I get a lot of experience, which I don't think I can get similar experience if I start with in a small company.
I see. And then for I-Chueh, you have a very interesting resume. You start with MD by training, and then you go to USC, where I know you as a professor, and now you join industry. So can you share with us how you make this decision and compare different experience?
That's a good question. So what there was in National Taiwan University Hospital, so there was a SARS outbreak. Yeah. It's probably the main cause for me to decide to do a PhD, because I have the curiosity about mechanism, about the tiny things. So, and I applied the school, and fortunately getting to Harvard, and also a turning point, because when I grew up, so I need to listen to my father. So for whatever reason, I did the MD for my father. So, and then I have a chance to get out to do what I really want to do. So that's why I changed to the biology field and start to do research. And in my research career, the good thing is you can do a lot of things you are interested in. There is no limitation. And but the thing is, if you run your own lab, the resource is quite limited, and then you pretty much need to do everything by your own. And then even you can find some collaborators, so they do have different priority. So sometimes you feel a little bit exhausted in the academic field, and it's a highly intensive working environment, I would say. And when you stay in the academic for a long time, you do very detailed molecular pathway or very specific mechanistic studies. So sometimes you just feel you lost the whole forest. You don't know the potential clinical application of your research. So that's the difficult part for me. That's why I think probably working in the industry can give you a better opportunity to redo something more relevant to patients. It's why I decided to change my career and luckily get into J&J. So, and in the industry, you do have a lot of resources. Yeah, and you don't need to do everything by your own. So you can easily find expertise, different department, especially for big pharma. Yeah, so it's the thing. I think I did the right choice. So yeah, I'm happy for working for my current position.
Thank you. And for Andrew, actually, you already answered why you start your own company. So my question is for you is that why is it AI? And why do you focus on protein? What application are you working on?
Right. Maybe I'll start with why I decided to focus on this. As I mentioned, my training was in physics, optics, and microscopy. So my first postdoc project, also my last project, is to look at T cell, be able to visualize T cell in human body, take a bunch of images, and then predict the T cell concentration around the tumor. And that allows us to estimate how well genetics immunotherapy works. And at the time, I think Sonny also mentioned, we have a lot of antibody that can bind to T cell. But the problem for us is the antibody is very good for making drugs because they circulate in the body for a really long time. But as an imaging purposes, we don't want that long circulating time to interfere the signal. So what we want is a protein that can quickly bind to the T cell. We take a bunch of images and then fall off and clear by the body. So, and we don't have any protein that can do that. That's why I got into protein engineering to try to search for that protein. And I didn't know what protein engineering mean at the time. And you can think of like software engineering. Software is that you are writing computer code to ask the computer to do something. Protein engineering is, if you don't, can I ask how many people know what protein is? Or you don't, if you don't, okay, good. I didn't know. I mean, I thought protein is like chicken or egg, you have protein. But it turns out, so protein is a sequence of amino acids. It's like a human language without white spaces, so just characters. And And each character have 20-ish different amino acids, A, B, C, D, E, F, G. So what you wanted to do in protein engineering is that you are manipulating those amino acids. You hope that this protein will do something for you. So that's protein engineering. And turns out there's a really cool technology that you can generate 10 to the 11th different proteins. So that's pretty big number, and that's a big data set for doing data analysis. And this is not simulation. This is actually in the lab. You can ask a virus to produce a lot of protein, different protein you want, and then you do measurement. Now, the problem there is at the time, 2014, when I joined the company, you can generate 10 to the 11th, but you can only look at few hundred and then pick from few hundred which one can bind to the target. So that's you have this many data as an input, but you're only looking at this. And I thought this must be a better way that can look at much bigger data. And at the time, NGS, next-gen sequencing, is another very cool invention in the industry, and I love it. That technology is being used to study disease, study how gene mutation affect the disease, but not a lot of people use that in protein engineering. So I kind of introduced that technology into the company, and I wrote a lot of software to analyze the data. So what that turns out is now you can analyze hundreds of thousands of protein sequences. With that amount of data, you really need some kind of machine learning. And because, like I mentioned, it's alphabets. So you need some kind of like a language model to analyze those. And that's how I got into the field. And I've been thinking about that for a long time. And in 2019, I think my idea is pretty mature. I applied for a grant within Genentech. There's a grant called Innovation Fund that you can propose an idea. They give you money, and then you can use 1 year to do your research. So I proposed my idea, and then I got an email after a few hours. They say, I'm sorry you are not in the research team. So at the time, I was hired into another department, not part of the GRADE. GRADE is a research, Genentech's research. So I was in different department, but I still had this idea. So I applied, but they say, you are not in GRADE, so you cannot apply for the fund. And I was a little angry, so I emailed the CEO, Bill Anderson at the time, say, hey, we're all within the same organization. We have great idea, and you should support that. And you shouldn't limit the idea just in the research department. So a few minutes later, I got an email, not from Bill, but from, I think, his secretary. He says, we will consider revising the policy next year, meaning they're not going to take me into the proposal. So that's part of the reason that I decided maybe I should build my own thing. And if I can build my own thing, this technology can benefit a lot of companies trying to do, develop a protein more efficiently. So I think that's the story.
Okay. So let's go back to your professional. For Leon, you've been working on immuno-oncology. Can you explain a little bit about what's immuno-oncology and what's the major factor you consider it is a good therapy?
Yeah, I think there's a lot to answer for that question. I will try to brief and also try to explain at a high level to allow the audience to understand. So immuno-oncology actually is a recent breakthrough in oncology treatments. So the traditional oncology treatment is target cancer cells, bring the cytotoxic warhead, including chemo or other target therapy, including kinase inhibitor, to kill the tumor cells specifically and directly. Immunotherapy is a different concept. Immunotherapy doesn't target tumor cells directly, but instead it targets immune cells. It uses immune cells as a pre-drug. Activate immune cell, allow immune cell at a better capacity to control the tumors and achieve a durable response. So that's the basic concept. And the real revolution just happened 10 years ago, actually starting from Jim Allison's work, actually at Berkeley. At that time, he was at Berkeley, developed a CTLA-4 antibody. CTLA-4 is a break in T cells. So when T cell activated, there's a break to suppress activity, to prevent overactivation and autoimmune phenotype. And then Jim Allison identified that if you use an antibody to block the break, you can induce a much durable immune response, and T cell can be reinvigorated in the tumor environment and then cure tumors. And then with this effort, actually the first IO therapy got approved, which is anti-CTLA-4 antibody. And later on, there's another triple being identified, which is PD-1, and identified by Japanese professor Hongzhou. And then both Jim Allison and Hongzhou actually win the Nobel Prize I think due to their great contribution in identifying the checkpoint and develop IO therapies. And these are very exciting concept because we are not only tumors which there's a high heterogeneity in the tumor environment based on different indication, different individuals, based on different genetic backgrounds. So it's very complicated to treat, and also every patient has different response. But for immunotherapy, because you're not target tumor cells, you target immune cells. So what we found is that as long as you have sufficient neoantigen can be recognized by T cells in the tumor environments, there's a wide variety of tumor indication can be responded to immunotherapy. So the current PD-1 therapy has been approved in more than 10 solid tumor indications. Probably is the most indication approved for any cancer therapy in human history. And then CTLA-4 is the first one, but however, CTLA-4 has toxicity issue. Both CTLA-4 and PD-1 has toxicity issue, but CTLA-4 has more toxicity issue. So its application has been limited and has been replaced by anti-PD-1. So with those excitement now in industry, particularly in oncology discovery, actually a lot of focus has been on immuno-oncology and try to identify the next generation of immune checkpoint. Some targets similar like CTLA-4 PD-1. A lot of efforts still ongoing, but since after PD-1, it seems like there's lack of new identification of new checkpoint that can deliver such a promise as PD-1. And then now we rely on more comprehensive approach, including combinational strategy to enhance the immune response. But I will talk about the challenge later. But I would like to just highlight at a high level to summarize the current advance in concept of immunotherapy on my part.
So continue, I would like to know more about the challenge in IO field. What will you say? Like not every patient react the same, or there's something else?
Yeah, so the lesson we learned about the IO therapy, particularly for PD-1 or CTLA-4, is that it's a subset of patients. They have pre-existing CD8 T cells in the tumor environments, and those CD8 T cells already being activated to recognize certain immunogenic tumor antigen in the tumor environments. And the PD-1 antibody is particularly effective against those type of tumors. But however, those only account for a minor population of subset of patients in the clinic. For example, in lung cancer, only account for 20%. In other tumor types could be even lower. So the real challenge is for the other 80% of the tumor, why the immunotherapy doesn't work, why PD-1 doesn't work. And then the major hurdle we identify so far is because there's other tumor actually has much lower mutation burden. Because the more mutation you generate from the tumor, the higher chance your T cells able to differentiate the tumor from your healthy normal tissue, so therefore can generate a more specific immune response to control the tumors. But if there is low mutation burden, your T cell has the last chance to recognize the mutated tumor cells. So for those tumor cells that unfortunately has low mutation burden or less immunogenic, the focus has been how to induce a more immunogenic peptide from the tumor cells. So therefore can train and educate our immune system, including T cell, to recognize and control the tumors. And that has been a challenge so far. And there's a lot of efforts. So for example, there's some targets actually inside the tumor cells regulating the class 1 antigen presentation pathway. When inhibit, actually can allow a different diversity of peptide presented by the tumor cells, and therefore can be recognized by the T cells pool, and therefore initial immune response. But those are in the earliest discovery space. So hopefully there will be some advance and can further, and therefore allow a more durable immune response, cover more broader patients. And other challenge, I think Sony just touched base on the cell therapy. I think that's a very hot area in addition to the checkpoint blockade I just mentioned. Cell therapy actually provides a great efficacy and significant promise, particularly for the hematological tumors. And for CAR-T, for example, some tumor indication has been achieved almost more than 90% overall response rate, which is unheard of, unprecedented before. But however, people try to identify and then apply this amazing therapeutic platform into solid tumor, but so far it's not successful. And there are many reasons, because a lot of the tumor antigen we select also expressed in normal tissue, particularly for solid tumor. And because of a reason, the CAR-T applied for solid tumor, the real challenge is the toxicity. It's difficult to overcome. You will achieve toxicity that the CAR-T to eliminate or attack your normal tissue before you see the therapeutic efficacy to attack your tumor cells. And for the liquid tumor, this is achievable because your blood cells, including B cells or other myeloid cells, is dispensable. So even though you use those CAR-T to deplete your hematopoietic cells, the patient can still survive. But the patient cannot afford to survive if you attack normal tissue due to the overlapping of a TA expression between tumor and normal tissue. So I think that's the #1 challenge that need to be overcome before we can develop more effective therapeutics for CAR-T in solid tumors. I will stop here, and then there's a lot to say, but we can follow up.
Okay. And for I-Chueh, you mentioned about gene delivery. So can you give us a high-level introduction of what gene therapy is doing and what major focus are you working on?
Okay, so currently we usually use the viral vector, so adeno-associated virus, which usually don't cause disease. And the lentiviral vector is for CAR-T therapy, so it's another kind of gene delivery into the cell. So currently, most of the gene therapy companies trying to do the systemic gene delivery. So AAV is commonly used, and so AAV is a small particle, and you can deliver about 4,700 base pair length of gene. So there is still size limitation, and so if patient has some genetic mutation, especially autosomal recessive, you can do the augmentation therapy. You just deliver the wild type gene, you probably can correct their gene deficient condition, and but still limitation if it's autosomal dominant disorder, so it will be very difficult to treat. So of course, this is for rare disease. There are a couple different companies, usually large pharma. They're already trying to stretch out to see whether they can use the gene delivery as a way to deliver drug, especially antibody drug. So just like diabetes retinopathy, usually use the anti-EGF antibody. So, but you need to do the frequent injection. So gene therapy can be a solution. So you just do one-time injection, and the drug can constantly express in your cell. So this is a condition, and I think this kind of application will be applied to multiple diseases. And you don't need to go to the hospital so frequently. You just do one dose and potentially can last for your lifetime. So the thing I'm doing now is we're trying to develop different kind of platforms. So we modified AAV. So as we know, AAV don't have a good specificity. They just go to different kind of cell randomly. So usually clinically, you need to use very high titer to achieve your therapeutic goal. So my job is trying to modify these AAV capsids and combine with other approach to increase the cell specificity. So we wanted the gene delivered to the target cell, not the bystander cell. So we probably can decrease this kind of dosing issue because high titer dose also correlate to the adverse reaction. So this is one thing we are working on. And another thing I'm working on is for mitigate immune response. As I mentioned, we use virus as a vector. So virus can trigger immune response just like SARS-CoV-2, like COVID-19 can trigger immune reaction. AAV can also trigger immune reaction. So it becomes a problem because some patients don't respond well. So for example, the cell transplant, so the Novartis drug, they have 30% of the patients have poor responses. So you might want to consider the redosing. But because you already exposed to it, you already have the antibody. So the redosing efficacy will drop significantly. So that is the big issue in the gene therapy field. So a lot of companies trying to mitigate this kind of issue. So using this kind of approach, so such as immune suppressant, but the result doesn't seem promising. So all companies do have some in-house product. We are trying to see whether we can use in-house product to try to minimize this kind of condition.
So you already mentioned several challenges like dosage, efficacy, immune response. So how about, does it really go to the target site, those kinds of other challenges? Can you talk about that and how you improve that?
So as I mentioned, so most of the gene therapy are used to treat real disease. So for the company perspective, it doesn't bring too much money, and the serum is very expensive. So most of the gene therapy product you need to spend 1 to 2 million. So that will become a limitation. The patient population is too small. So that's why, just like our company, we're trying to try different way to just integrate like antibody therapy into our gene therapy delivery platform, and then we try to broaden the application in therapy. And another limitation, I think, is the gene size. So as I mentioned, for AAV, you can only do 4,700 base pair. So if your gene bigger, you cannot use AAV. You need to consider other approach. So there are a lot of different companies trying to use different things. Lipid nanoparticle is a pretty hard field now, but it's different. So it's not like Moderna or BNT vaccine. They deliver RNA. RNA don't trigger substantial immune reaction, especially innate immune. But for gene therapy, we want to deliver DNA because we want a long-term transgene expression. So this DNA material can trigger very strong innate immune reaction. And so there is still a predicament we need to overcome. And multi-gene disorder is another question. So just like diabetes, for example, if multiple gene is affected. So if you want to correct all these genes, later will be very difficult. You probably need a better vector to deliver multiple genes into the cell at once. So of course, a couple companies trying to use a double AAV transduction or a different approach, but I don't think they are promising. So you probably need to consider to use other viral vectors. So adenoviral vector or herpes virus vector can be considered. You have way better capacity. But each viral vector has its own issue. So it's not an easy way you can fix all these problems. So yeah, and another thing I want to mention is just like our company, we currently focus on the CNS and brain gene therapy and eye gene therapy. So delivery is also a big problem. So for this gene therapy, you need to do a very invasive procedure. Yeah, to open the brain or to just inoculate the vector into the eye. So the way you can overcome this issue, you probably need to use a next generation delivery system. So this vector or this method material can cross the blood-brain barrier or blood-retina barrier. So you probably can do the systemic injection, and you don't need to take the invasive procedure. So yeah.
Thank you. And for Andrew, my question for you is that AI is such a new field. So how do you seek for resources, guidance, your challenges, and how do you know your model is doing in the right direction?
For the last answer, I think it's easier for me. Like my client's happy, I know it's going to the right direction. But the challenge, before I answer the challenge, let me describe what kind of, what are we learning here? So like I mentioned, protein sequence is a string of characters. It's actually a language of nature. There are certain keywords. For example, we talk a lot about antibody. We all do the COVID test at home, right? The kit has a lot of antibody that can recognize the COVID virus. That antibody is a sequence, depending on how you define antibody. It's around maybe 120 to 200 amino acid sequence. There's a certain keywords in that sequence that can recognize the virus. If you mutate the keyword out, you swap it, it won't recognize the virus. It will become a nonsense sentence, or it can maybe recognize something else. So definitely there's a language there. How do we learn that? So think about human learning language. If now I wanted to learn Korean, I probably would just go to Korea, or I just keep speaking Korean and then gauge people's feedback and figure out, and my brain will learn what are the words I say may be right, and I'll try another one again. Same thing in learning the protein sequence is that we will try a bunch of protein sequences. The way we speak protein is that we generate a lot of protein sequences through a lot of DNA synthesis technology like Linya's company is doing. We put into the cell to produce a protein. That's how we speak. And then to gauge the feedback is to measure the functions. That's the response from some assays. And then we use NGS to collect the data, to quantify them, and then use the language model, that's the brain, to process that. So back to the human language, in order to like OpenAI train ChatGPT, it's relatively easy compared to in the protein space because there are so many human language data on the internet. And also you can hire a lot of people to label the data for you because human language is created by human. So you can hire people to tell you, hey, this data means something. But the problem for the protein space is we don't understand the protein language. It's created by nature. We don't know the rule. We cannot hire people to label the data for us. So that's the challenge. And the other challenge, there's no internet for all this protein functional data. There's a lot of protein structure data, but what's important is the functions. There's no such data available on internet that you can do. So you need to generate that yourself, and that's what we're doing. Now, speaking of generating data to learn, the challenge there is people say garbage in, garbage out for machine learning. That's maybe easy for, not in like language, human language space, because a garbage sentence, we know the language, so we know this is not a good sentence to put into the model. But for protein sequence, we don't know what that means. We don't know what's garbage. That's a problem. In order to identify garbage in the protein universe, you need to set up some kind of QC matrix. And then in order to know what QC matrix you need to set up is that you need to understand the experiment. Because generating those proteins require a lot of steps in the lab, and every process will introduce noise into the step. You really need to know how to do those experiments, what kind of noise can be introduced so that you can set up the QC matrix so that your training data will be high quality and your model will be robust. So those are the challenges and some kind of solution I'm suggesting.
Thank you. So that's the individual question, and I have a joint question for all of our speakers because our forum is focusing on AI. So the first question for Leon and I-Chueh is that have you been working internally or externally with AI or machine learning group? What do you expect that they can solve your current situation? And what's the gap between expectation and reality? Just like what Andrew said, the antibody after AI, it can have better binding, but not necessary function. So let's start from Leon.
Yeah, so I certainly can share AI perspective from big biopharma because, for example, Pfizer currently, we are very aggressively trying to adopt AI platform into our drug discovery and development pipeline. So currently, Pfizer even try to develop our own AI platform internally, which is different from GPT, similar, but however, we cannot use GPT due to confidentiality information. Right? Pfizer have a lot of proprietary information that we cannot release in the public. So therefore, we cannot use public AI system to train the machine learning and acquire the information we would like to advance our drug development project. So we need to have our own proprietary AI platform internally, and only Pfizer project or scientists can allow to use that system. And then we just recently built that system internally. And the ambition is that, Pfizer generates so much data from pre-development, start from early discovery, target identification, validation, screening, all the way to phase 1, 2, 3 trial. It's a humongous database that if you can use AI properly, AI can help you to identify a relevant drug target pathway that gives the highest possibility chance to be successful in the clinical development. Think about this, any single drug, it takes like at least 6 to 10 years to develop, to get FDA approval. And then company need to invest billions of dollars, right? That's a huge investment. If we can use AI to help us to better to predict what drug give us most likely successful chance in the clinical development, that can save tremendous resource and also the timing to develop a drug, therefore can benefit more cancer patients. So I think there's a great potential layer that we can leverage. But however, the flip side is that we need to be careful about the security. And then the data cannot be shared between companies because they are competing each other. So we cannot share those information. So that's one thing that we are trying to do right now. Another thing we try to leverage AI is to identify novel PD marker. PD marker means pharmacological dynamic marker, which is a marker to predict the responsiveness of a single drug treatment. And then oftentimes we have a lot of new targets, new treatments, and then we don't know what would be the best PD marker to predict response. So therefore, we evaluate all the possible markers from immune cell. For example, there's 300 markers at different time points. So therefore, there's a humongous database will be generated to identify a more sensitive, robust PD we can use in the clinical development. So we plan to also use AI system to tell us that which biomarker, based on AI training, can let us know we should follow up in the clinical development. So that's in progress right now. So hopefully AI can show more and more encouraging potential and help to shorten the time and the resource we need for our current drug development model.
Okay, so I can say 2 examples for gene therapy. So currently, one field is pretty hard is to do the capsid engineering. So there are a couple of different companies just do the capsid engineering for the adeno-associated virus. So they just initial stage they just randomize the different sequence and trying to do some modification of AAV capsid. The goal is trying to find the capsid which can deliver to the specific target cell more efficient or more specific. So this kind of randomization, they probably can create millions of the sequence and the millions of different AAV. And, they do the in vivo screening in animals, so multiple rounds of in vivo screening. And each time they got the candidate, they can refine their model to create a new set of library to do this kind of screening. And this is pretty much like common practice. So Spark did it a lot. It's another gene therapy company. Our company just trying to do it, just stop because our gene therapy team just have 2 years. We just started gene therapy 2 years ago. So this is one thing AI can help to shape what kind of capsid you try to use in the future. And I do think if we can combine with like structure-based design, might be even better. So a lot of like AI made the sequence, they just destroy the whole protein structure and the AAV becomes just useless. So if we can add another layer of consideration, which might just save a lot of time and efforts. Another thing I want to say is our J&J team, we do have an in silico team. They're trying to establish this immune modeling system. So they are currently focusing on the NHC class 2. So they want to predict certain immune epitope interacting with the T cell receptor. And so, of course, it's not only limited to gene therapy. They're also trying to do something about oncology. So our team, the idea is to, because the AAV, they do have specific immune epitope. So we're trying to do this kind of matching modeling system. So there will be specific HLA gene, just like specific, and then NHC class 1 or NHC class 2 gene, which might relate it to stronger immune reaction. So in the future, possible ways, when you have a patient group, you can screen their immune gene, HLA gene, and then you potentially already can predict what kind of immune reaction may be happening in the future when they receive the AAV gene therapy. I do think there is a potential, but still a long way to go because it's just pretty early stage. Yeah.
And for Andrew, when you work with your clients, what's the major issue you always face? Is there a translational gap, knowledge gap, and how you usually solve this problem?
Right. I think there are a few, but I think the biggest one, especially early on, when AI wasn't that popular in the biotech space, 2019. So people think about AI as a black box. They don't trust the prediction, so they tend to not work with anything AI predicted. And that's also the same issue for me. I was the user of my product. So I actually spent a lot of time trying to see why the model makes such predictions, so I make it more explainable. And in order to make that more explainable is you have to open up the model, look at all the weights, and use some statistical method to interrogate all the weights. And then so I spent a lot of time making sure I can explain the model, the prediction to the client. I think that ended up helping they trust the model. And when they see a few prediction and the reason I explain to them, and if it's reasonable, they can go back and check the literature. Does my explanation consistent with the literature, then they start trusting the system. So I think that's, the biggest issue early on.
Okay, thank you. We have 5 minutes left, so I have one last question. This is called Taiwan Tech Summit. So I wanted to link with Taiwan. So from your experience working in your field, do you have any pros and cons or experience to share when you collaborate with Taiwan or Asia? So we can start from I-Chueh. You're not the first one every time.
Not so much working with Taiwanese company. So I think it's difficult because the gene therapy currently still focused on rare disease. And the market consideration and probably is the main reason prohibit a lot of people to invest in Taiwan for gene therapy. But I do think there should still be some opportunity. For example, if we can just use gene therapy to treat common disease, that can be a consideration. And just like I mentioned, you can do the antibody delivery, and then potentially can be a good start. And you don't need to worry too much about the patient population. And you can also make your system work well. And ultimately, probably can try to explore to treat a certain specific rare disease or multi-gene disorder. So that's my opinion.
Or Andrew?
I actually thought about these questions and went to Taiwan the past 2 years and trying to talk to people, see if they're interested in applying AI in making protein products. But in terms of like applying AI in protein product, those are too new to them. And I think the reason is there's not enough application, and the reason there's not enough application is there's not enough data for people to try AI in the protein space other than the protein structure. So I think that's the challenge, but the solution I think is, if you don't know, Taiwan actually manufactures a lot of protein that go into clinical trial. So like people here, we develop protein candidate, outsource to Taiwan to manufacture that and then ship those to the hospital to do the trial. So that means they have the facility to culture cell to produce a lot of protein. That's a lot of data, but those data that they're currently generating are limited. Those are only for specific work that they're making, so it's not useful for machine learning. For machine learning, you need a diverse data sets. So if we can teach them how to turn those engines to generate diverse protein, and then use next-gen sequencing. I think NGS is still not very popular in the protein space. It's very popular in other space, but not in the protein space. So if we can combine like how to generate diverse data, combine NGS, and then Taiwan has a lot of AI talent, we generate data set for them to make model, then we can leverage Taiwan's resources to become a data generation powerhouse and then build products. So, yeah.
Leon?
Yeah, so from Big Pharma's perspective, I do see now is a really good timing for Taiwan to develop biotech and pharma industry. I think one major reason is because Big Pharma nowadays, they invest much less than in their discovery because they realize, they spend too much money and it's just not worth it. I just using the Pfizer as an example. So their business model now will be that rely on external research discovery effort engine, and then they will invest and license those products and then move to Pfizer for phase 1 to 3 clinical development and become the products. And due to this reason, I do see a good opportunity for Taiwan because Taiwan wants to invest in drug industry, but however, Taiwan doesn't have the infrastructure, for example. It takes time to build infrastructure. And also it takes a lot of resource and money to build a big pharmaceutical company, which will take longer time. Pfizer exists for almost 200 years. If Taiwan want to do something, I don't think Taiwan has 200 years time to do that. So because of the discovery now, is less a focus in big pharma now. I think Taiwan is opportunity to change in that process and to become an engine for novel discovery science and target identification, and then provide information that target validation for big pharma. So therefore, pharma can continue the pipeline to develop a drug. So it's like a whole process. We work together at the early upstream, and then big pharma work at the later downstream. I want to give an example. People like, especially people from Taiwan, like TSMC as an example, right? TSMC produce chip, but they don't produce iPhone. They don't produce Mac. But however, chip is so important that every single Mac and iPhone need in their chip. So in Taiwan, it's the same. You could be the engine to identify novel targets. That's so important that all the big pharma want the targets, want to collaborate with you, want to know how you do that, how to identify that, and build that relationship. So, I think everyone here will agree with me that Taiwanese people are smart. I think no one will have any rejection here. So, we should focus and prioritize our resource into those novel target identification, which provide opportunity for sustainable long-term biotech or pharma discovery or development industry in Taiwan. I see that's opportunity right now.
Thank you for all the answers, and we finished this session. At 4:30, we have a networking time. If you have questions to ask the speakers, welcome to join us. And especially I-Chueh, he's from J&J. You can know what's up with the vaccine at that session. Thank you.
Thank you to our speakers for a fantastic biotech forum. I have a quick favor now for everyone in the audience. If you could just stand up and move towards the front and to the middle, that would be really, really great. You can take this opportunity to stretch your legs and get ready for a couple other really amazing speaking events. So please stand up and move towards the front and move towards the middle. Thank you so much.
All right. Okay. Do we have more folks here today? How's everybody? Good? Okay. Hold on. Let me switch my. All right. So thank you, the Bay Area Taiwanese Biotech Association, again, for bringing all these great speakers and the moderators and enriching us with all this remarkable biotech advancements. So before we move on to the next keynote, allow me to introduce myself. My name is Wally Wen. I'm currently work at Intel as the event marketing and the product demo lead, serving the global client computing business. Prior to joining Intel, I was an event operations strategist at ASUS North America for more than 6 years. Today, it's my pleasure here to be the moderator for the final keynote. AI is certainly the buzzword nowadays, and then especially when it comes to the technological transformations. And the PC and the computer hardware has always been on the forefront driving these transformations. AI has completely changed the way we think, we work, and we communicate. It has immensely increased our work output while at the same time reduce our working hours. So how AI can be more accessible and affordable to all PC users and the industries is going to be a hot topic in the next 5 or 10 years. And then it's my pleasure today to have Vivian Lien join us here. So she's currently the Vice President of Client Computing Group and the General Manager of Client Graphics at Intel. She was also my former manager at ASUS for nearly 5 years. And I'm thrilled to be able to work with Vivian again at Intel. So in the next 30 minutes, Vivian is going to share how Intel's view, what's Intel's view on AI, and how Intel approaches AI from ecosystem perspective. Intel has an extensive product roadmap of CPU and GPU and robust marketing and positioning strategies. And we believe all this will help accelerate the adoption of AI in any consumer or industry markets. Without further ado, so please join me in a warm round of applause and welcome Vivian to the stage.
Thank you, Scully. Really good to see you again, and thank you all for coming here on a beautiful Saturday afternoon to learn, to connect, and more importantly, to talk about what the future will bring to us. So, as Scully mentioned, my name is Vivian. I'm responsible for product management at Intel, specifically focused on graphics. Now, today, I want to talk about a very important transformation that's happening in the PC ecosystem. AI is expected to usher in waves of changes that will shift the way we work and play. We've been hard at work to create a family of products that will power the acceleration that is already happening today. Now, we're on a mission to democratize AI, to put that capability to the hands of consumers, to the businesses and the partners that we work with. So let's dig into how we're going to make it happen. Did it fix the receiver here? A minute. Okay. All right. So since we're in the Silicon Valley, I'm sure a lot of you know some of Intel's history in the world of computing and the many innovations as well as the technologies that we have either led the creation of or driven to market at a massive scale that's required for adoption. This timeline behind me shows some of the highlights since the early 90s, including the very beginning of our history, making silicon products like a CPU a very relevant part of a PC buying decision. So, does anybody remember Intel Inside, the very famous marketing campaign with the bunny suits? This was a marquee campaign that put the CPU that you picked in the inside a PC, a very important consideration. Now, there are many other critical technology highlights too, such as the introduction of MMX instructions, which allows for more multimedia processing available on a PC, as well as the built-in Wi-Fi with the introduction of Intel Centrino. Can you imagine today buying a PC without a built-in Wi-Fi and what that experience may be like? But thankfully, we had the ability to work with the industry to put those capabilities into the silicon. And in 2011, we introduced Quick Sync Video and also the first ever built-in graphics inside a CPU. Now, as we fast forward to this year and next year, we're on the dawn of a new era of AI computing. Now, Intel has been on the forefront of almost every PC transition for the last 50 years. Innovation is such an important part of our DNA, and so as we look ahead, AI really is no different. The future of computing is going to be built around AI processing. For Intel, this applies to all segments of the market, from cloud to the data center, to edge computing, and of course, to PCs. Bringing AI everywhere requires a diverse portfolio of hardware and software, and we're well positioned with technologies that spans this spectrum with an open approach. Our approach and commitment are to infuse AI capabilities for all of our technologies. Our heterogeneous architectures consist of CPUs, GPUs, NPUs, and accelerators delivering competitive performance and open standard solutions that our customers require in order to deploy AI at scale. Now, this is also important to allow for this full spectrum of workloads and usage models that we envision to democratize AI. In addition to building hardware capabilities, we think deeply about enabling the right models for the right workloads. and working across the entire ecosystem to provide training, tuning, and deployment needs to accelerate AI at scale. Now, while Intel's AI strategy stretches from cloud to the data center and client as well as the edge, there are reasons why AI on the client is important. First, enabling AI capabilities on each client device will allow the overall scale of AI to increase tremendously, providing more compute power to consumers and developers. Where latency is important to a user experience, the client device is the best place to put that AI. And if you're disconnected from the cloud, you have the ability to do local inferencing, which is important. Privacy on the local device is also important and has its advantages. Keeping sensitive data processing at the local level can offer peace of mind to users. And to ISVs and developers, running AI on the client has a cost advantage, which can help accelerate AI and the adoption of it. Now, adding AI accelerated compute to PC enables better, faster, and newer experiences. And some of this is already happening today. Most of us are familiar with video conferencing and streaming applications. So features such as background noise reduction, background removal, or avatar effects are enhancements thanks to AI. Going forward, the adoption of AI applications is going to fast approach with tasks and capabilities available, and that will continue to evolve greatly. Productivity tasks will speed up when AI can help you create PowerPoint presentations and build summaries of a paper that you just wrote. Creativity applications will leverage generative AI to help you create variants of your work to refine and to perfect. And with the added benefit of privacy of local AI compute, AI assistance will be more personal than ever. The future of AI computing is going to be very exciting and will fundamentally change how we utilize our PCs, how we game, and how we create. To lead this transformation, we need scalable platforms built for AI. And we need to lean into the scale that Intel offers, work with our ecosystem partners to enable more workloads, and to accelerate user adoption by offering new AI experiences. And the result of this tidal wave of transformation in the PC ecosystem is going to come here sooner than you might think. Now, the good news is that for consumers and software developers, Intel is not starting from zero on AI for clients. In fact, we've been planning for this shift for years, and the head start is helping to prepare the market. In 2019, when we launched the 10th generation mobile platform, we added in support for Vivian instructions in order to help accelerate the first instance of AI inference on the PC. The following year, when we introduced the 11th generation platforms, we brought the very first version of Xe graphics to mobile CPUs, and with it, another AI acceleration instruction called DP4A. When you take the combination of both acceleration methods, we saw performance enhancements for the very first client AI applications. And those include image upscaling, video enhancements from Topaz Labs, as well as image classification in Windows photo applications. We work with these ISVs to ensure that users of the platforms can see the benefit of hardware-accelerated AI capabilities. And we have OpenVINO. It represents another critical part of our Intel strategy and how we can enable AI at scale. OpenVINO is a free and a cross-platform tool that allows developers to write it once and apply across the spectrum of any applications that leverages deep learning. Now, as we release these future applications and generations of products with more AI acceleration, the software frameworks will be more important as the level of acceleration and the number of IPs that need to work together will continue to increase. A big part of the AI acceleration story has been and will continue to be built around GPUs. We know that GPUs are key to the AI ecosystem, and this is one of the reasons why Intel has been developing and investing in graphics in order to build a leading portfolio. We're committed to winning in the space, and it requires executions in multiple areas. First, we're leading in integrated graphics. And these are the GPUs that are built into the CPU, allowing our partners to have different design possibilities and dream up new devices that consumers love. Since the release of our 10th generation CPU family, we have strived to double the performance generation over generation. As we look ahead to later this year in preparation for the next generation launch, we're on track to deliver another generational leap in terms of integrated graphics performance. Additionally, we're building strong presence in the discrete graphics market. These are high-performing gaming. This is where high-performance gaming happens. And this is also where the gaming ISVs release their next-generation, highly immersive, exciting game titles. We launched the Intel Arc graphics in 2022 and have been seeing consistently improving perception around the way that we introduce the discrete graphics. And both of these lines of graphics, whether it's integrated or discrete, requires innovative IP. And the XE architecture is the underlying technology that we use to power the throughput when we need it or the efficiency when we want to build into a CPU. It also offers features to accelerate ray tracing, AI compute, and offers support for AV1 codecs, just to name a few. Now, building a new brand such as Intel Arc really requires a thoughtful approach. As I mentioned, we launched Intel Arc in 2022, and we have decided in order to break out of a very noisy market where players are very dominant, we took a different approach. Our go-to-market approach is really built around transparency and deep engagement with the community. We put faces out there in the world rather than just logos or brands to represent what we stand for and talk about product truth. We build the community through multiple channels, such as Discord. We put products in front of consumers, not in the usual place like a store, but rather we put it where gamers like to game. And we also have a way to show the product information to the community as well as to the press in a very authentic way. And besides building our brand through the methods that I just mentioned, we also work very closely with gaming ISVs. These gaming developers and publishers really help our product become better and in turn offer a much more optimized experience to our common customers. Now, easily the most popular use of AI for gaming is to super sample images in real time to improve the performance for PC gamers. The way it works is a lower resolution image is rendered by the game itself. We use our AI computational model, which is trained on billions of data points, to generate a higher resolution version of the image and show it to the user. Intel's version of this technology is called XeSS, or XE super sampling. And it has been implemented in over 75 game titles since we launched, and more are being added every month. So to show you how XeSS works, let me show you a game demo. This is a new game recently released called Synced. We're running this on an Intel Arc A770 16GB graphics card and a Core i9 processor. On the left, you have a game running in native 1080p resolution. On the right, we have XeSS enabled that renders at a lower resolution but uses AI to upscale the image. This improves the performance by 40% to 60% depending on the scene. And you can see the frame rates as we play the game, it going from the 70 to 80 frames per second, going all the way up to 120 or 140 frames per second. And this is a great use of AI that's improving gaming experiences today. Generative AI has gained tremendous popularity. The next demo I'm going to show you focuses on AI and stable diffusion, which is primarily the process of generating new images from text prompts or inputs. Here you will see a platform powered by an Intel A770 16GB graphics card and one of the most powerful and most popular local stable diffusion interfaces, Automatic 1111. So when I show you the demo, you will see somewhat complex but powerful interface and two different simple text inputs. First one is Taipei 101 Tower with blue and purple illumination. And the second is Taiwanese street food, just because who doesn't want to see a good food picture? So here. So here we go. It may be a little bit difficult to see on the top left corner. We put in the text prompt and hit generate button. You'll see in 2 to 3 seconds a fully AI generated image of Taipei 101. And here we show you the second using a similar methodology where we put in the text prompt Taiwanese street food. And in 2 to 3 seconds, you hit generate, an image appears. You can do this again and again until you get an image of your satisfaction. And you can see how easily this will be a revolution for content creators, introducing audiences to new art capabilities. Now, our graphics and AI strategy is going to take another major leap forward later this year when we launch our next generation product codenamed Meteor Lake. This is a new platform that combines innovation and power efficiency to kickstart the new AI PC era. Meteor Lake will be the first Intel processor, integrates Intel Arc graphics directly on package, offering amazing gaming experience, but also massive throughput for AI applications. It will also offer integrated NPU, or neural processing unit, for dedicated AI application, allowing users to utilize AI while on the go. And our CPU cores will continue to excel at lighter weight and low latency inferences. So Meteor Lake is a very exciting product, and we're looking forward to sharing more with you in the industry. But speaking of sharing more with you, here, let me give you a little teaser. In just a few days, Intel will host its annual Intel Innovation Conference here in San Jose. So hopefully you will all be attending either in person or via a webcast. This is a premier event for application and hardware developers to learn more about the future of Intel products and services. It's also a great way to build network and connections with those in the industry. And of course, if you're going to be watching the keynote from our CEO, Pat Gelsinger, on the 19th, you'll see a lot more about Meteor Lake and our AI strategy. So with that, thank you very much for attending this session. I hope you found the information useful. Thank you.
Thank you so much to Vivian for a wonderful keynote message. Our next event is happening soon, and I just want to encourage everyone outside and everyone inside to encourage your friends to come inside. They do not want to miss this. We next have our cybersecurity forum, and yeah, so please come inside. We will start shortly. And I hope everyone has been having a great day so far. It's been a day packed full of events. Everyone has been so talented. It's been such a great event. I've learned so much about so much stuff today. So yeah, so we're gonna give this a little, another minute or so, and then we will begin. And thank you so much to our hardworking volunteers. Great, so we will now begin. I want to invite our speakers for the Cybersecurity Forum on stage, Jeffrey Hung, Kyle Lai, Susan Chung, and Betty Cao.
Thank you. Test. Okay. Hello, everyone. Welcome to the Cybersecurity/AI panel discussion. I'm your moderator today. I'm Jeffrey Hung. And today we are very honored to have three very professional and very experienced guest panel speaker here. On the left-hand side, we have Betty. Betty is a senior director at Microsoft. Her professional exposure across highly regulated industry, globally distributed and diverse product and service portfolios, and different facets of the domains create and offers a unique perspective as we collective pivot into creating an AI blueprint for the future. And in the middle, we have Kyle Lai. Kyle Lai is the founder of KLC Consulting. Kyle has more than 2 decades of experience in cybersecurity leadership and has provided strategic guidance to many famous companies, including like ExxonMobil, Zoom, Microsoft, etc. And his current focus revolves around enhancing the security of defense industrial-based supply chain for US defense contractor. And right next to me, we have Susan. Susan Zhang is the deputy CISO at Cloudflare. She oversees engineering operations and technical program management functions across the security organizations. She started her career in management consulting at Deloitte. After a stint in go-to-market strategy at Salesforce, she found her calling in security as part of the security leadership team at Uber. So before we started, we need to make a disclaimer here so that everyone here can talk freely. So what we talk during this panel discussion does not represent the company we work for or any company we used to work at. It's just our personal experience and opinion. So with that said, let's dive into the topics. So in current cybersecurity world, we are dealing with a lot of different threats already, from smaller stuff like phishing, malware, to bigger stuff like APT or national threat actors. And all these stuff have been keeping us very busy every day. But with the emerging tools like AI, ChatGPT, it becomes very easy for attackers to use these tools as well. So I want to kick up the conversation for Betty. Like, how are the new AI-related tool will impact our current cybersecurity threats out there?
Well, thank you, Jeffrey. And I want to first and foremost thank the foundation for organizing this panel and for the opportunity to speak here and share our experiences. Before we jump right into how AI can be used in cybersecurity attacks, as a cybersecurity professional, I just want to first express the excitement I personally feel with respect to AI. When I think back to earlier in my career, in the security operations centers, while working as security researchers, hunting threats across enterprises and customer operations. And we always dreamed about, and we never stopped attempting at intelligent automation to help us really navigate through the overwhelming signals and alerts and breadcrumbs. And lo and behold, in the past 2 decades or so, progressively that dream has become a reality. Where today I can use AI to basically analyze, ask AI, say, hey, does this file has a signature similar to or belong to a malware or a specific malware family? I can also use AI to, for example, analyze some malicious code segment that is difficult to understand, or simplify codes that are obfuscated, evade detection. And I can also, well, recently, we can also use AI to extract entities from malware codes, as well as their behavior signatures when they are detonated. And of course, AI models can be chained together to really achieve very complicated goals and tasks. During our day-to-day investigations for threat events and threat intelligence, we can also use prompt engineering and package up our prompts into playbooks for later use or to share with others. Right? So as a security professional, we are definitely at a, how do I say, game-changing moment here, where what used to take a day or two or several days to accomplish in the security intelligence world now probably takes a minute or two. And this is really important because we have limited cybersecurity workforce that's faced with increasing automation in cyber attacks. So this AI technology does allow us to regain some of our advantage. But of course, while AI is helping us to improve our ability to defend and respond to cyber threats, we have to acknowledge and be cognizant about the new challenges that is coming up, because cyber attacks, after all, is just gaining in its sophistication, right? And research in multiple communities in cybersecurity, or basically scientific communities, have shown that offensive AI, or the use of AI to power attacks against computing systems, can become the tool of trade to scale up the cyber attacks. Like basically beyond basic automation, AI can learn from publicly available information like online user profile and craft highly targeted and effective social engineering attack. And there has been research paper and demonstration showing that the generative AI can be used to create network traffic that serves as decoy and camouflage for actual attack that is going on. And of course, and last but not least, just make sure I don't miss my stuff here. We also have seen in security conferences several years ago, I believe, where already synthetic voice prints can be generated to gain access via the authentication system. So while the AI use in cybersecurity attack is likely going to start with very sophisticated actor, but as security professional, we have already seen other attack vectors gaining popularity and traction via the increasing level of cooperation and commercialization in the criminal markets, cyber criminal markets. So that's, I think, how we can see this trend going.
Gotcha, I see. So on the same topic, Susan, from your perspective, are you seeing any major difference from a AI-powered threat compared to the maybe old existing threat we have here?
So I think what you said starting off is still very true, right? 75% of incidents are still from what we all have been battling for years, which is phishing and vulnerabilities. That's about 75% of them. I think what AI does is security is just really about how do you increase the cost for the attacker and lower the cost for the defenders. And what's happening is, kind of as Betty alluded to, it's lowering that barrier for entry for someone to be effective and also helping them to be much more targeted, because they are able to use all that information, just like intelligent automation, I love that saying, is helping companies understand what's relevant to corporations or governments. Attackers are using that as well. I think one of the big ones is crypto. They're aggregating data sets from different data breaches like, T-Mobile, probably shouldn't name a company, telecom and different sectors. They're using it to aggregate it and create much more targeted, high attack surface areas to go after. So I think that churn rate is higher, and therefore it's really difficult to combat against it as an entity that where we're increasingly pieces of the larger ecosystem. Is probably much better to use AI to lower the cost for us as defenders, right? I think the reason this has really hit the rapid adoption phase is because it's just so much easier to use. Like, you don't need to know how to code. You just need to know how to form not even full English sentences, just words, right? And you can be effective. And so I think we need to think about how then we can get the rest of the company, rest of the society also engaged in using that to help themselves be more secure instead of seeing that as a threat.
I see. And since we are here at the Taiwan Tech Summit, I want to focus on Taiwan a little bit more. So for the audience who doesn't know, Taiwan is one of the high target for cybercriminals. We are receiving hundreds of thousands to millions of attacks every month. And for situation that Taiwan is in, it's not just a personal threat or corporate threat. It's national security level of threat. So I'm gonna throw the ball back to Betty. So for national security wise, do you think the AI will create any different attack toward our critical infrastructures, or different from the normal security attacks?
The way I look at national security threat is, after all, it's cybersecurity threat with different scale and of impact, right? And potentially the actors involved in national security threats are potentially more skilled and better funded, or more committed because they believe in a specific mission with a statement. And I think specifically with generative AI, one of the bigger conversations is, can AI be used to fuel influence operations? And I think if we just think about the capabilities of generative AI logically, I think its application in generating, fabricating content that can be used in different information, operation, and campaign is pretty apparent, right? And the use of AI, just talking about the technology itself, to additionally tweak those content to target specific individuals and audience group is also not impossible.
I see. And usually in the cybersecurity space, US is usually ahead of policy-wise, framework-wise, compared to other countries. So I have a question for you, Kyle. You work with a lot of DoD contractor or US government-related companies. So are you seeing the US government making any difference or doing any action to defend against AI-driven threat? And is there anything that Taiwan can learn from it?
Yeah, thank you for the question. And really glad to be here. So when we were working with DoD and also the defense contractors in the US, this is actually one of the concern. One of the concern from the DoD is that in order for them to attack DoD, they are not going to attack DoD directly. They are going to attack the weakest link in the supply chain first. right? So they can actually successfully attack maybe one of the subcontractors, get into the prime contractor, then get into DoD. So there is a lot of concern in the DoD space, we call defense industrial base, right? So there are about 300,000 companies, or sometimes they say 350,000 companies that are in this defense industrial base, defense supply chain. So DoD, yes, they are very concerned about this. So what the government is doing, what the DoD is doing is they are starting to enforcing, is going to be coming next year, is going to start enforcing the independent third-party assessment on the defense contractors, holding something sensitive information, sensitive unclassified information. I mean, we are talking about the unclassified information here. So DoD, they want to do an independent third-party assessment. Once you have the certification, then DoD can trust that you have an environment that is capable of holding this sensitive unclassified information, right? So DoD is definitely, paying attention and they're doing something about it. Today, DoD defense contractors, they only have to do the self-assessment, but these are changing. Based on my understanding that Taiwan is also kind of copying what the DoD is doing, and they're going to implement something in Taiwan. So the defense contractor, because Taiwan and US, they work very closely. And for Taiwanese, there are some defense contractors in Taiwan also support the DoD in the US, right? Defense contractors, prime contractors in the US. So yeah, they're going to be doing something in Taiwan, similar protection in Taiwan.
Gotcha. So talking about defense, so my follow-up question, and I believe many audience may have the same question, is how can we protect ourselves? And when I say ourselves, it includes like individual and company and maybe government when we are facing like AI-driven threat that we are seeing right now. And I'm gonna give the ball to Susan.
So I'll start with a downer, then we'll go up. So a lot of times we talk about the concept of PII, which is essentially private sensitive information that can be used for attack purposes. To be frank, that concept is increasingly irrelevant because there's just so much PII out there. It's been compromised over and over in various formats. It's not hard to get a lot of data about each of you. I've actually had friends in the security industry be like, "Oh, you like that team, huh? I know because I see your password from 8 years ago. You like this specific football team." And so I think I say that because a lot of times people hold on to that as a form of security, and it isn't. And it's more about how do we start to realize that it is a when, not if, and therefore the one thing we all should do is just to be more vigilant about checking if we are compromised, checking your credit scores, making sure that for those of you that are still reusing any password, just start using a different password each time. One of the best advices I got was use song titles or use, I don't know, the combination of your favorite this and that, right? Or use a password manager. In fact, if you can, use a security key. That is by far the best. I think just securing your access is probably the first thing, because then also secondly, be more conscious about the information you're putting online. Because so much of all these data models, especially public, right? We all went through the phase where there's explosion of blogs, journals, social media, tweets, right? These are all information that's all being fed now to inform something. So it's a choice on your end, is how much do you want to continue to put out there? Is the return to yourself putting it out there worth that long-term data aggregation about you specifically?
And on the same topic, Betty, can you share some information on like maybe corporate level or to like national level?
Yeah, since I am last person to talk about this topic, let me supplement what Kyle and Susan just talked about. So maybe let's start at the government or partnership level. Is that there is in the United States a coalition for content provenance and authenticity. I think the acronym is C2PA. This is a coalition where the coalition addresses the prevalence of misleading information and seeks to develop technical standards to certify the source as well as the history or provenance of media content. And in parallel to that, at the government level, United States government has made several steps toward securing its ecosystem. I think coming out of the 2020 Cyberspace Solarian Commission legislative proposal, we now have the Cybersecurity Incident Reporting and Notification Acts for federal agencies as well as critical infrastructure. And to supplement Kyle's point, the Executive Order 14028, I believe, improving the nation's cybersecurity, definitely directed agencies to raise their bar in cybersecurity when it comes to supply chain security, as well as the adaptation of the zero trust model. And then moving further back in time, I believe National Academies of Science, 2 years ago, I believe there are newer activities as well, but they held workshops and published paper around how AI can be used across the cyber kill chain, from social engineering to basically how methods can be used to target vulnerabilities in autonomous system and to malware adaptation, right? But on the law side, there's definitely also Presidential Policy Directive 41, PPD 41, that sets up the architecture for US government coordinated response in the face of significant cybersecurity incident or event. And definitely going back all the way to 2015, the Cybersecurity Act authorizes the monitoring and the use of defensive measures and also information sharing with government and private entities and provide limitation to liability. So I think the 3 key takeaways at the government level, how we can protect ourselves, is really first and foremost, continue to invest in research and development to explore the intersection of artificial intelligence and cybersecurity. And then we have to take actions based on the results of the research and then raise awareness and training around the possible attacks and defenses. And the public-private partnership, lastly, is really important, as well as a cross-sector and overall information sharing partnership. So that's at the government level. So briefly, at the corporate level, again, this is a disclaimer. This is my personal opinion, is that as we are using AI to scale up workflows, that is the most sensitive in the sense in enterprises to protect our crown jewels, protect our trade secrets, protect our customer data, customer operations, and customer intellectual property. We have to put cybersecurity front and center and equally important as we think about how can we additionally use AI to create new values for customer. But fortunately for cybersecurity professionals, there are many existing frameworks that for secure by design and product and services lifecycle security that we can readily leverage and update and expand to address cybersecurity for AI.
Yeah, I think just to add on to that a little bit, I love that you said secure by design, because right now the currency for AI is speed. And every company out there has fundamentally changed their risk tolerance for around security, privacy, etc., because there's, for lack of a better word, a lot of FOMO in the Gen AI space. Companies that have built a lot of rigor are looking to bypass it, right? All the startups are not evaluating the potential impact of what they're releasing before releasing it. So we're kind of going back to a lot we'll learn as we do, and a lot of times after the pain has occurred. And so in that construct, it means that, more policy or process or any of those things that rely on traditional steps are going to be increasingly bypassed, and therefore things that help you start from a level that's more secure, and the Goldilocks is offering something that to developers, to those that are innovating, something that is more secure by default and actually helps them do their job a little faster, because that's what's drawing them to AI. Again, the currency is speed. So if you get in the way of speed, it may be more secure, but that company may feel like they're not going to be competitive in the AI space, and therefore, what's the point of securing something that may not exist in a couple of years, right? That is the business discussion that's occurring in all of these companies when we talk about regulatory policy and security. Is that's honestly going to come alongside it or later.
I see. And as Susan, you mentioned, like many companies are like integrating AI with their product already. So what do you think will be like ways we can utilize AI for defending ourselves?
Oh gosh, I think Betty hit upon some really good ones. I will say that overall, the discussion about AI for security falls into two buckets. One of them, the first bucket, is maybe the more traditional mindset, which is how do we restrict the use of it so that we are mitigating the risks that we see from it, which are A, seemingly infinite, and two, there's so much unknowns for everybody. The other side is seeing the mistakes of having done that before for other technological evolutions and seeing how that has put security on the back end in terms of being viewed as a partner, being viewed as a blocker, being viewed as XYZ, right? And saying, okay, how do we take advantage of this and instead position AI as an enabler, right? AI to reduce, for example, false positives, to reduce the amount of resources required to achieve something, to actually shorten the number of steps to release something because you're using it to do a lot of times you don't even need to look for the OAuths yourself. Like there's so many tools that can help you do that. But I think at the end of the day, if I look ahead decades, some say 5 years, but I think it's more closer to a decade or more, and this is very relevant to the group, is a lot of entry-level jobs in security will start to decrease or cease to exist. So a lot of like traditional operations center jobs, et cetera, a lot of where we cut our teeth in security and learn from the ground up may not be as available at companies because frankly, that can be done with AI, right? It can be done without learning a lot of the basics. Someone that has a lot less knowledge can use Gen AI to say, hey, what are all the assets that are exploitable with this latest vulnerability? What are all these things? So I think that's a part of how do we, going back to societal level, how do we up-level the training in cybersecurity so that people can use AI, and know how to essentially understand the accuracy and reliability of its outputs and then interact with it to aid it to operate at a higher level. So how do we get people that are entering the industry to operate at that higher level first and without having that entry-level job? I think that's the part that I just don't know the answer to, but it's a little bit of what's ahead of us, especially in cybersecurity.
I'm just going to add, I concur with what Susan was saying. Yeah, there's a lot of unknown today. Yeah, when you talk about AI, it's so new, right? How are companies going to embrace AI? What are they going to do in the next 5 years? There is actually a lot of unknown. But what we know is that there is a lot of risk, safety, quality, or there's from the risk point of view, is that, just learning from what we actually come through, in the internet era, right? There's a lot of vulnerabilities, and you probably will see there, every other day you will see some major vulnerabilities found in some of the software. We are going through that same era right now in the era of AI because it's so new. And just talking about generative AI, right? You can actually ask if one plus one, what is a 1 plus 1? The generative AI is going to say it's 2. But there is a way for you to actually trick generative AI, say, I think is 1 + 1 = 3. And from now on, 1 + 1 = 3. There is a way to trick that generative AI, some transformers to be able to actually adopt that as a truth, right? If that is the truth, then there's going to be a lot of problems. There's going to be a lot of attacks on these generative AI. And you will hear a lot, some of the new products that's coming out. There will be something that's new. It's a large language model firewall, right? LLM firewall is something new that's actually identify if the input to the AI is this something that's malicious, then they will try to block it. This is something new that's coming, right? And so just to say that, yeah, there's going to be a lot that we're going to learn from how the companies are implementing AI. Because, and what I heard is that software without generative AI, they're going to be out of business tomorrow, right? So there's going to be a lot of, it's way to be seen if it's true or not. But yeah, there are a lot of companies that are adapting, putting generative AI into their software today. But security, yeah, what security? That's after we make money, we'll worry about security, and that is going to be the problem.
Got it. Betty, you have something to share?
Yeah. Okay. I have, as I mentioned, I started a long time ago as a threat hunter. We're working in Security Operations Center. And I thoroughly enjoy that job. And my personal expectation is that AI is not going to take the job away. What will happen is already happening today is that internally within companies, teams are using AI to onboard new team members. And I can share with you that the excitement and the level of just like quantum jump from completely green in the company, in the work field, to you just kind of absorb how your senior team members on the team is thinking about things, and you can leverage the experiences immediately, and you can immediately contribute to making that things better. That is why I think AI is going to give us that opportunity to regain advantage, is that we are overcoming the manual workflows, overcoming the onboarding challenges to do something a lot more. And to supplement what Kyle was talking about, the prompt injection attack, AI systems can be tricked, right? Like humans, they can be tricked into clicking bad links or to execute actions at the directions of malicious actors. So that I think companies within corporate companies, especially those producing AI features, we do need to have our security teams getting accustomed to asking different questions when they are performing risk assessment to mitigate risks and performing red team exercises to test their AI features before rollout or release, is that the people should be asking themselves, if someone poisoned or tampered with my training data, how would I know? What telemetry do I have to detect any deviation or degradation of the quality of the training data I'm using? Am I training my model using user-supplied inputs? And if so, what kind of validation or sanitation steps am I taking on that content? And if I'm training my model on an online data store, how do I ensure that there's a secure transmission and communication between the data and the model itself? And how do I make sure the model weights and parameters are encrypted and protected? And last but not least, right, am I having a verifying agent on my results? And am I exercising due diligence in my test cases and test data in my machine learning operations or ML ops practices? I think those are elements that need to be considered as well.
Okay, so going back a little bit to the part when we said security team can use AI to, in other words, set the bar higher for entry-level security engineer, let's say. Kyle, I know your son is just about to dive into the cybersecurity field. what are some suggestions or recommendation you will give to people like your son on this part? Like, how can they get themselves more prepared in an environment like this?
Yeah. So kind of like what Betty and Susan have mentioned already. Yeah. In the future, in the near future, I think within the next few years, we will see a lot of the manual work, because you have to know when you are in the security operations center, in a large environment, large companies, you are getting 1 terabyte of data every 15 minutes, right? That's the last large company that I worked at, right? So it's not possible for a human to be able to correlate all these events, and that's why there is a lot of burnout in the entry-level security, because they just want the entry-level security people, right, to go and do the groundwork. But what's going to change is that AI, they're going to do the groundwork, right? And so for the entry-level jobs, I think we're going to just learn how to ask the right question, right? And also understanding, yep, I see this, I want to have the AI, be able to collect all this information and tell me where's the threat, if this is a threat, or if this is a threat, how do I actually correlate with the other systems? So these are going to be the change, in my opinion, these are going to be the change in terms of the how we monitor the security, how the entry level going to change. They have to learn how to ask the right questions, prompt engineering. That's pretty much asking the right questions so you can generate some relevant information so you will be able to respond to the security incidents. So that's kind of like my thinking.
Okay, so back to the risk of using AI. So Susan, are we seeing any, because we talk about a lot of like ways AI can be tricked or be utilized by like threat actors. Are we seeing any actual or example with like company misuse AI and then something bad happens?
Absolutely. And I would say it's AI is more the aspect that's exacerbating it, but the cause is with higher velocity of innovation, it usually means that there's more trade-offs to kind of going back to my point around speed versus security, right? It's something that I think a lot about as a company in my job, having worked at very fast-growing tech-native companies that have very different risk tolerances. One is more measured, one has infinite risk tolerance. And then how do you think about then, therefore, how does that extend to your trust in your third parties, right? And the challenge is when companies are innovating very fast, there's almost, that more of the resources and investment are going towards innovation and less so on the security of it. And therefore, you are also taking a risk with using them as a third party because there's just less, you have less third party objectives, you have less of everything to note that they put into it. And also, we're in a Gen AI bubble. With bubbles come with companies that are not going to be here in a year to 2 years. So if your infrastructure is relying on a company that's that's either acquired or folds, then you're going to have performance gaps. I've had all of that happen where a company goes, end of life with their product, or they got acquired by a larger company that's much more interested in market share than they are with keeping up with all the integrations. And also the latest OSs and compatibilities, et cetera. So I think there's just a lot of more volatility, and it almost makes companies that have a certain level of security standards and obligations to customers and regulatory to be actually a little hesitant about adopting the most innovative companies. I think every single, between Microsoft, OpenAI, they've all had security incidents. And actually, this was one of the most fun at DEF CON. They just had a whole hackathon of people just trying to trick AI. It wasn't, and I think that's a part of going back to what you were saying around the journey, right? It's like how to ask the right questions. I think Gen AI specialists, like the people that really know how to ask questions, is actually a job category that's being birthed and are growing. But I think that the dance is how do you, going back to like the trust of AI models, right? With the lack of transparency and what's going in, how is it coming out with where it's, with what it's suggesting? How does someone at entry level know when to trust what it's coming out and how to validate that? Because there's going to be a percentage of time where it's off. And that's the part where, how do we get that dance right of how do you have that context and understanding enough to question the model when you need to and rely on it when it's giving you fairly good results on speeding up your work. And I think that's the part where traditionally we've learned that by getting into it, right? Breaking it down, understanding down to the code level, every single bit. But that's not as possible anymore with AI. So how do we get our talent to be a level of awareness and trust that they know when to poke at it and when do they just take the information and run?
Okay. Kyle, so do you have any suggestion for like company that want to utilize AI but also are afraid of the risk of AI? Like what can they do? Maybe like build a framework, a policy to find the balance between the benefit and the downside of AI?
Right. So companies, they really want to utilize AI, but what Susan was mentioning about, there are some problems with the AI model, right? Something about hallucination. Your AI, they are trained from the data they read a lot from the URL, from the internet. They also have read the romantic novel, right? So they read pretty much everything. So if you ask the question, it might give you something that, based on what it has learned, the data it has learned, give you the next word, what it's supposed to say, right? What it thinks the highest probability that you want to hear. So that create a problem. So we really have to make sure that, all I'll say the administrators or people, the employees, they are going to be using AI. They are trained on understanding what is the AI technology, generative AI for the system administrators understand the fundamentals of AI, generative AI, for example, right? How do you train the data? What is the train? And also, kind of what Susan was mentioning about, if you are using an AI model, who actually trained the AI model, right? Because the employer of this AI model, they are the one that controlling the rules. What is going to show you, what they are not. Microsoft, pick on Microsoft, but Google, okay. If you ask something about, give me a story that's not appropriate for children, right? How do you build a bomb? Bart may be able to actually give you the list. Hey, here's how you actually build a bomb. But that's not really aligned with what Google's really want to say, right? So Google, maybe one day they will censor some of this information. So one day when you are asking these AI, they're not going to give it to you, right? So what I'm trying to say is that you really have to understand the fundamental of AI when you're employing or putting this generated AI into your software. You understand what you are going to get or how you're going to train the model to be able to generate something that you're aligned with your expectation, right? Not just with the users of their expectation. And also from when you are doing the security, safety, you have to understand, if I'm a medical device company that's building something with a software that put into, say, pacemaker, there's going to be a security, safety implication into the software that is putting to the patient's heart, right? So there's going to be a safety issue that you really have to think about. So policy, in terms of the government policy, they really should put some kind of policy to govern, regulate the AI, safety and risk. However, they probably should not put on too much regulations to impede with the AI development. So that's kind of my opinion here.
All right. Microsoft. So, Google. Let me just try to share my thoughts generically. I'm a personal believer, and in this case, I think the company I work for happened to have that mission and that principle very tightly integrated into our culture, is that the producer of software and products and AI features should always strive to implement foundational cybersecurity hygiene as well as best practices and make it easy for our users and customers to do so. Unfortunately, no companies in the world is immune to cyber attack or breaches. And I think as a consumer or as someone who's using all these technologies, the thing I'm looking for is, and the thing I'm going to as an individual place an expectation and influence the society and my community to place an expectation to tech companies is the promotion of transparency. Going back to Jeffrey, your original question is, how do I make sure, what consideration should I have when my company is trying to procure some AI products? And Susan was earlier on kind of referencing, well, some of the elements in my solution set may be going end of life, etc. The dependency, software component dependency, that problem is not new, right? And I think going back to some of the best practices or secure by design or life cycle product and service practices for security that we have today already, for example, asset inventory, right? Inventory your AI model, build your model registry, build your feature store, right? And also build your software bill of material for your AI systems. And I think many companies decades back have already started looking at bill of material. They probably require legal approval, procurement approval when they look at procuring different components to be embedded into their system for reasons precisely around end of life and also export control concern, security concern, and different geopolitical concerns as well. So again, going back to that foundational practice that we have collectively as a society, as an industry, cybersecurity profession, accumulated over the past decades, right? Let's continue to expand and adjust those cybersecurity framework and practices and processes to make them AI ML aware. And as AI and ML continue to be more and more integrated with software development, that is where we'll have a lot of opportunities to learn and to feed those learning back to the tools and processes and continue to share that, mature that as a society or a group.
Okay, thank you guys for sharing. We only have a few minutes left, and we want to open the opportunity to any audience who have any questions for our speakers. No one? Oh, yep. One in the middle.
Are you asking about the convergence? Is there more convergence of like privacy and data security needs or with security or? It's actually a phenomenal question because they are increasingly becoming the same from a technical perspective. So typically what I've seen at companies is the data privacy, data protection officer, the privacy, they're more legal minds that come to security on how do they piggyback on security's processes and technologies for privacy reasons. And there's also the rising trend of a chief trust officer, which is really looking at how does a customer trust a company's products in the US, security and privacy and reliability are up there. I think with AI and a lot of what Kyle and Betty have been mentioning is also integrity of the data. How do you know the data that is coming out? How do you know that the data that's feeding the model is something that can be trusted? Are there trust scores for data sets? How do we know that's not been compromised? So in terms of the types of technology that can help us start to decipher, they are just much more advanced in the cybersecurity suite. So I do think that increasingly so, this is an opportunity for security leaders and security industry to play a larger role in not just, I guess, traditional cybersecurity, but in this broader realm of trust, right? There's, Salesforce, Atlassian, ION, others where CISOs are now becoming chief trust officers that run security divisions. There are security teams that have privacy engineering. Our org at Uber had a whole privacy engineering department as well. So at least from my perspective, yes, that it is internally within a company, it does tend to be viewed together increasingly so just from a technology point.
Just very quick, this is a really good question, and the company really have to understand what kind of data they are receiving, what kind of data they want to protect first before you design the process to protect these data, because you want to understand what is the scope, right? And so that is first thing is to do a data asset inventory, understand what you want to protect, and then design the process to protect them.
Okay, we are running up on time. So thank you guys for joining, and thank you everyone here for listening. And I personally learned a lot.
Thank you, everyone.
Thank you, Jeffrey.
Thank you.
So we are currently checking the mics and they will come back soon, but I just want to thank the Cybersecurity Forum speakers for such an informative session. I definitely want to change my password right after the Taiwanese Tech Summit. And I encourage all of you guys to do that too. And now we are going to have our last forum of today, the Generative AI Forum. So we are really looking forward to that. And we will get the mics to all of you shortly. I will provide one mic first. Here you go.
All right, so in the interest of time, I'll just start with quick introductions. So today, very, very glad to have going to be a fun discussion with Wuxi here to talk about content creation in the new age of generative AI. So I think this is a top of mind in people's minds since last November when ChatGPT first came out, to be very frank. Even though I've been in the tech industry for 16, 17 years, I was quite surprised about that the moment when I felt that Turing test for the very first time has passed, right? So So very, very surprised, and today very, very glad to have a chance to have a chat with Wuxi, a generative AI expert, here to talk about different kind of generative AI. So a quick introduction about myself. I'm Harrison Tang. I'm the co-founder and CEO of Spokeo. So we are one of the biggest people search identity platform in the United States that serves about 15 million users a month to help them search, connect, and verify, know who they're dealing with. I'm also the co-chair of W3C CCG that incubates standards such as verifiable credentials, decentralized identifiers, and Web3 ID. And today I represent Southern California Mount Jade, 南加玉山科技协会. I'm the chairman at Southern California Mount Jade, and I'm one of the co-organizers for this event. So very, very glad to be here. And Wuxi, do you mind quickly introduce yourself to the audience?
Thank you, Harrison. So my name is Wuxi. So it's an honor to come to the Taiwan Tech Summit. I'm based in Boston and been traveling back and forth, and very first time joining this big event, and especially talking about generative AI. So I'm the RD lead at the Firework. So our company do short video, shoppable video, and live stream as a SaaS for business. So in short, we try to help our client to win the attention war by serving video. Okay, so I think most of the client agree that, okay, right now when we have a page and then something right there is moving, then the user cannot stop noticing that, this video will just, engage the user better and retain them and help them convert. But then the question always comes to, where do the content come from? So many clients tell us that we would love to be your client, we like to use your product, but we don't have content. What do we do? So that comes to my job, so having the content generation using AI technology, especially creating short form video. However, so speaking of generative AI, so actually my beginning is a very, very different perspective from video because I'm a music technologist. Okay, so when I'm still in college, I remember that I started working on signal processing, and then I'm a musician, so I want to solve one very, very, very difficult problem, which is we have a ensemble. So we have piano, violin, cello playing the note at the same time, but we only got this recording. Can we separate the sound? And I said that that's not possible because we already have information loss. So initially you have 3 soundtracks, but the output is 1 soundtrack. So you cannot recover that back to 3 soundtracks unless you can boost lots of information. Okay, so somehow, if you look at what generative AI is all about right now, this is what we are doing. So, and then the other also fun initiative, like when I first think about all this generative AI is, so I'm a musician, so I have a very strong passion in creating music and all that. But then there is a research area called the meta composition. So you create a computer program to create music. Okay, so
like AutoGPT, basically, right?
Yeah. So right now we finally recognize things like that. But at that time, this is like a sidetrack in the computer music area because who is going to recognize those music? Because you create a program to create music, do you still qualify as the creator of the music? So it seems to be somewhat philosophical. But 20 years ago, we were talking about that. One day, we will have this AI that has the emergent ability, and I realized that wow. So I'm already witnessing something we talked about 20 years ago.
So I think that's start from the beginning. like, how do you define AI, artificial intelligence, and what is generative AI, and how is today's generative AI differ from 20 years ago or predictive analytics?
Yeah, so I would say that, first of all, it's very hard to, sit anywhere to talk about just AI or generative AI because this is such a large area and I feel like that what I'm doing is actually a small corner, and especially in the video and music domain, but then the whole development, we've been seeing the explosions first by the Stable Diffusion mid-journey, it happened last year. And then, of course, ChatGPT blowing our, project pipeline away because, our founder basically said that, okay, forget about everything we're doing, because right now we need to watch this. And if we don't start thinking about this, then, ChatGPT is going to change. It's going to replace our product, basically. Okay,
so before you were using other models and you have to change the GPT.
Yeah. So remember, like we actually have exactly the same project that I will show briefly later. That we try to have a content generation tool so that it processes a web page. Okay, and then we specifically train that. Okay, here is the crawler. Here is the summarizer, and then some of the summarizer is going to recognize what is the category for this product and what is the targets and all that. And it's a very hard to build product. But when ChatGPT is announced, and then realize that okay, we just need one large language model, and then everything begin from there. So everything changed from that point.
So that's the big difference between 20 years ago and today? Is just the amount of data? Is that what it is?
Yeah, so I mentioned that 20 years ago we would talk about this immersion. So the immersion says that, we sometimes think that, okay, computer is able to repeat some pattern, but that doesn't qualify as intelligence. So that's almost the same thing like when a computer creates music, you still don't call computer a composer because you don't give credit of its creativity. We think that our computer is only, repeating some pattern without insight. Okay, but now when we talk about immersion, it's some after feeding a large volumes of data, after spending a large volume of computation power to train, then there is some high-level intelligence that emerge that we can even give credit that this is novel, this is creative, this is fun. And then, because the people are talking like ChatGPT even can tell a joke or it can recognize a joke. It's so hard to imagine. Like
I think their joke is funnier than mine, actually.
Yeah. So because we can debate, for the next, until the end of the session, like, so what, is ChatGPT a funny bot and all that, but when it comes to the time that we are all talking about this, we know that, okay, so now, they say that it's past the singularity, that, the AI's intelligence in next level. But if you only look at how we train model, the neural network, so many AI researchers think that they're just doing pretty much the same thing, except that right now there's explosive of the amount of data we throw in, as well as the pervasiveness, the accessibility of all the GPU and all that make it all possible. And we think that it really happened faster than I initially expect, because I thought that I'm never going to witness that, music source separation to be realized, because I thought that that's just impossible.
Yeah. So today, I think you have prepare a couple of use cases about how different generative AI models can actually help our workflows and productivities and businesses. So do you mind kind of share a couple? Yeah.
Yeah, sure. Yeah. So I think, so the very, very first case study I want to show, ChatGPT. Okay, so how we start to integrate ChatGPT in every aspect, and then there's one specific thing I want to talk about is prompt engineering. Okay, so one of the feature that in using a large language model is that in the past, the training go like you have a full set of training data, and then at the end of the training, you try to validate that whether the training turned into something you want. Okay, but right now we call this is the in-context learning. Like the ChatGPT already learned from large volumes of data that it collects from the internet, but then it is still learning as you give prompt. Okay, so exactly the prompt is like you can specify the specific way that you need from this task. No matter if it's, say, Stable Diffusion is creating image, or to here, this is all about creating video content. Okay, so in this case study, we present a content generation tool that we initially convert web page to a short form video. So let's see the workflow. So the workflow feel like that, oh, this is something like a useful tool. So you don't feel the AI just yet. Okay, but now we have a web page. You put the URL to the system. You say that this is a product. Potentially you can select digital human or TTS. Okay, but now so the GPT already generates some summarization from the product and all that, and you can open a whole project. So the project give some copywriting, something befitting to serve certain target audience and all that. Okay, so the prompt engineering come in this part that, so when we are able to make one video, we don't stop here. We start thinking, how can we make 100 different version video for just 100 different target audience group? For example, you can specify in the prompt that, okay, so here, this target audience, please separate 3 different versions, one for the new customers and the other for loyal customer, and the third group is the somewhat return customer, but seems that they are, forgetting about us. So how do we distinguish the writing? But then I prepare a more intriguing example. So can you go to the next page? Okay, so go to the next page. That so 2 months ago, I brought this video generation engine to a Taiwanese hackathon. Okay, so we basically want to solve a problem that how do we make, sorry, can we go to the next slide instead? Yeah.
So let's kind of go into a little bit of details about how this works. So basically the large language models, well, first of all, you grab the web page content, right? HTML, CSS, those things, and then you use large language models to understand the content. And then you have another model that converts those concepts into video. Is that correct?
Yeah, yeah. So we have an engine that try to take the writing and try to take the image and add animation into and packing into a video. Okay, but then the AI part usually come in the middle. Like, okay, so first of all, how do we generate an image? How do we find a right video structure? But right here we're focusing on using ChatGPT to do a very context-aware copywriting. Yeah. So
can you explain what that context awareness means?
Yeah. So for example, so if we go to the next slide, so I joined this event, US-Taiwan Watch Conference 2 months ago, and then do this special, like now I consider a case study. Okay, so how can we rewrite a news into different forms so that when people of different political view or different political sensitivity, that they can find a way to digest a news that we feel like important. For example, okay, go to the next slide. So here, I found a news from the reporter. So it's in Chinese, but basically it says something about the Hong Kong security law and how that affects some Taiwanese scholar who is doing research related or not related to China, but somehow they get into trouble. Okay, so if we just use a typical summarizer, you can see from the next page. So this is a typical ChatGPT prompt that we say that, okay, we have an internet news. Can you convert the news content to a short form video? And I'm going to use speech for storytelling with an eye-catching title, so very, very general. So what you get is the next page. So from the, next page. So it looked like this. Okay, so can I safely visit Hong Kong? And then Taiwanese political security in Hong Kong and the law and the pressure, and all that. Okay, so now the problem comes, like when I try to send this video to maybe, all the line group my parent will visit, they're like, oh, we don't want to talk politics, this is, sensitive, and there are many people in Taiwan that, we thought that we are in deep danger in terms of the misinformation war and all that, but somehow we cannot find a good way to sort of wrap this news in a friendly way so that the senior generation can also digest this news. Okay, so let's go into the next page. So we rewrite the prompt in a totally different way. We say that, okay, so forget about criticizing China, forget about, politics. Let's appeal to the compassion because Taiwanese is full of love. They love positive news. And then we have this joke of 长辈图 that they usually greet each other with good morning and with something, a lot of flower and say that, hey, let me tell you a story. Okay, so now I rewrite this ChatGPT prompt like this. I say that, okay, let's appeal to compassion, no criticism, and keep it short. Okay, so the result is the next video. Let's take a look. So remember, every single word in this video is without revision. So ChatGPT create this video. Okay, next.
早安，美好的一天，先听个故事好吗？在这个现在，我们关注的是台湾学者在香港所面临的困境。他们是那些长期往来香港，且研究领域与政治无关的学者。不久前，其中一位学者被港警带进小黑屋，并遭到政治询问。这不是个案，事实上，过去2年已有数名台湾学者经历类似的审问。这些学者中，包括一些年轻学者。他们不是民主运动的领袖，却也遭受到相同对待。目前我们无法确定台湾人在香港遭遇政治扣留的频率，以及港警对高风险目标的定义。这些情况给台湾学界带来压力，也影响到学术交流活动。
Yeah, so so the video is creating in the Mandarin Chinese, but basically it's trying to use a very alternative way to say that, okay, this Taiwanese scholar is not even a researcher for the political field, but somehow they're caught in the tension between China and Taiwan. And then we're able to just use a ChatGPT. We tell them that we appeal to compassion. And then ChatGPT actually found a way to say that they are not doing political work. And then they are not even, anything of a social activism and all that.
Yeah. No, I think it's very clear that, ChatGPT writes better than my 9-year-old son. So how does this work? Like, how does large language models understand? What does understand means? And what's intelligence or what's reasoning? Like, I know this is a subject to debate and there's a lot of different thoughts out there, but what's your thoughts on this?
Yeah, so I'm not an expert specifically about the large language model. but then the key is that how do you relate? How do you generalize when you say that, okay, I want to appeal to compassion, but I didn't say that we don't want to talk about politics. Okay, but then ChatGPT found a way to interpret that, okay, so maybe what make it become sensitive is because criticism, or what make it sensitive is that they understand that they are not promoting democracy, but somehow they are treated as somewhere in between. So I don't think this is a good explanation, but so it's about that the large language model quickly pick up this prompt and then are able to adapt and generalize into something that they found data in the past, a large language model. So for us, we're the user. Okay, so if you want to ask me why, I don't know. Okay, but then I'll tell you that, okay, I keep trying, and then right now there's the new job title that the prompt engineer is actually a job. Okay, so you can be really talented to make ChatGPT do what you want them to do. Yeah, and it's becoming an art right now.
Yeah, yeah. Well, I personally still like to believe that human neurons is more complicated than some kind of some kind of simple linear function, right, in the artificial neuron. So I like to tell myself that because I'm quite surprised by the advance of AI, and I hope there's still some futures in humanity, to be very frank. Now, we've seen the ChatGPT example, but there's a lot more generative AIs and different modalities. So I think you also have another example for the videos, right? So do you mind sharing that?
Yeah, so I think that this is coming a step back from going text and video and image. So when I say that at the very beginning, I saw that the sound source separation is a problem never going to be solved. And right now we know that, okay, when we have some missing information, our brain actually does it naturally. Okay, so our vision system actually always have this blind spot. The blind spot is like caught in between your eye, but then your brain tell you that no, there is no blind spot. So the difference is that your brain feel the information for you, so that you hardly feel that your vision system give you any discontinuity in the surround vision. Okay, so right now many people are using the magic eraser from their phone. Okay, so when you are taking a picture and then you feel like, there are too many tourists in this beautiful temple, in this beautiful place, and you can just circle them and erase them. How are we going to do that? Because we tell the computer that, okay, this part is missing. Can you use your sense to recover it? So you basically remove some part from your camera, and then you'll be able to wipe them out and let the AI to fix it for you. Okay. And here, this is an immersive video watching experience that I did in my company. And then we can use it as an example. Like, so sometimes the generative AI not necessary is directly touching stable diffusion or large language model. Okay, so go to the next slide. So into the next slide. So this case study is an immersive video experience for mobile using a standard landscape video. Okay. So the key is, so the experience somewhat look like this. Okay. So you can rotate your phone as if this is your VR gear. Okay. But then many of the immersive video experience, you need to specially produce the content in a special way, such as creating a 360 VR scene and all that. But here, this is just a landscape video. So how are we going to do that? So going to the next slide. So we can simulate that, okay, now you're holding a viewport. The viewport can be held in different directions. So when you are rotating your viewport, there will be some part that the viewport is temporarily stretching beyond where you have pixel. So now we ask the system to patch the missing pixel for you, just like that the user are using the magic eraser right now. However, when you are using magic eraser, we call that the inpainting. Inpainting means that you have an information canvas, but somewhere in the middle is missing. But now here we call this, this is an exportation, because what the information is missing is going to the side. Okay, so many people in the VR area will need this kind of thing. So let's see a closer look to the next slide. Next slide, please. So you can play this video. I hope that, I can use my phone to demonstrate this, because this is not the best demonstration. But if you can look at this experience from your phone, you will be amazed by that, how it stretches as if that you are moving closer and farther away from the view. Yeah, so, and then you hardly notice anything from the side that the system restored a bit.
But what if there's a bird, right, on the top left corner? There's a
so
what happens in that case?
If you have experience using the magic eraser, you actually screw up most of the, maybe half of the time, and then you're like, okay, maybe this time you need to redo it a few times, and sometimes the system can create different things, and sometimes it will force you to remove the entire bird, or in that case, probably need some prompt engineering to be specific, like you actually want more bird rather than no bird, things like that.
Got it. So this is a very cool technology. Is this model works just like large language models, or is it completely different? How does it work?
Yeah, so in this context that we don't use a large language model to distinguish the context, how we want the pixel to be restored. Okay, so this is more like a classic, like, so it's also involved a lot of training, because basically the computer is just picking up from the pattern. Okay, so usually when you see this, then the surrounding is what, and then they try to use this general sense to brush it up the area that you wanted to restore. Okay, so it doesn't involve a prompt in this context.
Got it. So I know you also have another example, one last example that combines different modalities together, right? With a digital human. Do you mind going to that a little bit?
Yeah, so digital human is, in a way that right now we are talking the digital human under the generative AI scope, but actually, the VR people, the metaverse research, there are many involvement about how do we create a human from scratch. Okay, so but then because of deepfake, because of so right now there are more model that is not discussed in the VR scope, but discussed in the Gen AI scope. So you feel like that the Gen AI is taking away digital human from VR into this world. But then we can also see many different difference in terms of when do we want someone to tell a story for you, for your product, or maybe when do we want a digital human to sell a product for you? Okay, so in this case study, we are looking at the AI virtual assistant in the e-commerce context. So first of all, we'll look at a short video. Next slide, please. So this video is
柔らかな肌触りのトップスをご紹介します。平安時代以降、公家が清掃する際身につけた下着。大片びらをモチーフにデザインしました。生地は尾張地帯一帯で織られる形状年間より続く下木綿手ぬぐい生地を使用し、氷型友禅で染色を施しています。手ぬぐいの幅を生かして縫製し、襟に薄い中綿を入れております。
Okay, so in this example, this is a short form video automatically generated from a web page. So is our client, and then we create this demo video that, okay, we have someone talking. Okay, so the first question is, then why do we need this digital human here? Because it feels like kind of weird. So we use an avatar like this to speak Japanese. It's weird to begin with. But then, so in the world of short form video, so how do we provide this embedded video service to win the attention war? Everything is measured by two metrics. One is engagement. How long do we retain the user here? Okay. The second metric is conversion. How many people watch this video and try to place this product in your cart? Okay. So one obvious fact that we know that when the video is played on mute, comparing to when you play this video with the sound on, so the engagement is differed by a huge margin. Okay. So in this context, the clear advantage of having a digital human is it reminds the user that, oh, I want to hear what she is talking about. Okay, so you are seeing someone moving their mouse but not hearing it. Your brain will tell you that, okay, I'm curious now. I want to hear that. Okay, so this digital human in this short form video context is drawing the curiosity because we are used to a talking person should come with the speech. And then the next example, going into the next slide, we take that to a digital store. So when you walk into a store to buy product, you will be greeted by the sales associate. So someone, they ask you, do you have any question? Do you want me to show you what is the latest product and all that? But when you visit an online store, maybe sometimes you have questions, but you cannot find anyone. Okay, so this is an example that we use digital human to create this virtual assistant for you, for any user, anytime. Next slide, please. It's still the same avatar. Okay, so supposedly this is a speech interaction.
Here are the 5 different colors and how they look applied on skin. First up, we have always an SCN. It's perfect for those sultry evenings when you want to make a statement. Next, we're moving on to the next. This shade is all about versatility and confidence. Now,
okay, so the middle part is cut to make this a little shorter, but then
yes, you can layer powder eyeshadows on top of the matte liquid eyeshadow to create unique looks and add dimension.
Does it change like different avatars? Because like, for example, I like Asian women better, right? Does it automatically change that?
Yeah, so obviously we do want to, accommodate any client's wish. Okay, so supposedly we should not only enable the user, the client to select different avatar, but also they can let different users to see any avatar they like. Because that will ensure the best engagement, right? Okay, so some explanation of this very short video is that this is almost real time. So the user is talking to this digital human almost like a real life conversation. So right now it takes about only 4 seconds from you speak, we process to we render this digital human for you. And then of the 4 seconds, actually more than half of the time is spent by the large language model. So creating this digital human and ensure that it lip sync with the text to speech is only taking about a second and not 2 seconds.
So what models are involved here, right? You mentioned large language model, there's a visual model, and there's the lip sync model. Like, what other models are involved?
Yeah, so lip sync model is one of it, and in this context, we try to not do the face resolution. So the resolution is again what we talk about, like how do we use AI to fix missing information? Because lip sync is basically based on we use the machine to generate a lip sync version of this avatar, and then we try to patch that part of video to the original avatar. Okay, so when you simply do that, then you will see something weird on the edge when you patch the video. Okay, so the face resolution make it look like, oh, okay, so I'm convinced. I think that she says all this. And the large language model is involved to process what the user is asking. Okay, so this is a pure conversational experience, meaning that the user is not typing, the user is speaking. And then, so we pick up the text by speech recognition and throw everything to our large language model. And the large language model already get what this product is about. And then it has like a knowledge base, everything a sales associate need to know about this product is already pre-trained. Okay, so at this stage, the large language model responds with something. Maybe this is from an existing video bank. Maybe this is not from the video bank that we need to live render. And then we go to, when it comes to the live render, we need to go to using the lip sync model, and then we need to face restore, and that's what you see.
Now, what's the cost involved? Because, like, for example, OpenAI API, right? If you want to use the GTP 3.5 or 4 models, I mean, it costs like a couple cents, right, per prompt. And if you're doing a lot of prompts here, that can be quite expensive, especially per view, right?
Yeah, exactly. This is an excellent question because people will ask, like, so why do we even need a digital human here? Because it's maybe this avatar is good looking, but then how far does it take you away from a chatbot? Because you can also add chatbot question, right? And then from chatbot to voice agent like Siri, Alexa, Hey Google, I hope I don't trigger any of your phone, and to this digital human, seeing this face, does it justify the cost? Okay, so speaking about the cost, so what we know is, so when we are doing face resolution, we probably need to spend like 12 times more GPU cost than just doing a lip sync. Okay, and right now, say rendering a minute of this with face resolution can cost $2 to $3 US. Okay, so this is steep. If we say that, okay, every user who log into this system and want to talk to this person is going to burn $2 from a company every minute, then I don't think we can sell this product at all. Okay, unless we find a perfect reason that digital human actually work. Digital human boosts the sales so much. Okay, so then a lot of effort right now. Of course, right now all the unlimited spending of the GPU obviously is making some of the company's stock price going really, really high. But then at the end of the day, we are thinking like, wait, do we really need a digital human? Because obviously this is a cool demo. Our CEO bring this demo right now and present to our biggest investor, SoftBank, and they love it so much. They probably want us to double down on this. But then we're like, yes, Gen AI is the hottest topic for the investor's point of view. But then, is this what our user need? Is this what our client and user need? Is a different question.
Cool. I think we have about 9 minutes, and we want to leave the some time for the audience questions if there are any. But I want to ask a hard question because these models, they're all separate, right? Most of them using supervised learning. But there's always this talk about artificial general intelligence. Do you actually believe in that? Do you think you can create one universal model that actually rule them all, or you think that's a pipe dream?
So I think at the very, when I went to MIT, that's 17 years ago, to me, the hardest AI problem is common sense. They said that how do we use AI to create common sense? And then common sense goes a long way. So right now, like even for human, my wife will think that, I don't have common sense in many aspects, so AI.
Well, common sense is personalized. Next time you should tell her that.
Okay. Yeah. So we talk about like, to what level do we start to give credit that this is intelligent, or this is insight, or this is novelty? And right now, many people still criticize that all the knowledge, all the witty reaction from ChatGPT doesn't qualify as the same way as a human intelligence is. And then I really have no answer for that because in a way that I don't need to define whether that is intelligent or not, or I don't need to define what is, whether the general intelligence can happen. What I need is that, okay, ChatGPT is already transforming the way we work. It's like our partner. Okay, so we work with this. Either it's a virtual assistant of you, virtual coding assistant, or as a composer, maybe I can work with AI as a partner that we co-create song together. And I think that is beyond like asking like whether this is intelligent or not, or whether AI will eventually make it, because I think that we are already witnessing something really, really special, something I didn't believe that would happen 20 years ago.
Yeah, I know. I think if you look at the Wikipedia definition of intelligence, it's about practical application of knowledge. And the truth is, for the longest time, the definition of intelligence is about the Turing test, right? Which is a blind test. Whether if you kind of like a Pepsi and Coke, you do a blind test. If you cannot tell the difference between the AI-generated response and the human response, then that's the intelligence. And I personally think that definition needs to change because ChatGPT has passed the Turing test, and the truth is, I still felt that we are probably, us human intelligence more than that, because obviously we have logic, we have reasoning that a lot of these large language models don't have. So maybe it's just me hoping that there's some hope in humanity. Maybe it's wishful thinking, but I personally think that the definition of intelligence probably have to change at up level. All right. Any questions from the audience? No? If so, I'm going to ask Ushi even more questions. So we talk about content generations and things like that, right? So one question that a lot of people have is about fake news, misinformation, disinformation, malinformation. And by the way, the definition of misinformation is incorrect information, right? Regardless of intent. Malinformation is correct information with malintent, and disinformation is both incorrect and malintent. So my question is, how do we actually tell misinformation and disinformation, fake news in the new age of generative AI when content creation with generative AI becomes so easy?
Yeah, so in a way that right now we have a lot of need at school to examine that whether students' paper or thesis is purely written by ChatGPT. So then there is the counter GPT tool to tell you that, okay, I think it's I forgot what is the service. There are multiple services to help you determine whether a writing is generated by ChatGPT. And as far as I know, Google, if you're a marketer, you will know this kind of thing, that if you use too much ChatGPT's help to create some of your writing, so Google actually detect that and will lower the exposure for this information piece. So I think that also go to the other part, like not just the misinformation, because now we can create a digital human. Then there will be people trying to create, use it in a scam. Like, there's the old school scam, like someone pretending your kids are in trouble, your parents in trouble, and then right now they can easily render someone just almost look like your kids or your parents. And what do you do? And how do you distinguish that? Oh, okay, this is just a scam. This is not real. I know that, Harrison's expert is more on the security side. I think this is going back to you, that, how do we avoid a misuse of information of this kind, so that we don't have more and more scam that, make people fall into the trap because of using digital human.
Yeah, like one easy thing I do, like for example, I have a Taiwanese American team member, and for the longest time, like his English always lack commas and like has grammar errors, and all of a sudden it's all perfect. I was like, man, something's happening right here. So that's an easy litmus test right there. But I think the question of truth is actually quite interesting, because what is true, right? True represents reality, and what is reality? And the truth is, I think reality is high dimensional. And to test high dimensionality, you need criteria, because we do not have a full picture of all the features and dimensionality in the world. Like a good example, that's a very physics question, answer to this question. But a good example is we humans can only experience X, Y, Z, and half of time dimension. And the truth is, the reality is a lot more than that, right? Because, for example, weight is a dimension. Financial score, like your credit score, is a dimension, right? So that is something we cannot experience. So to tell truth, I think there needs to be multiple criteria. And you have to have consistency, like blockchain, for example, right? More than 50% majority rule is true. If you think about it, when you transact something, how in the world does this node running in like Iceland know that's true or not? It doesn't. It doesn't. It's the fact that 50% of the node says it's true, then it becomes true. So that's consistency, it's authority, it's correspondence. Does it correspond to the real world? Like in identity, there's a question called authentication, which is the linkage between digital world and the physical world. That's correspondence and coherence. There's a lot of criteria, and the truth is, it's a very, very complicated problem. You had to think really hard about that.
Yeah, so it came to me that, last week, our marketing department called a meeting with us and said that he tried to show me the prompt on ChatGPT, said that, can you create a marketing report that doesn't look like ChatGPT? So you write it in the prompt to tell ChatGPT to write not like ChatGPT, and I don't really know what this is. But
I think now we only have a minute. I just want to conclude. I do think that there's going to be a wealth of information out there, and our society, due to the revolution of recommendation engine in the past decade, which by the way is a kind of information filtering system, has made our society a lot more polarized, a lot more segmented. In marketing, there is a model that a lot of people like called STP, segment target positioning. But maybe, just maybe, we do it too well that creates this dichotomy in our society. And I think one of the things I do want to leave everyone with is perhaps we should all be open-minded about different informations out there so that we do not let technology, right, harnesses us, but rather us harnessing technology. Do you have any conclusions?
Yeah, I think that's a perfect conclusion. Yeah. So it's a pleasure that today Harrison and I go through many aspects of generative AI. So thank you.
Thanks a lot. Sarah?
Thank you, Wuxi and Harrison, for a fantastic forum on generative AI. That was very thought-provoking and very informative. And that was our last forum. And with that said, the Taiwan Tech Summit 2023 Next Vision has come to an end. Thank you so much to all of our co-organizers, our sponsors, our volunteers, moderators, speakers, guests, everyone here and online for an amazing Taiwan Tech Summit, and we will see you next year. Thank you.